please subscribe to the Edureka YouTube channel and hit the bell icon to never miss an update. Also, if you're interested in learning Java from scratch, do check out Edureka's Java certification training. So without any further delay, let's get started with today's agenda. So we'll start today's session by understanding how to set up Eclipse IDE on Windows, where we will see how to install Java, then how to set up Eclipse IDE, and end it with a project on Eclipse IDE with Hello World program. Next, we will talk about Introduction to Java, where we will learn how Java works, the modifiers used in Java, where we'll have access control modifiers and non-access modifiers. Up next, we'll talk about variables and data types in Java, where we will learn about operators, control statements, and methods used in Java. We'll also learn classes, objects, and OOPS concept in Java, followed by exception handling in Java, where we will talk about exception handling in blocks. Then we'll go through a hands-on demo with exception handling using try-catch blocks, and then we'll see why to use throw keywords and the difference between throw and throws, and finally user-defined exceptions using throws. Next, we will talk about Java projects for beginners, where we will see how to create a software for ATM machine using Java, and then how to create a text editor using Java, and thirdly, how you can create a sign-up form in Java. Finally, we will end the session with a few interview questions on basic Java, then some questions on OOPS, followed by servlets, JDBC, Spring, and Hibernate. So stick around till the end and you will learn everything about Java in this full course video from Edureka.
So let's start with installation of Java. So to install Java, what you initially have to do is you have to go to the Java's download page, right? So let me open my Java's download pages and let's search for Java download on Google, right? You see I've already got a link of Oracle, right? Basically, this is the page that you have to go to download Java. It's an Oracle official website from which you can download Java. So in the overview page, you basically get the complete overview of Java, like, what's new in Java, if any old versions are updated, which Java version is compatible to what, and so on, right? So if I go to the downloads page now, this is where you can basically download Java from. So in this session, I'm going to download Java 8. So to download Java 8, this is the basic link. That is, you have to go to Java SE 8U211 or 8U212, right? So I'll go to JDK download. So I'll just click on that download option, and then you'll be redirected to this particular page. So once you're redirected to this particular page, what you have to do is you have to initially accept the license agreement, and then you have to choose your download version, right? So your download version will be basically based on your system configuration. So mine is Windows 64, so I'll go for the Windows 64 one. Else, if you're downloading Java on Linux or Mac OS or Solaris, or maybe different versions of it, like 32-bit, 64-bit, and so on, you have to download Java based on those versions, right? So here I'll just click on the Windows 64-bit, and then what you'll see is basically that you'll be redirected to Oracle login page, right? So since I've already created an account of mine, I don't have to create an account. Else, if you don't have an Oracle account, what you have to do is create your account first, and then you have to go back and download the Java version, right? So since I have already my account created, I'm going to just use this account, and then I'm going to just click on sign in. So once I click on sign in, you can clearly see that Java is getting installed into my system. So let's wait for that to happen. So as you can see, Java has got installed into my system. Now what you have to do is you just have to double click on this installer so that you start installing Java. But before that, let me just go back to my downloads to make it clear for you. So if I go to my downloads, you can clearly see that my Java has got installed, right? So if I double click over here, what you'll see is basically Java will start getting installed, right? So let's wait for it to react. All right. So it says, the wizard will guide you through the installation process and so on. So basically that's what you'll see. Once you click on that option to install Java, basically on your installer, when you double click, you'll see this wizard coming up. So I'll just click on next over here. And then you can see that, the wizard has started to install Java. So just keep clicking next so that, Java gets installed. Now, once you click on next, what you have to do is you can just basically choose the folder where you want to install Java. I'm going to let the folder be the same. So basically I'm going to install Java to C, program files, Java, and the JRE, right? So then I'll click on next. Once you click on next, you'll basically see that, Java is getting installed, right? So let's wait for that to happen. So once it gets installed, you will see a final wizard which says Java SE Development Kit 8, so on, has successfully installed, right? So next, you can just click on either next steps or close. After that, you can either click on next steps or close. So if you click on next steps, basically you can access the tutorials, API documentation, developer guides, and so on. So I'll just click on close over here. And then what I'll do is I'll go to my command prompt. And then let's say, we come to the C folder, basically a C directory. And let's say we type in Java-version. So when I type in Java-version, you can clearly see that, the Java version which is installed into our systems version is shown over here, right? That's basically 1.8. That is basically Java 8. So guys, that's how basically you can install Java. Now, once you have installed Java, you can go forward and set up your Eclipse ID. So let me show you the same, how you can set up your Eclipse ID on Windows 10. So to set up your Eclipse ID, what you can do is you can just type on Eclipse download. You can go over here and then you can choose Eclipse ID for Java developers, right? So if you just click on this link, so over here, you'll see that, the package was released in 2017. A new package is available, right? So let's just go for that, the newer version. And then over here, let's choose our Eclipse version, right? So over here, again, I'm going to go for Windows 64-bit. Well, you can definitely go for Mac OS and Linux based on your OS kernels that you're using, right? Since I'm using Windows 64, I'm going to go for that. So I'm going to click over here. And then once you click over here, you'll be redirected to this particular page, which says that, you're going to download the Philippines version. So just click on download over here. And once you click on download, you'll automatically see that the Eclipse ID zip file is getting downloaded, right? So let's wait for that to happen over again. So until Eclipse ID is getting downloaded, let me tell you one thing over here that, I have downloaded Eclipse ID for the Java developers, right? That's because, I'm going to show you how you can run a simple Java program using Eclipse. Well, you can use Eclipse ID for complex projects like Spring Boot framework projects, Spring projects, and you also have Eclipse for other languages like, C, C++, and so on. If you're further interested how you can, use Eclipse ID for Spring Tool Suite, basically for your Spring Boot projects, you can refer to my video on Spring Tool Suite. So I'll leave the video link in the description box below. Also, apart from this, if you wish to learn about the top trending technologies and you wish to enhance your technical skills, you can go forward and subscribe to our Edureka YouTube channel to get daily notified on the top trending technologies and then enhance your skills as you want. So as you can see on my screen, the Eclipse ID has got downloaded. So basically the zip file has got downloaded. Now what you have to do is you have to extract the zip file. So I'll go back to my downloads, right click over here, go to extract all, and then I'll choose the destination folder, right? So let's go to browse and let's say, I put it in program files, and then I'll click on select folder. Basically what I'm doing over here is basically I'm extracting the zip folder into my program files. Now once I click on extract, let's just give the permissions. And then once I click on extract, you'll see that, automatically the files are getting extracted from the zip folder. So over here, guys, remember the fact that, it doesn't matter which folder that you want to extract for, because the root folder remains Eclipse wherever you extract the folder, right? So once you'll see that, the items are extracted, you'll clearly see that, automatically an Eclipse folder is formed into our program files from where you can launch your Eclipse ID application, right? So let's wait for the files to get extracted over here. So as you can see, Eclipse has got extracted. So basically all the files from the zip folder has got extracted to my program files, right? If I go to my program files, you can clearly see that, there's a folder named Eclipse. Now, if I double click over here, basically you'll see an application of Eclipse, right? So basically you can right click over here and choose run as administrator. Now, as you can see, my Eclipse ID is getting launched, right? So let's wait for it to launch, and then I'll show you how you can run a simple program and how you can create a simple project over that. So let's wait for it to launch. Now, once Eclipse launches, the first thing that comes into your screen is basically you have to select it directly for your workspace. So basically, workspace is the place where, all your projects will be stored. I'm going to let it be the same. So that's basically I've put C user Sahiti and Eclipse workspace. Now this is where all my project files will be stored, right? So after that, what I can do is I can just click on launch, and then you'll see that, Eclipse is getting launched, right? So let's wait for that to happen. All right, so this is how basically your Eclipse IDE workspace looks like. Now to create a Java project, what you can do is you can go to File, you can go to New and choose Java Project. Now over here, you can mention your Java project name, let's say example, and then you have to make sure that your execution Java runtime environment is present. So since I've downloaded Java 8, you can see that Java SE 1.8 is present. After that, I can just click on next and then make sure that my libraries are present. That is basically the required libraries for your project, and then I can click on finish. Once I click on finish, you will clearly see that a project has been created. Now what you have to do is you have to create a package for this project, right? So for that, I'll right click over here, go to new and then choose package. And then let's say I mention the package name to be Edureka. So basically your class and your main file will be present under this particular package, right? So I'll mention Edureka and click on finish. Once I click on finish, you'll see that automatically a package name Edureka has been created. Now what we have to do is you have to create a class, right? So basically under a public class only you'll put your main class and then you'll print whatever that you want to, right? So for that, I'll go to Edureka over here. That's basically my package. Right click over there, go to new and choose class. Let's say I mentioned the class name to be hello world. And then I'll choose the modifiers to be public because I want the class to be public, and then I'll click on finish. So once I click on finish, you'll see that automatically my Java file, that is basically my hello world.java file, has been created under the package Edureka, right? So over there, if you observe, I did not choose to automatically create the main class. I just wanted to type so that I can explain you. So let me just type in the main class. So for that, you just type in public static void main, and in brackets you put string arguments. That's basically string args, and then you close the brackets and then you open a new set of flower brackets, and then what you do is you basically mention whatever action that you want to, right? So since I just want to print hello world over here, I'll type in system dot out dot println, and then inside which I'll mention in quotes, I'm sorry, it has to go inside bracket. I'll mention, let's say, hello world, right? Now after that, what I'll do is I have to just execute this project, right? So to do that, what you can do is you go to run and then you can choose run as and choose Java application. Once you choose run as Java application, you can clearly see that automatically we've got an output which says hello world. So I've just zoomed in my screen so that you can clearly see what I've done. So basically I created a project first, and under which I've created a package, and under that I've created a class file. After that, what I've done is I've opened the class file and then automatically mentioned system.out.println to print the output hello world. So when I execute this project as a Java application, you'll automatically see an output which says hello world. I hope you understood how you can install Java and how you can install Eclipse.
The first topic is about introduction to Java. So what is Java? So Java, as we said, it's a programming language which has object-oriented programming model. So when I say object-oriented programming model, everything in Java is taken as an object. So object is nothing but something that has got state and behavior. Say for example, you have chair, right? So chair has got a particular state and it has got a particular behavior. If you do something, if you move it, it would go this way and that way and stuff like that. So basically any object, if you think about in reality realm, any object for that matter would have some kind of state and it would have some kind of behavior which incorporates on its own, right? So basically similar to that, Java is programming language which is based on object-oriented programming model. So everything Java could be thought of as an object, or you define a class. So say for example, you have house, right? So house could be thought of as an object or class rather. A house is a class and it would have certain attributes, right? Like number of rooms or stuff like that. So that is nothing but the state of the house. So this was actually brought in by Sun Microsystems in 1995, And basically Java is nothing but, we have JVM, but JVM is nothing but, you kind of can say it's a specification, right? Sun Microsystems has said that this is how it should be, so that any company tomorrow, I can go and create my own version of Java, but it has to be aligned to this particular specification that is given by Sun Microsystems. So Java is nothing but the reference implementation of Java is provided by Sun Microsystems, but nevertheless, as I said, JVM itself is a specification which anyone can implement actually. But we will talk about Sun Microsystems, talk about the reference implementation that is nothing but one created by Sun Microsystems. So everything in Java would have a state and behavior, and which would be defined by class. Again, it was started off by a team led by James Gosling, and we know it's an open source, which doesn't stop anyone from putting in whatever code they want to. Still, we have a lot of versions coming in Java. So it's not that you just have one version created by Sun Microsystems and it's been used across the industry. You have, like, if you find some issues or if they want to have some kind of enhancement in a particular module, they keep doing it. So right now we have, like, Java is at version 12, which is like we have a lot of enhancements coming in. It's a evolving thing. It's ever evolving thing. And as I said, this is open source. Tomorrow, if you become a good programmer in Java, you could go and actually write something for Java, and which would be moderated by someone and which would be put as open source and anyone can use it. Other thing is Java, the very important feature why we use Java, or why Java is so widely used, is write once and run everywhere. So you write a class or you write program once and you compile it, and this particular compiled version of class could be run anywhere on any machine, or you could transport this particular compiled version of Java, which is nothing but class file. We call it as a class file. Again, you did not get into what is class file, but just to say that you compile it, you get a compiled version of it, and this compiled version of class could be transported anywhere in the network, or you could put it anywhere and just run it. So you could take it on your pen drive as well and go anywhere and plug your pen drive, get this class path, download this class path, or download this class rather, and just run it. So it write once and run everywhere. And the magic part is it could be run on any environment. It could be run on any platform. That's why it's platform independent. So I could write a program today on Windows, compile it, and tomorrow I can just take it on my pen drive and run it on Linux as well. So you don't have to take care about it. Java by itself has a feature to make it platform independent. So, as you could imagine, this is one of the reasons why it's been widely used, because since we are getting into a phase of distributed computing, we cannot have everything run on the same platform. You don't know where so you as a programmer write something, but you don't know where this particular program is going to run. It could be on any platform. So this is why it is more important. So unlike .NET, right, you need to have Microsoft. Just to give you this thing comparison with .NET, so for .NET, you need to have Microsoft Stack implemented, but for this, you need not. It could be run everywhere. So Java can be used to create complete applications that may run on a single computer or can be distributed among servers and clients in the network. As I said, this is more about the application of platform independent programming language. So it could be used on any machine. You need not take care about which machine your program is going to run on. All right, so let's talk about Java features. So what features do we have in Java? First thing is Java is pretty much simple when it comes to SDK, or when it comes to API, application interface. It's pretty much simple. It's kept as simple as possible. It's pretty much similar to other programming languages, and it's verbose. So anyone can just read through it and understand what it is trying to do. So they have kept it to that level. So similar to any high level languages, right? The code should be such that as you read through it, you should understand what it is doing. And that's what they have tried to do. It's high performance. One of the things that I already mentioned about, it's a evolving system. It's not that it's been just done once and been used throughout. It's a evolving system. So as and when there's continuous improvement done, right? So as and when, if I as an application programmer, if I find something not working as expected, I can raise a ticket and they could go through the ticket, or there's a Java development team which has been driven by Oracle now. They would look at the priority of this particular stuff, and if there are a lot of tickets being raised by other companies as well, and if something could be done on the particular aspect that you raised, they would surely incorporate it and notify you in a particular release the enhancement is coming up and stuff like that. So it's a evolving system, and the performance is always, if there's some drawback or if there's something not working as expected, they would surely rectify it in the future releases. So that way they keep it up to the mark. They keep the high performance thing going. It is secured. So Java basically runs in virtual machine sandbox, and no one can get into this particular space. So no one can intrude it, I would say. So that keeps it free from virus and stuff like that, or untrusted process. And other thing that is important is, unlike C, Java doesn't expose pointers. So in C, there could be malicious user who could get into the memory location through pointers and can manipulate the contents of a particular memory, right? Whereas in Java, it doesn't expose the pointer. It doesn't give you the pointer to a memory location. So you can't actually go and change the content of a memory location when you're using Java. So that keeps it secured. So it's robust. So Java checks the code during compilation time and runtime. So basically what happens is, as I said, when you compile it, you get a class file. And whenever you try to run this class file on any of the machines, it will ensure that it's properly done. Or if there's some issue with the class file, it would say that it's a corrupted class file. So basically, you have some kind of checks done during the compilation as well. Compilation is nothing but if you have some syntactical error, say for example, if you miss a semicolon at the end of a particular statement or an end of any statement, it would prompt you during the compilation time that this is not what is expected, or it would ask you to correct it. Once you have everything as per the expectation, it would compile it and create a class file. And when you port this class file to any of the machines, during the runtime, it checks as well. And the other thing is about, you don't have to take care about memory allocation and releasing. Unlike in other programming languages, Java by itself does garbage collection. Garbage collection is nothing but when a particular memory is not being utilized by your program or goes out of scope, it would, Java by itself has a thread. I don't want to get into threads and stuff like that, but Java would clean off the memory contents by itself. You don't have to explicitly write a code to clean it. In C, you have to write a code to clean it, whereas in Java, it's done by itself. So that makes it robust. Other thing is it's portable, as we already spoke. You can write a program in Windows and you can run the same program, or you can write a program in Windows, compile it, get a class file or the compiled version of the class, and just port it on any platform. It could be Windows, it could be you run it on Unix or Linux or Mac or anywhere. So you don't have to take care about it. So Java by itself does it, and that's where JVM comes into picture, which we'll talk about in the further slides. So other thing is it's dynamic, which means that it has runtime polymorphism. So all the objects are evaluated during runtime. It's not just that it's done during the compile time. There's something done during the runtime as well. So basically it's called as runtime polymorphism. But just to keep in mind, not everything is linked up during the compile time. There's something done during the runtime as well. So it could be distributed as well. You don't have to have all the code put into one machine and run it. From my machine, I could run something written on your machine as well if into in the same network, or if they're exposed to a network. We could run programs on different machines. So that's what distributed is all about. So you could think of big data. So this is one of the major features why Java is being widely used in big data, right? So big data is nothing but you have chunks of data. You have like petabytes of information coming in every minute or every hour or every day, right? And you want to process it. So it cannot be done in one machine. If you want to run everything on one machine, as we had earlier, right? Everything was monolithic. Everything was done on one machine, sort of. So that's where you would want to have servers, right? Now the server thing is not being used that much since there's a lot of investment and stuff like that. So distributed computing is nothing but we have like peer computers or normal computers that we have, and programs are actually run on these machines rather than having high-end machines. So basically, this feature is what helps Java to be used in big data. And as I said, it's run on commodity hardware as against server hardware, which needs a lot of investment for companies. Java is multi-threaded. So multi-threaded is nothing but, so you have multiple cores on your machine, right? You have like 4 cores and stuff like that. So you could utilize all these 4 cores. Say for example, you want to do addition of 2 numbers and multiplication of 2 numbers, right? Different numbers. So you don't have to run everything on one core. So this could, since you have 4 processors, right? 4 cores, you could have addition run on one core and you could have this multiplication going on at the same time, at the same instance, right? You could have this multiplication going on as well. You could run them as a thread, right? You don't have to have one waiting for other. You don't have to do it in a sequential manner when you're operating on different variables, right? So that's what multi-threaded is all about. As I said, you could have this operations carried out on different cores at the same instance of time. Object oriented, again, as I spoke earlier, everything is performed using objects, and Java can be easily extended since it is based on object model. Now let's talk about which sectors or which industry sectors actually use Java. So you have Android apps. So Android apps could be written on Java. So basically the underneath is Android API, which is similar to JDK. So JDK is nothing but Java Development Kit. It's widely used in financial services industry. If you would have some idea about it, you could see that mostly all financial companies use Java. So all the legacy systems that we have in financial companies is mostly developed on Java. So one of the aspect for this is more about it's pretty secured. So that's why it's been written on Java. Lots of global investment banks like Citigroup, Barclays, Standard Chartered, and other banks use Java for writing front and back office electronic trading system. So one of the main features why it's been used in financial industry is about security. It provides high level of security, as we spoke earlier. Java web applications. So basically, you have web servers on which your application would be hosted, and you could request for a particular JSP, or JSP is nothing but a dynamic HTML page, right? Wherein the contents could change. Basically, you could request for some particular JSP and you could get it. So, say for example, you're trying to log on to a particular application, you get a login page that is nothing but a JSP. So basically, many of the web applications is developed on Java as well. One of the main features why web applications are developed because you have a lot of web servers supporting Java. You just have to deploy your application on a particular web server and could access it from anywhere across globe. You should be on internet though. Embedded system. When it comes to embedded system, it has to be lightweight, right? So Java 8, I remember Java version 8 had a lot of feature making it pretty much lightweight when it comes to embedded systems. So basically you have micro edition J2ME. What we are talking here is J2SE. And the thing that so there are 3 flavors of Java. So one is J2SE, which is nothing but standard edition, and which is standard edition, which you have like all the data types and stuff like that, all for loops and stuff like that, right? That is about J2SE. You have J2EE, which is enterprise edition, which is nothing but the web application that we spoke about. And we have J2ME, which is micro edition, which is nothing but for embedded systems. As its name suggests, it is micro edition, which is light in weight. And as we can imagine that in embedded system, it has to be lighter since it is burnt into a chip, right? And you cannot have a big application. So that's why we have lightweight when it comes to J2ME. So again, as I touch base on this, it's about web servers and application servers, which makes Java compatible for web applications. So we have Apache Tomcat, which is pretty much widely used, which was a web server earlier. Now they have Apache Tom E, or which is Tom double E, which is nothing but an application server version of it. So basically, when it comes to web servers or application servers, what you do is you as a client could send a request to a web server, and web server or the application server would just process this particular request and send the response the way the application is written. So basically, it would serve the expected result out. So you have enterprise applications. Again, this is Java Enterprise Edition, which makes it favorable for web applications. So all these are specifications, J2ME, J2EE, J2SE. These are nothing but specifications exposed by Java. So if you as a developer wants to do something, or if you want to write your own version of it, you could do it. So where is Java used? Again, scientific applications. So as you could imagine, in scientific applications you need to have high level of accuracy and precision. Rather, there could be mathematical equations and mathematical computations which needs a lot of CPU time, because it's very CPU intensive, right? When you do a very precise calculation with high level of high degree, it needs a lot of CPU time, right? So that's where Java is good at. So basically, this is about, as I spoke about, multi-threading, utilizing all the cores to the fullest. So suppose you have 4-core processor, using all these 4 cores is being done by Java. Java has feature, or through threads, you could actually read through or actually utilize these 4 cores to the fullest. Big data technologies. Again, big data is nothing but, as I said, it's distributed. You cannot have everything run on one machine, which was the case earlier. You would have one server put up and everything is run on that particular server. Now it cannot be the case. That's where big data comes into picture, wherein you have distributed architecture and you have this data being processed across network rather than just on one machine. And mind you, as I said, these machines are commodity hardware and not server level hardware or the enterprise level hardware, which makes it cheaper. Internet of Things. So, Internet of Things is coming up, is a booming thing wherein you could connect things together. Say, for example, you have cars, right? So, you could connect cars together. So, you could have sensors in your car which could emit data and you could connect them together. So, basically, it's all connecting things together. Or say, for example, let me talk about internet itself. So earlier, if you remember, computers were not connected. It were all peer, right? It could just be used for your own purpose. Now internet has started wherein you have all these computers connected, and if you are connected to the internet, you could go on to Google and search something or whatever you want to, sort of. So basically, this is what Internet of Things is all about. So consider this, instead of computer, it could be any other object, say car, for example, as I said. So consider car has sensor and it is emitting this sensor data every minute, and we could utilize this sensor data and do something with it. Or one car can know where the other car is. So that's what Internet of Things is about, all about, connecting things together. So let's talk about Java internals, how it looks like, and all the features that we spoke about. So basically, so far what we have covered is more about Java is an object-oriented program, or it uses object-oriented programming paradigm, which is nothing but everything is thought of as a class with a particular state and behavior, right? It's platform independent. That's why it's been widely used. It's secured as well. That's why it's been used in banking applications and stuff. It's good for distributed computing since it's platform independent. You just have to write it once and you can run it everywhere. So basically, this platform independent aspect is what helps it to be widely used in big data applications. So let's talk about the internals. So what is JVM? JVM is nothing but, again, it's a specification, right? You could have your own JVM. Sun by itself gives specification for a JVM. This is what the JVM should be all about. So I could create my own JVM, but we usually use the reference implementation of Sun Microsystems or Oracle now, right? So JVM is a virtual machine that runs the bytecode. So basically, there has to be some level of compilation done before JVM can understand it. So that's where you have Java compiler. And so what this does is nothing but it takes your source code, it takes the class files as, or it takes the class that you write as is. So Java compiler would consume it and kind of compile it into a dot class file. So dot class file is nothing but compressed version of it and compiled version of it as well. And this dot class file is nothing but it's also known as bytecode, and this is what a JVM could understand. So once you have this class file, it could be sent to the JVM, and JVM could understand it and run the applications. So what makes Java platform independent is this Java compiler is platform independent. You don't have to take care about it. You just have to run the compiler. And whenever you want to run this particular byte code on any of the machines, you just have to have JVM for that particular machine, right? So basically, if you want to have on Linux, right? If you want to run it on Windows, you would have JVM installed on Windows, or you would download the JVM for Windows. And if you want to run it on Ubuntu or the Linux or Mac, you would just have to have the JVM downloaded for that particular platform, and it should be able to sense this particular bytecode. So basically, this is what makes it platform independent, right? As I said, once you have this bytecode, once you compile it, this bytecode could be transported or ported into any of the machines, any operating systems, and you should be able to run it. That is what it is all about. It's write once and run anywhere. So as I earlier mentioned, you could just get this class file into your pen drive and take it anywhere, and you could just plug your pen drive and just run through. That's how simple it is. So this is Java runtime environment wherein you have a set of JVM plus you have libraries. Libraries, it is nothing but all the programs put together, all the program source code for Java put together. So rt.jar is one of the libraries which would have most of the classes, or you have util classes, maybe string class. String is a class itself, which is exposed by Java. So this particular jar file, or it's a Java archive. Jar is nothing but Java archive, which is set of Java classes, or the class files rather, which would have a lot of class files within. So in rt.jar, you would have something like string class and stuff like that. A lot of other classes which is being used by the system, or which is being used by Java itself. So basically in JRE, this is what you have: JVM plus set of libraries plus other additional files. So as spoke, JVM is nothing but specific to environment, but all these things like rt.jar and stuff like that would be independent. JRE does not contain tools and utilities such as compilers or debuggers for developing applets and application. So JRE by itself is a runtime environment, so it doesn't have compilers and stuff like that. So JDK is nothing but it's specifically for development. You could see here it's JRE plus development tools. You have compilers and stuff like that as well. So to run a class file, you just need the JRE, but if you're a developer, you would need JDK. So what we downloaded earlier, if you remember, that was JDK, right? JDK for Windows or JDK for Linux. So basically, if you see this one, you could see here as JDK. So essentially, you need JDK only if you're a programmer. If you just want to run the class file, JRE would suffice. So what is JDK, JRE, and JVM? As we spoke about, you could see JDK is a superset. It has everything, right? JDK would have your JVM plus it would have, as we spoke here, it's JRE plus your development tools as well. As you could see here, details, it has everything here. It would be really confusing right now if you directly get into what all this is all about. But basically, you could imagine JDK is a superset and JRE is nothing but It's your runtime environment, which has JVM and some additional files, or rt.jar as we said, which is nothing but set of files, set of class files that is exposed by Java, which could be used, like string, for example, right? Let's see how it works. So basically you have your source file. So this is what a developer would typically write, would create a .java file. So whatever you write, you create a class, you just create a new class and write something to it. What you get is .java. You get the extension .java. So basically this is your source code, whatever you write, you as a developer would write. This class files would be sent for compilation, or whenever you are good enough done with your coding, you would compile it. And once the compilation is done, once everything looks good enough, once the compiler doesn't mark anything and doesn't flag anything rather, which means everything is syntactically right, you would get Java bytecode, which is nothing but .class file. Now this .class file could be moved across network, or you could, as I said, you could just put it in your pen drive and can take it anywhere. And you could run it on any of the environments. You just have to have JVM. So basically you could run this class file, which is compiled on Windows. You could run it on any of the environment, any of the platforms. So this is something that we spoke about during runtime. There's a verification as well. So when class loader would load this particular class file, it would ensure that it is up to the mark or it's not manipulated sort of. So if at all it sees something wrong, then it would flag it off as, corrupted file or something. So this is nothing but Java class file libraries, rt.jar that we spoke about, Java archive. So this is what is happening when you run a particular class file, right? So you have this class loaded, and then you have this compilers, just-in-time compiler actually running it for you. So basically it's a part of JVM. So remember JVM is nothing but it's a platform. It is specific to platform. So basically for Windows, you would have a different JVM, and for Linux, you would have a different JVM. So yeah, you get this class, you load this class using class loader, and you run through the application or run through the class files. So typically this is how Java operates. So just to give a gist on this one, so you have a source code, you have .java file written, you compile it, you get a .class file, and you can port this class file anywhere. You can run this class file anywhere on your network or wherever you want to. You just have to take this class file, and on the machine on which you run, what would happen is you load this class file first using class loader, and with JVM would have just-in-time compiler, which would run a particular class for you, right? So what we are trying to do here is you're running the source code that's written on any environment. You're running it on any other environment. So basically you could write this on Windows. You could write source code on Windows, but you could run it on, say, for example, Linux. So that is what makes it platform independent. So yeah, let's create one class. And as we create it, I'll talk more about it. So you could open up your Eclipse and could create something like new project. So it could be a bit different for you. The look and feel might not be exactly the same as mine, but you just have to create a new project. Select Java. So basically I put a project name, so whatever you want to. So basic nomenclature is like it has to start with uppercase letter, which is camel casing, right? So you should follow camel casing that's one of the best practices. It won't flag you as some error or something, but that's a normal industrial practice that whenever you create a Java project, it has to use camel casing. Create Edureka Java. So it's creating a project for me. And as you can see here, I have this particular project being created, right? Now what I do is I create Java class. So basically, as we said, everything could be seen as a class, right? That's what object-oriented is all about. So basically what I would do is I would create a class here. So this is my source folder wherein all my source class would be there. So as you can see here, new Java class. So say I create com.edureka. So this is nothing but your namespace or the package, right? So you could give whatever you want to. Basically, this is to avoid collisions, right? If we don't have a namespace, there would be a lot of collisions within the class. So there are a lot of people working on the same project, right? So I could create a class with name class A, and the other person might create class A as well. So when this is clubbed together into one particular application, there would be collision. So to avoid this, basically what you have is you have a namespace. So I would write as com.edureka.class A, and the other person would write something else, and that would avoid class name collisions or class collisions. So this is com.edureka is my package or namespace, and hello world is my Java class name. So as you could see here, there's a package com.edureka, which is again a namespace. And there's a class by name hello world that's been created, right? And if you want to see, you could actually go and so you can see a folder structure created here in the source. So this is your source folder, right? Within your project, there was a source folder wherein we created the class. So if you go to the source folder, you could see a package structure or you could see a directory structure being created, which starts with com, and within com you would have edureka, and here you can see hello world.java. So remember we said that your source code would have all the Java files. So basically this is what I was referring to. This is a method that's a default method that's been called. So when you run this particular class file, JVM would actually look out for this particular method. So you need to have the same signature as is. So you would have a main method wherein your program execution would start, right? So as in when you compile it and run the class file, so basically when you compile it, you would get a class file, right? And when you run this class file, JVM would check out for this main or a method that has the same signature as this one. That's a main method. And your program execution would start running from here. So basically it's an entry point for your execution, right? So this would be a simple program wherein we would just print hello world. So basically you have like system is a class, and this is how you print in Java. So I don't want to confuse right away by saying what is system, what is out, and println. But basically what you have is system is a class. As I said, everything could be imagined as a class. So in Java, everything is a class. So basically you could just click here and you could see the source code of it, right? This is the source code, and this is coming from rt.jar. Remember in JVM we spoke about in JRE we had rt.jar, we had JRE, we had JVM plus class files. So all this has been written by Java, by the Java community. So basically you can see here this system itself is a class. So out is an instance variable and println is nothing but a method within out. So what this statement particular thing is doing is nothing but writing it onto your console. So let's print hello world. So basically when you build a project, it's compiling it. As you could see here, it's saying it's building it. So once it has built it, you could see a class file here, right? So you could see here hello world.class. This is because we built it. When you build it, your Java file would be compiled by your compiler and it would create a .class file. And remember, as I said, this .class file could be run on any machine. So this is Windows machine that have written this file, Java file, and compiled on. Now this .class file could run on Linux or any platform that you want to run it on. So let me talk about this class, right? So you have a public keyword, which is nothing but access modifier, which gives visibility. So basically what we are trying to say here is hello world is could be publicly seen. So it could be seen anywhere within the application. So basically for class level, you have public, which as the name suggests or as the name gives out, it could be seen anywhere within your application. That's a visibility key access modifier. All right, so you have the keyword class here, which is for the class. You need to have it mentioned as class. If you write something else, then it would give you compilation error. So it has to be exactly the same. All right, that's the syntax of it. Hello is nothing but the name of your class. Then you have this public static void main, which is nothing but, as I said, this is the entry point for your application or your class file. So when you run this particular class, it would start off from here. You have a static keyword. Static keyword is nothing but it's at the class level. So basically you need not create instance. We haven't reached to that point yet. So basically hello is a class and you could create instance of hello, which is nothing but object, right? So when you have a static keyword here, you need not create object of hello to run it. If it's not static, then you need to have object of hello created. So basically what I'm trying to say is, say you have one more method here, which is test. Now this doesn't have a static keyword here. So basically what we can do is we can print. So yeah, this is a non-static method, right? Now we cannot call it directly. If it's a non-static, you need to have an instance of hello world created. So basically how you create instance is nothing but hello world. That's your hello world object. So when I say instance, I'm talking about creating object, right? And you could create new hello world. So object of hello world is created using new keyword, right? When you do this, you would get an object of it. Or now what I do is, so basically what I was trying to say is you cannot call test as is. If you do it, you would get a compilation error saying that non-static method test cannot be referenced from a static context, right? You cannot call it without having your object. So basically I can call it on hello world object dot test. Now I can call it. Now it doesn't give me compilation error. I'll create one more static method which would give you some idea. So I'll rename this as non-static test, and this would be static test, right? And we are printing a static method, and here we are printing non-static method. So hello world dot non-static test. Now, whereas the static test need not be called using object, so we could directly call static test. Sorry, I haven't written static here. So this is a static method. Okay. So now you could see here it compiles fine, right? So what I was trying to say is when you have a static method, you did not have an object to call it, whereas non-static method, you need to have object. That's what the static is all about. Then you have void is nothing but the return type. It's not returning anything from here, so that's why it's void. You have main method, that's the keyword, that's the entry point for your application. You have this arguments. You can see string array of strings, which are arguments provided to a particular program. So you could pass on as many arguments as you want. Or if your program is, say for example, you want to pass your name as an argument, you can do that. So this is arguments. Then we have main, which represents startup of the program, which I already mentioned. Then we have system.out.println is nothing but the print statement. So as I mentioned, system is nothing, everything could be thought of as a class. System is a class, out is an instance variable, and println is a method within out. So basically you don't have to think much about it. Just to understand the structure of it, just to understand how a particular class is being written, this is what we have. This is how we write a class, right? Again, just to brief on this, you have access modifier, which denotes the visibility of a particular class. You have the class name, you have the main method, which is nothing but the entry point for your class. You have a static method, which says whether you need an object to call a particular method or could be called directly from a class. You have a return type here. So this is how typically any method would be written. And you can write whatever statements you want to within this particular method. In this case, we have printed out hello world. So basically you could follow this when you do it on Eclipse. So it might be a bit different based on the Eclipse version that you would have, but it should be pretty much similar. All right, so you create a new Java project. So I showed this already on IntelliJ, which is also widely used IDE, but yeah, you could use Eclipse as well. So basically you could see the project name being written as hello world, right? And here it mentions the JRE to be used. So here you can see class being created. And let's see how we can run this. So we compiled it and we saw that dot class file was created. Now we can run this. So as I said, main is the entry point. So it would start running from here. So your program control would come here. And the first thing that it would see is you have printed hello world. So it should print this one. Then I would keep it simple. I don't want to, let's see what's been printed here, right? So you could see here hello world being printed first, right? This is where the program execution started from. So it came to main, saw hello world, it printed out hello world. Then you gave a call to this non-static method. So it printed non-static method, which has been printed in this particular method. And then it gave a call to static method, and you could see static method being printed here. So one thing to remember is the program execution starts from main, and it just executes this main method. So whatever content you want to write, you would basically write it in the main method. So you could see here hello world being printed out. Now let's see how easy it is to code the same in the J shell. So J shell is nothing but shell prompt that was created in Java version 9. Since 9 you would have J shell. So since I have Java version 12, I should have J shell as well. So yeah, J shell is nothing but a prompt. So it's nothing but instead of writing into integrated workspace, you could have J shell and you could try out something here. It's not something for production use as such. It's basically to test something, right? You as a developer could, if you want to see what it does, instead of writing everything into the main. So if you write a class, you would have to write things into the main and then run it and stuff like that. With J shell, it's just a kind of interpreter wherein you could write something, some command and see what the output is. So basically you could say, for example, we printed hello world, right? So system.out.println hello world, right? If you remember, this is what we typed into our main method, right? So if you want to run this, you have to have all these artifacts created as is, right? To have a class, you need to have main method and then build the class and then run it. Basically in JShell, you could run it just to see what's output, right? As I said, this is not an application as such. This is just for the developer to test what the output for a particular command would be. And what are modifiers in Java? So one thing that we saw in the program was access modifier. We already saw about actually this one, right? Public, and we saw public here as well. So these are nothing but modifiers, right? Public, as I said, this public means it's an access modifier, which shows that hello world could be accessed anywhere throughout your application. So here we can see it's a word or a phrase, changes meaning of other phrase in some. So basically it's just trying to say that one of the aspects or one thing that access modifier could be used is to control the visibility of a particular class or a method as well. We have an access modifier for your methods as well. So this is just one of the things, right? We would see other modifiers as well. Modifiers in general has some other things as well, but when it comes to access modifiers, it basically controls the visibility of a class, or a method. Or so yeah, modifiers here, as you could see, there's access and non-access modifiers. Let's see access modifiers. So we used public already. So this one is nothing but a access modifier, which is public, which says that it could be used throughout the application. So visible to the world, as it says. Public is nothing but visible to the world. If we talk about chronological order, if we talk about the visibility, so default is visible to the package. So default is nothing but within the package it would be visible. So basically you could default is without any keyword, without any access modifier. That's a default scope. So within the package, it would be accessible only within the package. So you have like com.edureka, that's your package, right? So this hello world would be accessible if it has a default scope, it would be accessible only within com.edureka. If you try to access it from some other package, you would get an error. So that's the default visibility, visible to the package. Private is nothing but it is visible to the class. It is only visible to the class. So this is the lowest visibility, only visible to the class. If you try to access it from outside class, even within the same package, you would get an error because you won't be able to access it. It is accessible only within the class. Public is accessible to the world. It could be accessed from anywhere within your application or anywhere within your wherever your class file. So basically, if you have a jar file, but what I'm trying to say is public is accessible anywhere, right? Protected is again visible to the package and all the subclasses. So we'll talk about subclasses. So subclasses is nothing but in C we have inheritance, right? Say for example, integer. Integer is a class. So as I said, in object oriented paradigm or in Java, everything could be visualized as a class. So integer itself is a class, right? So there's a number, there's a superclass, which is number, which has all the common state and behavior that a particular number would have, right? So number is a superclass, and you have subclasses like integer. Float would be a subclass of number. Long would be a subclass of number. Basically, this is inheritance, right? You are inheriting integer, float, long, double, and everything from number class. So number is a superclass, and all this integer, float, and everything is a subclass of number. So when it comes to protected, it says that it is visible to the package and all the subclasses. So just to keep in mind, as of now, you can think of access modifier as visibility of a particular component, or could be visibility of a class or visibility of a method or an instance variable as well. This is what drives the encapsulation factor of object-oriented paradigm. So basically, we control the access for all these components, or we control the access of class, variables, methods, and everything, which makes it encapsulated. Cannot be breached, sort of. As we could see, this is like I could make this one as default as well. All right, so this is default scope. It would still run because it's within the class. Right now, suppose I make this one as private, right? Just to show you what this encapsulation is all about, or what this access modifier is all about. Suppose I make this one private, right? Still this one runs because it's within the class. You're trying to access it within the class. Now I create a new class. Say for example, we say access modifier test. So I create a main class here again, main method. Now suppose if I try to run this, right? So basically I create the same stuff here. Say I create a hello world object. Okay. Now this one is private, right? Now if I try to access it from here, what I was trying to say is if I, so as you could see here, it says that non-static test has a private access to hello world. So you cannot use it from outside. That's what I was trying to say. So basically, since it has got a private scope, you cannot access it from other class. And if I remove this private now, which gives it default scope, and as we said, default is nothing but it has got access within package. You could see this error going off here. Now it is accessible, right? So that's what it is all about. When you have a private scope, it's within a class. whereas default is within a package. Public is accessible anywhere and protected is visible to the package and just the subclasses. So let's talk about non-access modifiers. This is not controlling the access of class, method, or variable. When it's static, you need not create object of a class. So basically for static test, you could see that we didn't create object of a class. We didn't call static test on a particular object of a class. It could be called directly. That's what static is all about. The static modifier for calling methods and variables without an object to which it belongs. As we saw, we didn't create an object of hello world. We directly call the static method. Final is nothing but you can't change it. Final, as the name suggests, you can't change it once it is created. So finalizing the implementations of classes, methods, and so this is nothing but instance variable, which we would be talking about the slides to come. Just to tell you, this is an instance variable which we have assigned the value 10. Now suppose within this particular method, I try to change the value to 11. You would get an error saying that cannot assign a value to a final variable. So final is like it's final, can't change it. Once you have created it, you can't change it. But if I remove this final, you could see this error would go off. You don't see this error anymore. Whereas by putting final, you would see this error. So that's what final is all about. So basically, this is good enough for constants, right? So if you have constants within your class, you would make it final so that no one can change it. Abstract is nothing but you could mention it as abstract when it doesn't have implementation of all the methods. So what I'm trying to say is abstract modifier is again a non-access modifier, and what it tries to say is, say for example, you have a shape class. Shape class is an abstract class because shape doesn't say you want to calculate area of shapes. So basically shape class by itself wouldn't know what the area of the shape would be. Shape is a class wherein it's a generic class. It doesn't know what the implementation of area would be. For square, it would be side square. For rectangle, it's length into breadth. Or circle, it's pi r square. So basically shape by itself wouldn't know what its area would be. But now shape is a superclass, and say you have subclasses of it, like square, you would have circle, and so on. So now basically you want to ensure that when you create a subclass of the shape class, you want to ensure that that particular class implements the area. That's when you create it as abstract. So the shape method would have, or the shape class would have area method as abstract, which would be implemented by the subclasses, which has to be ensured. It's kind of ensuring, or if the subclasses don't actually implement it, you would get a error. So basically circle would have its own implementation of area saying pi r square. Square would have its own implementation saying side square. So basically what I'm trying to say is area is a abstract method for shape class. And when you have an abstract method, the class itself is abstract. So you have like shape com.edureka.shape. I'm creating a class. Now I'm creating an abstract method. So when you say abstract, you don't have to provide implementation. It's just a generic this thing. You don't have implementation of it. You just have the signature of it. So basically, as I said, when you have an abstract method, the class itself should be abstract. So we'll have to make this abstract as well. So you created a shape class which would have an area and which would give you this thing. So basically, if you want to have subclass, I don't want to show how the subclasses are created at this point, but basically this is what abstract is all about. You don't have the implementation of it, but you're ensuring that subclass is implemented. So here you can see it's just a signature. You don't have implementation unlike this. Implementation is nothing but if you write something within these braces, this is an implementation for this particular method. Whereas in shape class, you just provided the method signature, but we don't have implementation of it. So that's what abstract is all about. Synchronized and volatile is much about it's used in threads. Synchronized is we are saying that only one thread could get a control at one point. So as we said, threads are nothing but parallel execution. You could have thread, say for example, you could have thread one calling a method. So we have a non-static method test, right? Say this is a method. So what we are trying to say here is if it's synchronized, we can make this as synchronized, private synchronized. So this is what ID is all about. So when you have this integrated development environment, you don't have to type everything. When you type sy, you could see synchronized coming up here and you could select it. So when you put a synchronized here, what we are trying to say is only one thread could access it at a given point. Only one thread at one point. So if multiple threads are trying to access it, one thread has to wait for it. So only one thread would get an entry to this and the other thread should wait for it. So that's what synchronized is all about. And volatile, it's basically for memory visibility, or what we are trying to say is, so basically every processor has got its own cache. So what we are trying to say is when you use a volatile access specifier, don't store it in cache, store it directly into the main memory so that all the threads would get the most recent value being assigned to a variable. And also volatile is not needed when you have using synchronized as such. So it's mutually exclusive. So let's talk about variable. So variables are nothing but it's a holder, right? It holds value, and variables are nothing but it's reference to that particular or it's a address or something that is pointing to a memory location where the values are being stored, and you could access it using this particular variable name, or you could access the memory location where the value is stored using a variable name. What I'm trying to say here is, so this is a variable and you could access, so this 10 is stored somewhere in the memory and you could access this part of memory location where this 10 is stored using this variable, or you can manipulate it as well. You can change the value. So basically there are three types of variables in Java. There's local, instance, class, or static. Local is nothing but local to your method. Whenever you have a method or you kind of create a variable within a method, that is nothing but local scope, which is like it has the access, its visibility only within that particular method. Once control goes out of this method, you can no longer access this particular variable. That is local. So if I define something here, say for example, I define something here. So this is a local variable since it's defined within a method. So once the control, you would have this only within this particular method. Once the control goes out of this method, this is no longer accessible. Basically, this is where garbage collection for Java is useful. Once your control goes out of this particular method, garbage collector would kick in and would clean off this variable or clean off this particular memory location, or would make it available for use. So that's the local scope. The next one is instance. Instance is nothing but something that is defined at the instance level. So this is instance variable. So since it's at the class level, right? This is, you could see it at the method level. This is at the class level. So this is nothing but an instance variable. Now there is static variable as well. So this is how you define a static variable. So instance variable is nothing but it's per instance. So you could go and change this instance variable to something else. Suppose I assign a value 40 here. Now I could have one more object created. Suppose I call this object 1 and I have hello world object. So I create one more object here. So what we are trying to do is we are trying to change the instance variable through objects. So basically this is what it is. When you have an instance variable, normal instance variable, which is non-static, you could access it through objects, right? So through object one, you assign for object one, you assign instance variable value to 40. For object two, then you change the instance variable value to 50. I won't say changed it, but you assigned it. This is how you deal with instance variable. It's at the instance level. It's at the object level. Whereas for static, it's at the class level. It's one per class. It's not one per instance. It's one per class. So basically what you can do is you could do something of this sort, wherein it's at the class level. It's not at the object level. You are assigning value 100 to a static variable. So as you could see here, it's not a particular instance that you're operating on, it's the class directly. Just to give you a gist, we have local variable, which is within a particular method, and scope remains within a method. Once the program control moves out of this particular method, Java would or JVM would come in and kick in garbage collector to clean this off. It's only accessible within this method. You have an instance variable which is at the class level, but it's non-static, and which means that it has copy per object. When you have multiple objects, you could change the values the way you want per object. Static is nothing but one per class. And as you could see here, we changed the value of the static variable to 100 through class. So that's about variables. We have an instance. So instance variables are declared in a class when the space is allocated. I'll just read through this one. So when a space is allocated for an object in the heap, a slot for each instance variable is values created. We had a teacher instance variable, and whenever you create, but basically an instance of a class is created in a part of a memory which is called heap. So whenever hello world object is created, a slot for this instance variable would be created as well. Instance variables are created when an object is created with the use of keyword new, and destroyed when the object is destroyed. So unlike local variables, which is within the method scope, instance variable is within the class scope. So basically, whenever you create an instance of a particular class, your memory would be allocated for that particular instance variable. And whenever it's done, whenever it's destroyed by the garbage collector, it would go off. Access modifiers can be given to instance variables. You could have like private, public, protected, default. All the access modifiers be assigned to an instance variable. So basically you could have it as private. Private is just within this class. You cannot access it outside this class. You could have public as well, which is like could be accessed anywhere within this application. You could have protected, which is like within the package or the subclass. And you could have the default one, which is nothing but package access, which would be accessible just within this package, that is com.edureka. So instance variable have default values. For numbers, the default value is 0. For boolean, it is false. And for object references, it is null. So values can be assigned during the declaration or within the constructor. You could assign values directly while declaring it, something like this. Instead of 0 is the default one for integer, as they have mentioned. But yeah, you could assign, if you put it as 10 here, it would be taken as a default value instead of 0. Constructor is nothing but a method which constructs an object of a class. Values can be assigned during the declaration or within the constructor. Instance variables can be accessed directly by calling the variable name inside the class. However, with static methods, when instance variables are given accessibility, they should be using fully qualified name. So what we are trying to say here is this is a static method from which we are trying to access instance variable. In this particular static method, you need to have object reference. This is the object that we created. So object reference dot instance variable. You need to have, as we have mentioned here. So here, as we can see, object reference dot variable name. You need to have fully qualified name. When you try to access it within the static method, you need to have fully qualified name. Whereas here within a method, which is non-static, this is non-static. Here I can access instance variable without object reference. So here, as we can see, it could be accessed without, but if I do it here, it would throw me an error. It's not accessible here at all. Non-static field instance variable cannot be referenced from static context. Instance variables are not accessible directly here. It has to have fully qualified this thing, which is object reference dot instance variable. Whereas when it's called within non-static method, you could use it direct. So static, as we spoke about, it's one per class. So it's declared using static keyword. So static variables are stored in static memory. It is rare to use static variables other than declared final and used as either public or private constants. As we said, it's mostly used for constants, and static variables are created when program starts and destroyed when the program stops. So one thing to remember is it's one per class. It's not one per object. Instance is one per object. You have a copy of that particular instance variable, one per object case of instance, whereas case of static, it is one per class. So the scope remains, or the life cycle remains, right when the class is loaded till the program is stopped, till the class is unloaded. Static variables are declared public since they must be available for users of the class. It's not mandatory though, but usually if it's a constant, it is declared as public. Static variables can be accessed by calling with the class name. So we saw here class name dot static variable. So how do we decide what amount of memory is to be allocated? So these are the data types that we have. So each variable in Java has a specific type which determines the size of memory, the range of values that can be stored, and the set of operations that can be applied to the variable. Data types can be categorized into two major types, primitive and non-primitive. So basically primitive is not object. Primitive is supported by language itself, which is kind of, it has got 8 primitive, or it's predefined by the language and named as keywords, and it has 8 primitive data types, that is byte, short, integer, then you have long, float, double, character, and boolean. This is pretty much similar to other programming languages that you have. Byte, it consumes one byte. These are 8 primitive data types that are predefined. Non-primitive is nothing but string. String is an object itself, so that's something that is non-primitive. Or if you define your own class, say student for that matter here, right? We have defined student class, that's non-primitive. So this student class is non-primitive. We have strings for storing string, which is again kind of non-primitive. We have arrays, or basically it's all called as reference variables, since we're referencing a particular memory location through variable name. This is where we have table showing byte consumes 1 byte and its range is from -1 to 8 to 1 to 7. Short is like 2 bytes, and you could imagine that it would be from -32768 to 32767. So it's pretty much similar to other programming languages that you have, like in C as well, we have similar to this thing. One thing is character takes 2 byte, in C it takes 1 byte, I believe, though it doesn't use all the 2 bytes every time. It depends on encoding type. So Boolean is 1, which is true or false since it has to store 1 or 0. So yeah, it's pretty much similar. So just to talk on the bytes required, byte is 1 byte, short is 2 bytes, integer is 4 bytes, long is 8 bytes, float is nothing but it has decimal values stored, signed decimal values. So it again consumes 4 bytes. Double is signed again float values or signed decimal values, which consumes 8 bytes. Character is 2 bytes, and Boolean is 1 bit. So basically, to decide whether to use float or double depends on the nature of the application. So if you want to have more precision or if you want to have more range, you could go with double. So non-primitive or reference data type is a variable that holds a particular object or holds bit that represents a way to access an object. It's a pointer to a memory location basically. So as we spoke, Java doesn't expose the pointer directly. It doesn't give you directly pointer to the memory location, but it gives you the reference variable. So you cannot manipulate memory location directly. You cannot add some values to the memory location through pointers or something, but through reference variable, you can access it and assign some value. So yeah, it does not hold the object itself, but it holds a reference address to the object. The reference type does not have size or bit range. So here we can see string str is equal to Edureka. So the one shown in red is actually the memory where Edureka is stored. You have a reference and str is the reference to it. So here we can see variables and data types. So we have a main method again, and we have byte. We declare a byte here. Byte b is equal to 10. Short s is equal to 20. So I think it's pretty straightforward. You kind of have this data types created. You just have to assign values to it. These are all primitives, as you could see. Till here it's primitive. So you could see that values are being assigned and it's been printed out here. So I think it's pretty straightforward. You can assign a value to a variable and just print it. So again, we use system.out.println for printing it. You could try it out on your own. You could try it out this data type program. You could just assign something and just try to print it out. We are talking about data type conversions. So we have implicit and explicit conversions. In some case, programmers don't have to actually write explicit conversions from one data type to other, but in many cases, programmers need to. So the arrow in the diagram shows the possible implicit type casting that are permissible with primitive data types. It's just with primitive data types, right? As the diagram shows, int can be converted implicitly to long, float, double. Since int takes less space, it could be applied to any of the numbers. For vice versa, they have to be converted explicitly. Whereas if you want to convert long to integer, you have to mention it explicitly. So basically, we are talking about when you're trying to store integer into long, integer takes less space and long takes more space. So it can be easily accommodated. Since long takes more space, if it is more than the range of the integer, it wouldn't know how to assign it to integer. So that's why it has to be explicitly converted. Implicit conversions, we can on the J shell, you could type this. So here what we are trying is we have a character C is equal to A, and you could see C is assigned A. Now integer K is equal to C, which could be done. You could assign character to an integer. So basically it's a ASCII code for it. So 97 is the ASCII code for C, which would be assigned to K. So now when you assign C to float, which works as well, so you get 97.0. You could assign character to long as well, which is 8 bytes integer. You could assign double as well, which is 8 byte float, and you could see. But it cannot be done the other way around as we spoke. So you cannot have integer or you cannot have double assigned to character. So it would give you incompatible or possible lossy conversion from double to character. It has to be explicitly done if you want to do that. Need of type conversions. So here we have integer a equal to 100, initiated a variable with type integer. Then you have a string b, which is assigned value hello. So basically here you can see string being used, which is a reference variable. And you have string s is equal to a plus b. S equal to a plus b, then it adds up like 100 plus. Since hello is a string, it would concatenate it. So you could see 100 and hello being concatenated, and you could see 100 hello. The data type of both the variables are different, but to perform any operation, we need both the variables to be of same type. Here integer value is converted into string and gets concatenated with other string. So basically had b been an integer, you would have got addition of it. Say for example, integer b is equal to 200, and if you 100 plus 200, you would get 300. But since it's a string in this case, 100 is converted into string and it's concatenated with hello. Explicit type conversions. We saw the previous case wherein double was being assigned to character, which prompted us with lossy conversion. So this is similar to that. So basically here what we are trying to do is we are trying to assign double to integer. So you have double, d is equal to 45d, which is 45, right? Again, double is 8 byte decimal signed decimal number. So you assign 45 to it. And now we are trying to assign this double value to integer. So it's possible lossy conversion. But you have a provision to typecast it. So basically what we are trying to do here is you're trying to assign again double to integer, which is possible if you typecast it. So when I say typecasting, it's nothing but opening parenthesis, then the destination data type, then your data, actual variable. So basically to the right side, you could see that through explicit typecasting, we can assign double to integer. So casting may lose information. For example, floating point values are truncated when they are cast to integers. Example, the value of d, that is 45.5, when converted to integer gives 45. So we could see here in the bottom, like the double, we assign the value of 45.5 to double, but when we converted into integer, we got 45. 0.5 was truncated. Since the destination data type that's integer doesn't store decimal values. Now this is like type conversion methods, which is there near wrapper classes. What we are trying to do here is we are trying to convert 23, which is string, into integer. So you have a string s is equal to 23. You assign the value 23. So mind you, this is string right now. We have integer dot parse int, and we pass the string, which would be converted into integer. So this integer class that you see here, right here, is nothing but a wrapper class. You have string into integer, which is nothing but integer dot value of string, which converts it into integer data type itself. So as you could see, the destination is integer. Now integer to string, you have integer. We have a toString method which converts integer into string. So basically you have integer I which has been assigned 23. Now you have integer dot toString I which would convert this integer into string. We have one more method which is string dot value of, which would also convert integer into string. Let's talk about operators. Operators are nothing but it operate on these data types. So you have unary, which is kind of pretty much similar to what you have C++. You have postfix and you have prefix. Postfix is I++ or expression++, and the operator is after the variable, which means that it would be assigned value and then it would be added. Prefix is before the operator, which would be added first and then assigned, or the operation would be done first and then assigned. That's prefix. Arithmetic is pretty much similar, like multiplicative. You have like multiplication, division, and mod. You have additive, which is plus and minus. You have shifting operation, which is bits shifting to the left and bits shifting to the right. You have relational operators, less than, greater than, less than, equal to, greater than, equal to, instance of quality of two data types or two variables. We check whether they are equal and not equal. We have a bitwise and bitwise XOR, bitwise inclusive OR, which is happening at the bit level. We have logical and logical OR. So basically this is for conditions, right? If you want to have like two conditions, like if int I is greater than 0 and int j is greater than 0, sort of, you add or you have logical ANDing between two conditions, logical conditions. Or logical or pretty much similar to other programming languages, like it's or between two conditions. We say that either this or that. We have a ternary operator which says that if the condition matches, we would have a condition followed by question mark followed by colon, and we would have some value followed by colon followed by some other value. So what we are trying to say here is if the condition is true, assign value 1. If the condition is false, then assign value 2. So instead of having it written in if else, you try to put it within ternary operator. So basically this is when you have simple assignment operator. If you have a logic, if you have some particular logic being written, it would be a better practice to have if else so that it's readable, right? Because ternary operator, it would be very difficult to actually read through. We have assignment operator, which is equal to, which is plus equal to, is nothing but adds the value on the right hand side to the left hand side and assigns it to the left hand side variable. Minus equal to does the same thing. It kind of subtracts value to the left hand side from the value to the right hand side and assigns it to the left hand side. So I believe this is pretty much similar to other programming languages. There's nothing different in this. We might have used it somewhere or the else. Should be pretty much simpler for you guys. So let's see unary operator example wherein x is equal to 10. So you could see x being assigned value 10. You have x plus plus. As we said, it assigns first and then increments it. So you could see value 10 here again. So now if you, after this, if you print the value of x, you should see the incremented value, that's 11. So that's post increment. So let's see pre-decrement. So you have A been assigned the value of 10. All right, now you do minus minus A, which is pre-decrement. You would see the value 9 directly. And now if you print the value of A, it would be 9 again. So basically this is like decrement and then assign. This is like assign and then operate. This is like operate and then assign. Let's see the negation operation. Like A has a value of true. Now we negate it and assign it to the variable D, and you could see that it's changed to false. Now let's see the arithmetic operator. You have B which has value of 20. We have D which has value of 30. So when you add it, it gives you value of 50. When you multiply it, it gives you the value of 600. 30 into 20, which is 600. When you divide it, 30 by 20, you get value 1. And when you have mod, which is like remainder, which gives you value 30 by 20, which is equal to 10. Shift operators, so it shifts to the left. So shift left, shift right. So basically you have integer value of 20, and if you convert this into binary, if you convert the 20 to binary, which comes out 5 digits, right? So when you convert this binary and when you shift it to the left, you would get the value of 80. So you have value 20, which is nothing but, if you convert this 20 into binary, which would give you 10100, right? Now what we are doing here is kind of shifting it to the left by 2. This is what you do, and this is what it shows up as value of 80. So this is nothing but 64 plus 16. So that's what this left shift does. Basically it's shifting to the left by 2. Again, you could have shifting to the right by 3, which would give the value of 2. Just shifting to the right by 3 would be something like this, right? So yeah, basically it shifts it, and you could see that, yeah, basically it would end up to 2. So now we have like relational operators, which is pretty much simple, like A less than B, it gives false. A greater than B, A equals B. Since you have A is equal to B, in this case we have A equal to B, that's why we have A less than B as false and A greater than B as false, but whereas A equal to B is equal to true. We have arithmetic operators pretty much similar. Basically you have add, you have multiplication, you have division, you have mod. So here we have A is equal to 20. So what we are trying to do is assignment. So A is equal to 20. Now B is equal to 40. A plus equal to B, which is nothing but, as I said, your left hand side would be added up to the right hand side and would be assigned to the left hand side, which is nothing but 20 plus 40 would be assigned to A. So when you print A, it would print 60. Ternary operator, which is nothing but if A is less than B, here we can see that if A is less than B, then the value of 100 should be assigned to TR, or the value 200. In this case, the value 200 is being assigned. A is greater than B. Logical operators is nothing but ANDing and ORing of conditions. Yeah, here we are saying that A is less than B and D is less than B, then return false. And it's like kind of ANDing logical conditions. Now let's talk about the control statement in Java. Now again, this one is pretty much similar to other programming languages, nothing different in Java. So you have control statements, you have iterative statements, you have jump statements. So one is selection or decision making statements, which is like if else ladder. You have if this particular condition satisfies, do some things, do some execute group of statements, and if it doesn't, then execute other group of statements. That is about if else. Switch is nothing but based on the value of a variable, like you execute different step of statements. Like say for example, you have you write a switch on integer variable x. Now when x is 1, you do something, or if x is 0, you do something. Or you can have a default statement as well. When x is neither 0 or 1, do something else. That's about switch. Iteration is you repeat the same set of statements again and again. till a particular condition is met. That's iteration. So you have for loop, which is like after every iteration, the value of variable or the iterating variable would be changed and would be checked against a condition. And if it meets, it would come out, or if it meet, it would execute it again. And if it doesn't meet, then it would come out. So yeah, this is pretty much similar to other programming languages. So for int I is equal to 0, I is less than 10, I plus plus, and you write something within it. So this loop would go on for 10 times from 0 to 9. It would break, it would come out when I is greater than 9, which is 10. When it goes to 10, it would come out. While is again pretty much similar to that. You have do while construct, which is guaranteed to be executed once because the condition is checked after the execution is done once. So basically, no matter what the condition is, it has to be executed once for sure. That's when, if that's the behavior you want to put into your program, you would use do while. Execute once for sure. Jump statements, you have like break, which come out of for loop, or any iterative statements. You have continue, which would again continue, and return is again coming out of a method, or yeah, mostly from the methods you return something. So the control leaves the method. Now, just to give you what if else is, if the condition is true, then execute the conditional code. If the condition is false, come out of the execution or come out of the conditional code. Skip the conditional code. That's what if else is. So here you have int I is equal to 10, int b equal to 20 if I is less than b. So it's pretty much similar to the ternary operator that we had. So you could see here tr is equal to a plus b. So basically the value, if a is less than b, which is in this case, a is equal to 10 and b is equal to 20. In that case, you would have ter as 30 since it is true. So basically it checks the condition, and if the condition is true, it executes the code with it. Now let's talk about if else. If else construct is nothing but you have a else set of statements to be executed when the condition doesn't succeed. So in this case, if a is less than b, tr is equal to a plus b, else tr is equal to b minus a. So in this case, it was less than a is less than b, so you got the value of 30. Whereas if a is greater than b, we have again changed it. So if a is greater than b, then tr is equal to a plus b, else tr is equal to b minus a. So in this case, a is less than b, so which means tr should be b minus a, which goes into the else condition statement. And here you have 20, b as 20 and a as 10, which is 20 minus 10. So you should have tr as 10. So here it's pretty much same. It does the same thing nested if else. Now we are talking about the switch statement. So you have switch expression and you would have case written against it, whatever case you want to execute. So basically you would have for value 1. So yeah, what we are trying to say here is we have a switch expression and we have a value. For value 1 as its value, then execute this piece of code and then break out. And if it has value 2, then execute this piece of code and then break. If it doesn't match with value 1 and value 2, then execute the default cases. So one thing to note here is it's mutually exclusive. Only one of it would be executed out of the cases. Make sure you break out of all the conditions. So to the right hand side, you could see integer ch has a value of 40. Now we have a switch for 40. Now case, when the value of ch is 20, it would print case 20 executed. When its value is 30, then we would have case 30 executed. When its value is 40, then we would have case 40 executed and then break out. And if it's neither 20, 30 or 40, we would have a default case executed, which says that 20, 30, 40 not executed. So in this case, since it has a value of 40, you would see that case 40 executed as output. Iteration is nothing but it is basically iterating code. If a condition is met, the code would be executed. Until the condition is true, the code would be executed, and once it is false, it would come out of the loop. So basically it's a looping statement. So after every loop, the condition would be checked, and if the condition is true, it would loop again, and if not, then it would come out. There are three types of for loop in Java. Simple for loop, similar to C, like for int I is equal to 0, I is less than 10, I plus plus would be a simple for loop. For each or an enhanced for loop and labeled for loop. For each is basically iterating on array list. Suppose you have some collection, or suppose you have array, right? You don't have to manipulate the indexes, since the typical scenario with array list is iterating through all the elements within the list. So we have an enhanced for loop wherein we don't have to actually deal with indexes. Java has come up with a enhanced for loop wherein for each iteration it would assign the value of each element within the array to a variable which could be used within the loop. So we don't have to deal with indexes, like we don't have to loop through till the size is met, till the loop through till the size of an array is met. Basically, it's all done by Java itself. We have an example which would clarify it. So simple for loop is, as I mentioned, you have for int I equal to 10, I is greater than 1, I minus minus. So it would print from 10 to 2. That's a simple for loop. Now, what's the syntax for it is for, then open up round brackets, then you have initialization, then you have a condition, and you have increment or decrement, whatever you want to do. Or you could even add up like I plus equal to 2, even that is good enough. It's like for each even number. Not even, I would say, it's like incrementing by 2. Now, this is what I was talking about. So this is for each loop or enhanced for loop, wherein a typical scenario with array is you kind of iterate through each element within the array and then do something within the loop, right? So this is what Java has made it easier for us. So basically, you don't have to deal with indexes here. If you wouldn't have had for each loop, what you would do is you would, till the size of the array is met, you would iterate through and read from each indexes, right? But in this case, as you could see, there's an array, and for each loop, the value within the array would be assigned to this variable, and you could use this variable within. Makes it pretty much simpler for us. And as I said, this is a typical thing that we do with arrays. Now, labeled for loop, it's not recommended to use this often, but still we have these constructs here. So basically, it's like go to. We can have a label of each for loop. It is useful we have nested for loop so that we can break or continue a specific for loop. Normally, break and continue keywords continues the innermost loop, innermost for the loop only. To give rationale behind why I mentioned that this shouldn't be used often is because it becomes very difficult to debug, right? If you dry run it, if you use these labels, it becomes very difficult to actually understand what's happening within. So we should avoid it, and all this could be done by writing a proper constructs or using simple for loop as well. So we should avoid it somehow. So basically, as per my experience, this is not a good practice to use it. So type of while loop, we have simple while loop, we have do while loop. All right, so simple while loop is first the condition is checked. If it meets, then the looping statements are executed. Whereas do while loop is kind of the statement is executed once for sure, and then the condition is checked. If it is met, then it is looped again. If not, then comes out. So this is a simple while loop. So you have condition. As you could see here, while a is greater than 1, you print the value of a and you decrement it within. Here it's a do while loop. So no matter what, you would have this 2 printed and it would be incremented. So it's 2 to 9. So no matter what, some value would be printed for sure when you use do while. Now we have jump statements, which is break is like coming out of a loop. So as we mentioned, it's the innermost loop that it comes out of. So that's what break does. If a particular thing is met, or you could write a condition for a particular loop to be broken rather than continuing it. So basically you could have like this would be more or less like you could have an infinite loop, say for example, running through, and if a particular condition is met, you could break out of it. A typical scenario where it would be used. So here you could see that you have a loop from 10 which iterates from where I is equal to 10 and where I is greater than 5, I minus minus, which we are decrementing each loop. Whereas you are saying that if I is equal to 7, we should break out. So here you can see though I is greater than 5, you can see the loop has broken out after 8. Since the value has reached 7, it's not printing the other indexes because it broke out of the loop. So basically, this is like if a particular condition is met and you don't want the loop to go ahead, you can break out of the loop. Continue is similar. When you write continue, it goes to the start of the loop again. It starts the loop again and it skips the messages or it skips the code that you have after continue. So in this case, you could see that we have I equal to, in case when I is equal to 5, we are continuing the loop, which means the print statement for I when I is equal to 5 wouldn't get executed since you're continuing it. So basically, as you could see, the values being printed here, you can see 0, 1, 2, 3, 4, and there's no 5 here. Then we have 6, 7, 8, 9. So basically what we are saying here is when I is equal to 5, don't execute the statement within the loop. Just continue, just skip it. Okay, so what are methods in Java? So method is if you would have written function or if you would have used any programming languages, if you want to perform some operation, if you want to do something, or if you want to do something on some particular data, you would write a method. So basically in Java, methods are defines the behavior of a class. So remember I told you a class is all about state and behavior. So methods are nothing but it defines the behavior of a class. So what are methods? A method has a group of statements. Of course, as I said, since it defines the behavior of a class, you need to have some operations done, right? So you define the operations through group of statements. It is much more used to have reusability of a block of code that minimize redundancy. So imagine if you didn't have methods, then you would have written the same piece of code again and again. Say, for example, you have a method which adds to number, right? And if you write the piece of code to add to numbers directly into the main method, if you want to write it again, or if you want to again add two numbers, you will have to write the same piece of code again in the main method. Whereas if you have a method, what you would do is you would refactor and take this add method or a functionality which adds to numbers into a method. And this method could be invoked from anywhere within the application, which is nothing but reusability, right? Rather than writing the same piece of code, now what you're doing is you are defining this add method into some other method, which could be called anywhere within the code. So that's about redundancy. That minimizes redundancy and increases the reusability of a code. A class can have multiple methods, as you could imagine. You could have multiple behaviors introduced into a class, which means that you would potentially have multiple methods within a class. A method returns a null or a value using the return statement. So basically, the intent of the method is to perform some operation, right? So what the method would take is it would take parameters and do some operations on these parameters, and it may or may not return something back to the calling program. So if you don't want to return anything, you have to return null. Or if you want to return some value, you could have, say, for example, you want to return string, you would return a string of a method. You could have void as well, which means that the method is not returning anything back to the calling program. It is doing something within itself, and just the control would be back to the calling program, but it won't return anything out of the method. That's about method. So let's talk about, so what's the syntax of method? So the first one that you see, so this is a method which is public int edureka integer a integer b, and it is just concatenating the two strings or two numbers that we have sent across. So basically let's anatomize it. So what is public? So public is nothing but again a access modifier. So public means this particular method could be accessed from anywhere within the application. So that's what public means. Similarly, you could have private, you could have default scope, or you could have protected scope. So public is accessible anywhere within the program, private is within the class, default is within the package, and the protected is within the subclass and the package. Okay. What is this int? It is nothing but the return type. So this particular method is going to take two arguments and do something and return integer, right? Name of the method is, you can see Edureka, that's the name of the method. Okay, so what you see within the parenthesis after the method name is nothing but the arguments that this method takes. So what this particular method is doing is it is taking two arguments which it is acting upon, right? So it takes integer a and integer b. That's the parameter list. So whenever you want to invoke this particular method, you have to pass arguments in this order. Now, what you see within this curly braces is nothing but the behavior, or this is how you introduce a behavior to the class, or this is how you add functionality to a method. So what you are doing here is kind of adding this to numbers. So what is a return statement? What does it do? So return statement is nothing but you do something, you take the arguments whenever control comes into a particular method, it does something and you return it back to the calling program. So the return statement is a control flow statement that terminates the execution of method and return control to its caller. So when return type of any method is void, then the method does not return anything. If it is void, you won't return anything out. But if it is returning string or something, you would return string, or null if you plan not to return anything. It could be null as well. So here we can see a method by the name work, which is returning void. So you can see that it is not taking any arguments as such or parameters, but it is just printing out saying that Edureka welcomes you. In the second case, you can see it is returning integer. So it's taking int a and b, okay, and then it is printing out and it's returning integer as well. So let's write a program, sample program to add two numbers, and we would be writing all this logic within a method. So let's start off by defining a class. All right, so we define a class, say com.edureka. And a typical name for all arithmetic operation, class with all arithmetic operation would be calculator, right? So I would write it as calculator, for example. All right, so here you can see the naming convention again. There's a package, which is com.edureka, and you have a class as calculator, and it follows camel casing. So it starts with uppercase, followed by lowercase. So you can see the class is being created here, okay? Now what we are trying to do is you are going to have a method which takes two number, okay? So say I define, let's keep it public. All right, so this is an access modifier. We want to keep it public, so we want to access this particular method from anywhere within the application. So I'm keeping this public. So typically addition would return results, right? You would add two numbers and return results of two numbers. So that's your return type, which is integer. So you could either write the return type as primitive or you could write it as a wrapper class. So basically wrapper class is nothing but integer has its own, everything in Java has to be realized in terms of classes. So integer has its own class. Int is a primitive data type and integer that you see here is a class corresponding to int. So let's put the return type as integer and add is the method name. Okay. Now this takes two arguments, integer arguments, which is arg1, and let's put the second one as arg2. All right. So we start and end it by curly brace. Okay. Now we have to write logic within here. So what you see here, it's throwing an error saying that you are not returning integer out. there's a missing return statement, because in the signature, this is known as method signature. This particular thing that you have defined here is method signature. So in the method signature, you have mentioned that this particular add method is intended to return integer out of the body, but still you haven't returned integer. So basically, to get rid of this, I could put return null, which means it's doing nothing. Now you can see that we got rid of the error, right? So let's do one thing just to make it more verbose. I'll write integer result is equal to arg1 plus arg2. So this is a method body that you are defining here. So you are adding a behavior, right? You are giving behavior to the calculator class. So by defining add method, this certain behavior that you are introducing. Now you could have a multiply method as well, which would take two numbers and would multiply it, which is again giving some sort of behavior to calculator. So that's the reason we say that methods add behavior to the class. Okay. So here it is taking two arguments, arg1, arg2, adding it, and we will return the result from here. All right, so this is a method that you have defined. But so far, we are not invoking this method, right? We are not calling this method. We want to call and check whether it's running as expected. So that's where we would have main method. All right, when you type main, it should give you suggestion saying that, are you trying to write main method? So once you click on it, it would, this is done by IDE, by the IntelliJ. Similarly, in Eclipse, you would get an option. It would give you a suggestion saying that, do you want to introduce main method? All right. So we have a main method here. So again, it's public static void main, and it's taking arguments here. All right. So remember I said static and non-static method. You can see here add is non-static method. When it's a non-static method, you have to create instance of this class to invoke it. So basically, first thing that I do is I create instance of calculator. So how do you create instance of calculator? It's with new keyword. All right, you create new and it would create instance of calculator. Now I give a call to add method, and suppose I want to add like 10 and 30. Okay, so these are the arguments and it has to be in order. In this case, since both are integer, it doesn't matter. But had it been some other data type, you have to ensure that, say for example, I write string here. What this would return is typically a result, right? Addition of two numbers. Now let's print it out. System.out.println. This is for printing result of addition is. Let's print out the result that we got here. All right, and let's end it by semicolon. So basically you have a package defined here. Within the package you have calculator, and actually it's my bad. I should have defined it right here. So it gives the right package name here. So earlier I had defined calculator within com.edureka. Again, I defined a package com.edureka, which is not required. So yeah, you can see here package as com.edureka, which is nothing but the namespace. We have public class calculator. So public is nothing but the access specifier for this class. Class is the keyword used for defining class, and calculator is the name of your class. Also, one thing to note is the name of the Java file should be same as the name of the class. So that is something that IDE or IntelliJ would do it for you. You just have to create class and it would create class. So basically, if you go to the source folder, you would have something like calculator.java. All right. Then you have public method, which is again, here's the method that we have defined. Public is the access modifier for this method. Integer is the return type. Add is the name of the method. It's taking two arguments, arg1, arg2. Within the body, you are adding two numbers and you are returning result, which is integer, which aligns to the signature that you have put here. All right, in the main method, just to check whether this add method is functioning properly, what you do is you create the instance of calculator, you add two numbers, you pass two numbers to it, 10 and 30, and we are going to print the result and see if it returns as expected. So here basically it should print the result as 40 since adding 10 and 30. So remember, while it builds it, it would compile into a class file. Okay, the .java file would be compiled if it's properly written. If it's syntactically correct, it would create .class file. All right, let's wait for it to run. Okay, so it's prompting me errors that we have in other methods. So let me do one thing. Let me delete the other classes that we defined yesterday. So I go to the source folder, com.edureka. So I'm just deleting these classes that we defined yesterday so that we don't spend time in actually correcting it. All right, so put it into a backup folder. All right, so okay, so we have only this calculator class now. I run this. So yeah, you can see here it has printed result of addition is 40. So basically what it has done is adding these two numbers, 10 and 30. All right, so that's what we have here. So we're adding two numbers. So let's talk about the sequence of how all this is being carried out by Java, right? When you run a particular program, how things work out. When you run a class, the first thing that's been called is the main method. Okay. JVM is nothing but Java Virtual Machine, which runs the program for you, which is part of JRE, Java Runtime Environment. When you run a particular class, it would search for a main method. And if it doesn't have a main method, then it would give you an error saying that a class can't be run. So it's pretty much similar to an executable file, right? So if you're trying to run a class, it has to have a main method, or you won't be able to run the class directly. So that's where the execution starts from. That's the entry point for your program. Okay. So once it encounters main and everything is good, your JVM would start executing the statements that are there within your main method. Okay. So in the addition case that we saw within the main method, we created the instance of calculator and we invoked add method, right? So when we ran that particular class, you could see that the addition was done. So basically what's happening behind the scenes is, JVM would execute the sequence of statements that you have within main. So again, coming back to the example, add example. So within the main, you invoke the add method, right? When you invoke add method, the control would go to the add numbers method and it would again execute whatever functionality you have put within that particular method. This case, it was addition of two numbers, so it would execute it. Once the execution is done, it would return whatever is being written out. So in this case, ours was addition of two numbers. So it would return addition of two numbers back to the calling program. So your calling method was the main method wherein you called this add numbers from. Okay. So it would come back to the main method and that's how it prints it out. So following the invocation of add numbers, you could see that we have printed out the result that comes out of this add numbers. And that's how it gets printed onto your console. So that's the sequence of execution that happens behind the scenes. Now, what are the ways in which you could call a method? There's call by value. Call by value is nothing but instead of passing the memory location, it passes the value of a particular variable. Okay. So this is similar to call by value and call by reference that we have in C. Okay. Instead of passing the memory reference or instead of passing the reference, it's just a value that's been passed. So if you change something within the method, or if you change the value that's been passed within the method, only the local copy would change, whereas the main copy would remain as is. But basically, call by value is just passing the value, but not the actual reference. All right, so to understand call by value, so this would give you some idea. So say for example, I have integer arg1, which is equal to 10, integer arg2, which is equal to 30. Okay, now I pass arg1 comma arg2. So what's happening here is it's passed by value. So suppose you change So what I'm trying to say is here, if you change arg1 to something else, say 100. Okay, so what we are trying to do here is we are trying to pass this to arguments arg1, arg2 to add method. And within the add method, we are changing this arg1 to 100. Basically, we would check whether this 100 is being reflected in arg1 here. Okay, arg1 here would change to 100 as well. Let's see what happens here. Okay, so I print it, okay, before passing it by value. So I print arg1 here, okay, and after I give a call, I would again print it. Printing arg1 after passing it by value to a method, add method. All right, so let's run this. So basically, since it's passed by value, arg1 would remain as 10. Okay, so that's what pass by value is all about. So here you can see arg1 before passing was 10 and arg1 after passing was again 10. All right, so the change that you made here doesn't reflect here. So that's passed by value. All right, so there's one more concept of method overloading. So within Java, you could have same methods with different number of parameters. Same method, when I say same method, it has got a same method name, which would take variable number of parameters. Okay, the overloading happens at the compile time itself. So during compile time, JVM understands to which method you are actually giving a call based on the actual parameters you pass on. So just to give you a fair idea about this, I define one more method, say add, which takes say integer arg1. Let's keep this add as. So I define three parameters here. So instead of two, I define three parameters here. This is nothing but method overloading. All right. So here I define arg1 plus arg2 plus arg3. All right. So we sum it up here and we return it back to the calling program. So one thing to note here is it's not giving you compile time error, right? So you can see that it has accepted this add method as well. So you can see here the signature is pretty much same. Only thing is we have one more extra parameter, which is arg3. So it is treating these two methods as a different method. That's what method overloading is all about. Suppose I define one more arg3, I say 40. All right. So we have three parameters here. I'm giving a call to add arg1, arg2. If I put arg1, arg2, the first add method would be called. If I have one more arg3, now the second add parameter or the second add method would be called. So let's define result from new add method, right? So here we say, okay. So as I said, we have overloaded the add method. Overloading is nothing but same method name, but different arguments or different number of arguments. Or it could be different types as well. You could have only two arguments, but one is integer and one is something else. Say for example, string, that also works. So basically different data types, same number of arguments, but different data types or different number of arguments. All right, so here we are adding three numbers and let's run this. So it's going to add 10, 30 and 40, which is nothing but 80. So this is done at the compile time. As I said, this linking is done by JVM at the compile time. So here you can see result from new add method is 80. During runtime, you can see that it invoked this particular method and not this one. All right. Now let's start off with arrays, right? What is the concept of arrays? So again, this is similar to other programming languages. Arrays are nothing but grouping data or grouping values of same data type. Okay. So arrays are used to solve the problem of storing multiple elements of the same data type. Okay. An array is group of like typed variables that are referred to by a common name. So you define a name for the array, and in the future you can use this name to access it. Okay. Specific element in an array is accessed by its index. As you could imagine, since we are grouping, you would have multiple elements, right? You could add something to it, or you could delete something, or you could add it to the end, insert it in the between of the array, or just search something, or just search by index, right? You would give some specific index and get element from that particular index. So we would be looking at the program which would give you a clear idea about this. But basically array is nothing but group of or its multiple elements of the same data type. Array type is fixed and cannot be changed. So in Java, when you define an array, you either give the number of elements that you can store in the array, which is nothing but the array size, or you have to give the values that a particular array would contain right when you define it. Okay. But all in all, you have to make sure that when you define an array, you give the size as well, which cannot be changed in the future. The size of the array has to be mentioned during the declaration itself. So here's an example of array. This array has around which has four subjects, which stores marks of four subjects for a student. Okay. So here you could see indexes in the white box, which says 0, 1, 2, 3. It's always in sequence. It starts with 0 and it ends with n minus 1. So basically this array is of size 4, which starts from index ranges from 0 to 3. All right. The value that is stored is nothing but that's the marks in a particular subject, which is like 87, 60, 70, and 80. That's a value that's been stored into this array. Okay. We can access any of these indexes. Suppose you want to access at index 1, you could do it. You need to define upfront, you need to define on the size of the array upfront. This is how it's been done. Okay, so this is how you declare a array. So we saw how we usually declare integer and stuff like that in Java, but here we are declaring array. All right, so this is an integer array, and you can see square brackets here. All right, this tells JVM that we are trying to define array of type integer. All right, so again, we use the same keyword, which is nothing but new. New keyword is used to create a particular array. All right, and here we are defining array of size 5. So this is one way of declaring array. The other one would be through initializer itself. So when you declare it, you give what are the values that particular array is holding up. In the first case, you're not giving the values, you are just defining an array which reserves some amount of memory, right? JVM would reserve some amount of memory, or in this case, it's 4 bytes, right? Array. So for integer, it takes 4 bytes. So it would reserve 20 bytes for array of size 5. All right. So in the second case, as I said, it's directly initializing the array. It's putting these values directly into the memory location. Still, it would be consuming 20 bytes, but the second variant would have the values directly initialized. So when you declare an array of size 5, the range of indexes would be from 0 to 4. If you try to access index 5, you would get this exception. Exception is nothing but a anomaly situation, right? Which or something which is not expected has occurred in your program, and Java expresses such event by throwing out an exception. You can't access index 5. So different ways of declaring array. We saw that it's with new keyword. All right, so you have new int10, which would declare array of size 10. Again, you could either have the square bracket at the end of the variable, or you could have it in between the type and the variable name. So behind the scenes, everything is the same. It doesn't do anything different for both, but these are different ways in which arrays could be declared. All right, the third one is similar to the last one, wherein we are initializing it directly. All All right, we are putting this value 1, 2, 3, 4, 5 into this array. This one is again the same. So within the square brackets, you can see that you're not defining the size of the array, but you have an initializer at the end by which you express that you want to put in 1, 2, 3, 4, 5 into this array. So basically 1 and 2 that you see here does the same thing. It declares the array of size. The first case is 10, the second case is 5 though, but behind the scenes, it's doing the same thing. It's nothing different when it comes to actual reserving memory and stuff like that. It's doing the same stuff. And 3 and 4 does the same stuff. Only thing is syntactically it's varying, but what I'm trying to say is JVM doesn't do anything different to actually execute it. So the length of the array is set when it is declared, and when an array is declared, array index gets initialized. All right. So if you define an array and if you try to print the length of it, you could see that it prints out. In this case, we have declared array of size 20, and when you do x.length, when you print it out, you could see that it prints 20. All right. So what are different types of arrays that we have? Again, similar to what we have in other programming languages, we have single dimensional array and multi-dimensional array. Single dimensional array is what we saw earlier, like you define array of integer of size 5, that is a single dimensional array. So in this case, you could see a array being initialized with value 2, 4, 6, 8, and 10. That's a single dimensional array. Since we have just one dimension, one row, right? Say, for example, you want to store marks scored by a student or marks stored by a particular student, just one student, that would be a single dimensional array. All right. So say, for example, the first one is the marks code in math. The second one is the science and so on and so forth. All right. So that's single dimensional array. So now what's multi-dimensional array? So taking the same example of storing marks scored by a student. So by a particular student, it would be a single dimensional array. But suppose you want to store marks scored by all the students in all the subjects. If you want to store it, it would be a multi-dimensional array. So one particular row that you see here would be a marks secured by a student, by just one student in all the subjects. The first row would be by student 1, the second row would be by student 2, the third row would be by student 3, and so on, right? So that's where you have this application of multi-dimensional array. So how you access it is nothing but if you want to access the first element or the first index, it would be a of 0, 0, and this would be of 0, 1, and so on. So as I said, if the first column is for math, if it's a marks secured in math, this entire stuff, the first column that you see would be marks secured by all the students in math. That would be the first column. Whereas the first row is the marks secured by student A in all the subjects. So basically this could be imagined as a table in a database, right? You have a table wherein you have rows and columns. So columns are nothing but you have fields within a table, and the rows that you have are different entries that you have within a table. So this could be imagined in the same way. So you could see how the indexes are aligned. So X increases when you go down and Y increases as you go to the right. The memory allocation of array. So for single dimensional array of type integer, one integer value takes 4 bytes, right? So now when you declare an array of size 5, you would have 20 bytes reserved. That's how memory is being allocated, right? If you have a character array of size 5, it would be 10 bytes. Since each character takes 2 bytes in Java, so you would have 10 bytes reserved upfront. All right, so that's about memory location allocation in single dimensional array. And when it goes to multi-dimensional array, in this case, you have like 5 elements, right? You have array of 5, 5, which means that you have 25 elements stored within the array, right? 25 integer elements stored within the array. And each integer value takes 4 bytes for storage. So it would be 100 bytes. All right. So if you have array of If you define a multidimensional array of 5 into 5, you would have basically 100 bytes allocated for it. Let's write some programs and understand more about how these arrays operate. So we have an array of 5 elements. All right, as you could see here, 2, 4, 6, 8, and 10. Write a program to access element at a specific index. Okay, so you have an array of 5 elements, 2, 4, 6, 8, and 10, and we want to access it. We want to access particular element. All right, so let's write. So I create a class. All right, I define this as array demo. So I don't give a package name here because I'm defining a class within a package. So you could see here the package came directly because I right clicked here, right? And then created a new class. So yeah, you get this particular class here. I define a main method as a type main. It would give me a suggestion, right? So this is the entry point again for this particular class. And suppose I define integer array, and suppose I define 2, 4, 6, 8, and 10, right? So you could see here we have an array defined of size 5, okay, and you have initialized it as well. So what I was trying to say is you need to have length of the array given upfront, right? If you don't do that, it would show you an error. So you can't do something like array of integers is equal to new. So you could see here array initializer expected. All right, so either you will have to initialize it or give some value to it. So if you put here 10, you could see that it compiled, right? So either you will have to mention some indexes here or the length size of the array, or the other way is to initialize this. Okay, now you could see the compilation error has gone. So what I'm trying to say is JVM has to know about the size of the array upfront. If it doesn't know, then it would flag you with an error. All right. So we have defined this array of, let me keep it as is. Okay. So now we have defined an array of size here 5, and we have initialized values as well. Now let's try to print out values, right? So just to keep it simple, suppose it ranges, the index would range from 0 to 5 in this case. So this value 2 is stored at index 0, value 4 is stored at index 1, value 6 is stored at index 2, value 8 is stored at index 3, and 10 is stored at index 4. All right, so let's try to print 0. By the way, I want to copy it. Yeah, so I'm just printing 0, 1, and 4, and let's see what it gives out, right? So it should print 2, 4, and 10, right? So you could see here 2, 4, and 10. Now the other thing that I wanted to show is if you try to access, so let me show you what happens there, all right? So if you try to access at index 5, which doesn't exist at all, now it should give you a exception. So in Java, exceptions could be nothing but caught, and you could do something with it. So here you could see that it gave you array index out of bound exception, since 5 doesn't exist at all. The index 5 doesn't exist at all for this array. Okay, now let's define multidimensional array, write a code to find the length of row 0, right? So let's define a multidimensional array. All right, so we have a multidimensional array here. So how you define multidimensional array is something like 1, 2, 3, 4. All right, so this is a multidimensional array that you have. Okay, so we have defined a multidimensional array. The size of this array would be 2 by 2, right? 2 by 2 is the size of this array since you have 2 elements here, or let me put it to remove the confusion. Let me put it this way. So right now we have like 2 by 3, right? So you have like 2 columns and 3 rows. All right, so now let's print Actually it has to be 3 by 2 rather. Okay, now let's print the size of this array 0, right? So how we do it is again println. Now you have multi-dimensional array and you have 0. So 0th one refers to this 0, 1 and 2. Okay, dot length. So as you could see here, that individual row that you have within multi-dimensional array itself is an array. It's a single dimensional array. So multi-dimensional array is nothing but it's a array of a single dimensional array. Okay, so let me print here size of first array. I missed plus. So as you could see here, there was an exception. And since there was an exception, you won't have this particular statement executed since there was an exception here. So basically, to execute this particular statement, you should handle this particular exception. But we are not talking about handling the exception yet. So I'll have to comment this to pass through. So now you could see that it has printed out 2, which is your size of first array. So this is a program that we actually did right now. Create an array having many characters, write a program to copy elements from created array to another array, and also write a program to delete an element from an array. Okay, so I'll just talk about this right here. So we have an array here of characters, right? So basically when you want to delete something from an array, what you will have to do is you will have to shift the indexes, right? You can't delete something directly from an array. So what you will have to do is if you want to remove something, then you will have to shift the indexes. What happens is suppose you have an array of 5 integers and suppose you are deleting the second element, right? Now what you would do is you would shift, if you are deleting the second element within the array, you would shift all the elements that follows the second element to the left, right? So the third element would become the second element, the fourth would become third, and the fifth one would become the fourth. So basically you shift it. That's how you delete something from an array. All right. So other thing is about copying elements from the array. We have a utility class, which is nothing but system. System is a class itself. So as you could have seen that when I'm printing out something, I do system.out.println, right? So this system, it's a utility class in Java wherein it exposes a lot of functions within or a lot of methods, utility methods within. So one of them being array copy. So here you have to give source and the starting index and the destination. And what we are trying to do here is copy 5. So this is how we copy from one array into another, starting from index 0. So this is copying, and the other one that you see here is about delete. So as I said, deleting is nothing but we have a logic written here to shift the indexes to the left. So here we are trying to delete one at index 3, and we are just shifting elements after this index 3 to the left. That's how we delete something from an array. Now let's see what are strings. So string is nothing but, again, it's a data type within Java. So why do we have strings at all, right? We have array of characters, then why do we have string at all? So here's an example wherein you have a lot of loads of data. So you could imagine a role of a data analyst who has to analyze through a lot of data coming in, right? So nowadays it's like petabytes of information being processed throughout a day, right? Which would be very difficult to handle if you had to deal with character array. So that's where Java has come up with strings, which is nothing but a group of characters, but you don't have to deal with it. Java by itself has a class which would take care of this strings. And since strings are widely used within a program, you could imagine that name or anything that any identifier that we have is mostly we have to store it as the string. So one of the data types that's widely used within industry or which is widely used in programming is string, right? So Java has some kind of string management as well to make sure that programs run or make effective use of strings. Okay. So here what's been mentioned is James is a data analyst and he's finding it really difficult to actually deal with character array to store patients' names every time. So that's where we have string. So string is solving the problem of actually dealing with character array. So Java is actually having character array is storing characters or the characters in the string in a form of character array, but it doesn't expose it to the outside world. You can just use this class to deal with it, but you don't have to deal with character arrays. So Java string is nothing but sequence of characters. They are objects of type string class. Once a string object is created, it cannot be changed. This is the immutability functionality of Java, wherein once you write to it, you can't change the value. So this is specifically important when it comes to multi-threading, when you have multiple threads accessing a particular string, a same string. So that's when immutability helps us to make sure that multi-threading is it's thread safe. We call it as thread safe because multiple threads can access the same string just because it is immutable. All right. So what are different ways in which you declare a string? So you have string str is equal to new string, which you are not initializing the value of the string here, which could be any value. And you have string str1 is equal to Edureka, wherein you are initializing the value of the string right away. The other one is the character array. Similar to the integer array that we discussed, we have character array as well. So immutability of the string. So why do we have immutability? One is for security. So string stores a lot of useful information, like even the credentials and stuff like that, which shouldn't be accessed by external users. So this immutability factor of string helps us to keep it secure so that no one else can see it. Synchronization. So this is what I spoke about. When you have multiple threads accessing the same string, you don't have to synchronize it. Java by itself, through its immutability feature, would ensure that multiple threads can access the same string without hampering it, or it would run as it's expected. Caching. So caching is nothing but you have a string pool. So basically, if you have two strings with the same value, it won't store it. It won't store redundant copy of it. There would be just one copy in the string pool, and both these references would be pointing to that value. If you happen to change one of these references, it would point or it would create a new value in the string pool and point the other reference to it, sort of. So basically what we do is why caching is required is, as you could imagine in an application, as I said, string is widely used data type and you could have multiple references pointing to the same value of a string. So we don't want to have duplicate values stored. That's where this caching comes into picture to utilize memory efficiently. So what is string pool? As I said, string pool is all the constants that you define within the string within the application would be stored in the string pool. String pool used in Java is a pool of strings stored in Java heap memory. So we have heap memory wherein the objects are created, and that's where string pool resides as well. String pool is possible only because strings are immutable. You can't change once it is defined, you can't change it. If you change it, then you can't change that particular memory location. It creates one more entry in your string pool and the reference would point to the new entry. So the actual memory location is not getting changed. That's what immutability is all about. String pool helps in saving a lot of space for Java runtime. We are breaking on the redundancy factor here. So if you have multiple strings, or if you have multiple strings holding up the same value, it won't create multiple copies of it. There would be just one value in the string pool, which would be accessed by all the references. So basically, string pool, as we discussed, is or resides in heap memory. So string is not a primitive data type. Unlike character, char is a primitive data type. String is not a primitive data type. It's a wrapper class to array of characters, right? And this is specifically done so that Java has a mechanism to manage strings well, which is widely used data type within any application. or any programming language for that matter. Java strings are stored in string pool of heap area, which we already discussed. So we can see a string pool. So we have stack memory and heap memory. So when you have a local variable, when you define something locally, the reference is created in the stack, all right, and it points to the actual object is created in the heap, but the reference is created in the stack. So you could see S pointing to hello in string pool. Okay. So S is nothing but a reference to the string. Okay, so here we can see that we are concatenating, right? So this would give you a fair amount of idea what immutability is all about, right? So here we have string S1 is equal to happy, all right? And what we are printing out is the original string that is happy, right? So you could see here S1 is a reference that's been created in the stack. You have a string pool within your heap memory, which would store all the strings, all the constants or literals that you have defined here. So you could see happy been stored in the string pool and S1 pointing to it. Now you are trying to concatenate S1 with learning, right? So it's happy learning. So you could see that the memory location that S1 is pointing to is not changed, right? It's still pointing to happy. But there's one more constant that's been created in the string pool. That's a concatenation of happy and learning. So you could see happy learning also created. But what's important to note here is S1 is still pointing to happy. It's not pointing to happy learning. All right. So if you want S1 to actually point to happy learning, this is how you do. So you have S1, which has the value happy. All right. So you do S1.concat learning and you assign it to S1. All right. So you are assigning to the same reference as S1 and you are printing out S1. In this case, what would happen is, unlike the previous example that we saw, wherein S1 is still pointing to happy, you would see that S1 is pointing to happy learning. So here you could see that S1 is pointing to happy learning. So basically you move the reference from happy to happy learning. All right. So let's see what are strings. How do we operate on strings, right? So let me create a new class here, just string demo. I create a main method again. All right. Now what we do is string s is equal to Edureka. All right. So let's first print the length of the string. All right. So this is how this utility class, or this is how this wrapper class helps us. So it has all these utility methods, right? You just have to do s dot length. It would give you length of the string. So had we not had strings, and if you want to deal with the character arrays, you would have to print the size of the array here. All right, so when we run it, it should print 8. 8 is the size of the string, Edureka. Let's have substring. So it's a beginning index. So suppose if you give 2, so it would give you substring from index 2. So basically we are getting substring. We are getting part of the string. Substring is nothing but part of a string, right? From a particular index. So since we have given 2 here, it starts from index 2. So you have 0, E is at 0, index 0, D is at index 1, and U is at index 2. So it starts from U till the end of the string. You have compared to, you could define 2 strings and you could actually compare them and see the value. So basically, so you could have one more string defined here, something of this sort. All right, so here we compare it. So we are doing s1 dot compare to give s2. So we are comparing s1 with s2. So it compares the given string with current string. So here you can see it has shown -1, right? Since B is 1 ahead of A. So if you have same string, it would show you 0. So if it's exactly the same, it would give you 0. You have is empty. Suppose you don't have anything within your string, you could check it whether it's empty. Is empty returns a Boolean variable, which means if it's true, it is empty, and if it is false, it has some value within. We have two lowercase, we have two uppercase. In this case, suppose you want to, there could be scenario in which you want to change or you want to change the casing. So I'll just take one of it. I make it two uppercase. Okay, so S1 is nothing but we have Edureka stored within, and we are, so when I run this, you should have Edureka printed in uppercase. So here we have it in camel casing, and let's see the output. So here you can see the string was converted or translated into uppercase. So similarly, you could do lowercase, which would print string in lowercase. Now we have value of is nothing but the value of a string, value of some of the data types. So you could pass integer and you could do value of, and it would give you a convert integer into string, right? So value of is a method within string which takes different data type and converts it into string. So just to give you an example, you could have like integer I is equal to 100 string dot value of, and you give I, it's converting this I into string. So it would print the same value 100, but it's converting it into string. You could replace something within the string if you want to replace particular character within the string, which could be done with replace method. So replace method takes two parameters. Replace is a method within string which takes two parameters. First one is the character that you want to change, and the second one is the new character that you want to change replace to. Okay, so here to show s1 dot replace, I could replace e with e maybe. All right, so we are making it lowercase, and as you can see here, it's printed in uppercase E was changed to lowercase e. So that's about replace. We have contains, which again gives you Boolean type result, which says whether a particular value or particular character is present in a string. All right, so in this case, we check whether we have S2 with HELDO, and you replace D with L, which becomes hello. And now we are checking with the replaced string contains D, which it doesn't contain it, right? So it would give you false. So that's about contains. Equals is basically checks for the equality of string. It takes one argument and it compares it against the string object against which you invoke the equals against. All right, so to give you an example, so you have S1, which is Edureka. Now to print it, so here we do S1 dot printing equality of string. So since it's the same, it would give you true. If had it been different, it would give you false. So you can see here it's printing both the strings are the same. You have different methods like compare, ignore case, wherein in this case we compared with case, right? If you would have had Eureka in lowercase, right? If it would have started with lowercase e, you wouldn't have got 0 here, all right? Whereas there's one more method which is s1.compare to ignore case, wherein it doesn't consider the case, right? So even if there's a case change, if there's one in uppercase and one in lowercase, still it would match, or still it would give the value as 0, which means both the strings are the same. We could get some character out from a string. Okay, there's a method character at. There's ends with, which again returns a Boolean value saying that whether a string ends with a particular character. All right, so here what we are doing is we are checking whether the string P, which holds the value happy learning, is ending with U, which doesn't, right? That's the reason it gave you false. Had it been G here, it would have given you true. Now that's about strings. Now let's talk about different variant of strings and why do we need it. So there are like three variants of string. One is the string class itself. The other one is string buffer, and you have a string builder. So we'll talk about why do we need these variants at the first place. So string buffer is nothing but it's good for multi-threading. When you have multiple threads, usually it's good to have string buffer because all the reads and writes that you do on the string, it is synchronized. So when I say synchronized, there's only one thread that could access a particular method within a class at any given point. So you can't have multiple threads going in and changing the value or doing something. So basically, if you have a string within your application which is being accessed by multiple threads, it's better to go with string buffer. Or if there's a lot of not accessed as such, access is one factor, but of course, if there are a lot of modifications done and stuff like that, like with string buffer, you could append to a particular string, which cannot be done in string, right? In string buffer, you could actually do a lot of things which cannot be done in string. And just to make it thread safe, they have made all the methods that modify the string contents as synchronized so that only one thread can access it at any given point. So see, you can see insert here, right? In string, you don't have all these methods. You don't have methods to manipulate the strings in string, right? Whereas in string buffer, you have methods to manipulate the strings. So when I say strings, those are literal strings, right? Not the string class. All right, so here we have string buffer and we are trying to append something to the string buffer. So we define a class, we define string buffer. So you could have like s1 dot append, and when you see append, you could see that it appends any data type. This is the important factor in string buffer. You have a lot of utility methods within, or you have a lot of methods to manipulate the string, which you don't have it in string class. All right. So this is mutable, right? You're changing the values. Suppose I append 3 exclamation marks to it, right? So what we are doing here is we are just printing out the new string. All right. So basically you should see Edureka and the 3 exclamation marks. Yeah, as you could see here, it got appended. Right? So basically it's a mutable string. Change the value within. Insert is nothing but inserts a new character at the given position. So here we are saying that insert W at position 0. You could replace it, replace particular or replace substring with a new string. So here what we are saying is replace index starting from 0 till 2 with this new character sequence. You could delete something from it, delete sequence of it. So here we are saying from index 0, delete one character. So if you have 2, then it would delete 2 characters. So basically, when you say 2 characters, even this E would have been gone. Okay, in this case, we are just deleting one character. So basically, this delete method takes the starting index and the number of characters following the starting index. Reverse, you have like you could reverse the entire string. Okay, so just to show you, I can new string dot, if I reverse it. So basically, these are kind of utility methods which we often use, right? So you can see it's been reversed here. All right, you can see the capacity of the string. Capacity of the string buffer is nothing but I think it reserves 16 characters initially when you declare it, and it keeps on incrementing it. So it has a growth factor defined within, which you need not take care of at this point, which you need not think about it at this point, because those are internals to Java. But initially, when you declare a string buffer stores space for 16 characters, which is 32 bytes. If we have string buffer, why do we have string builder, right? So string buffer, as I said, has some drawbacks. What are the drawbacks is more about string buffer is synchronized. When I say synchronized, which means that only one thread can enter it, only one thread can process it. So basically, if you have a multi-thread application, you should go with synchronization, because synchronization has some overhead, right? It has its own trade-offs. So when you use synchronized, what happens is when you move out of the synchronized methods, JVM internally has to do some operations which takes some time. So basically, it's good to avoid synchronization, and which would make the application much more faster. And that's where string builder comes into picture. If it's a single threaded application wherein you know that you don't have multiple threads which are going to access a particular string, in that case, you should go with string builder as against string buffer, because string buffer would give you a slightly lower in performance compared to string builder. Most of the things that string buffer does is done by string builder as well, as far as the functionality is concerned, but it's not thread safe. String builder is faster, but it's not thread safe, which means that you cannot have multiple threads accessing it. All right. So to keep it simple, if you have multiple threads accessing a string buffer, then you should go with string buffer. But if you have a single threaded application, you should go with string builder, which would make the application much more faster than string buffer. Again, with string builder, the default capacity is 16. When you initialize it, it stores, as you could see, it allocated 16 space for 16 characters initially. So as far as the demo is concerned, it's pretty much similar to string buffer. As far as the outcome is concerned, it's pretty much similar to string buffer. There's no difference as such, but as far as the performance is concerned, string builder is faster than string buffer, because it's not synchronized. Okay, so you define a string builder with happy and you append learning to it. Okay, and if you try to print sb1, which is appended with learning, you will see happy learning, would see it being appended. Okay, similar to string buffer, when you delete character from index position 0 and one character from that position, you would see that the h, which is the first character, has been deleted out. So you could see that at index 1, you could insert welcome. You can see the entire string, that is welcome, being inserted between. Okay. Then you have reverse. You could reverse the entire string, pretty much similar to string buffer. So again, this one is very similar. You are appending, you are deleting, then you are inserting here, you are reversing here. This is pretty much similar to what we did for string buffer as far as the syntax and semantics is concerned. And the outcome is the same as well, just a performance change in terms of speed, right? So when to use string buffer and string builder? As I said, if you have multiple threads, you should go with string buffer to make it thread safe, but it would be slower as compared to string builder. Okay. String builder is specifically good enough when you have single threaded application, and it would be faster since it's not synchronized. So to make it thread safe, you have synchronization, which adds overhead to the performance, which takes toll on the performance. That's why string buffer is slower. Why to use object-oriented concepts? So let's talk about classes and objects. So classes are nothing but it has got a state and behavior, right? As you could see, you have a class and you have different objects, right? There's a phone which is a class and which has got different types of phones, right? A rotary phone, then you have a touch tone phone, and you have a cellular phone. These are objects basically, right? So you define phone, which is pretty much generic and which has got state and behavior. Class is something that is generic, that has got state and behavior. But objects is something that is an instance of a class which would have specific state and behavior. So phone by itself, phone is a class by itself, which may or may not have specific behavior. But you could see that the specific phones will have its own behavior. You could define its own behavior. So all these three things that you see here, three types of phones, are nothing but objects of phone class. State is something that is defined by instance variables, right? It's a class level variable, right? At the class level, you define something. that gives state, and behavior is nothing but something that is defined by methods. Like calculator was a class wherein we had a add method, and add method basically gave some behavior to the calculator class, right? So what are attributes? So you have a class and you have attributes. Attributes are nothing but a property of an object. And in Java, this is defined by your instance variables. Basically, class will have properties, which is nothing but the state, which would be defined by instance variables. And you could imagine every instance will have its own set of properties. It won't be the same, right? In terms of the phone that we saw earlier, there were three different types of phones. You could imagine that it would have different properties, right? It's not the same. So what are the naming conventions in generally used at the industry level for Java? So this is not something that is actually taken care by compiler. So even if you don't follow these naming conventions, still the compiler would pass through. But these are best practices, or this is good to have thing in the industry. Conventions is more about to keep everyone on the same page and make it easier for other developers to understand more, right? Or keep things simpler. So that's why we have conventions. If we wouldn't have conventions, then people would prefer to write in their own way, which would make us difficult to understand. All right, so for class name, it should start with uppercase. As we saw in all the examples, you would see that I have always used started with the uppercase, or it's rather camel casing. So in this case, you could see string buffer demo, right? So it starts with uppercase. You have B, which is again uppercase. You have D, which is again uppercase. This is nothing but camel casing. It starts with uppercase. Basically, it follows camel casing. Interface name is again similar to class. It starts with uppercase. You have method name, which should be lowercase always, which should start with lowercase, but you could have it follows camel casing, but it has to start with lowercase. So main is a predefined method within Java, right? So you could see main starting with lowercase. Or I created add, right? Add is again, you could see uppercase. If you would have, say, for example, add numbers, you would have something of this sort, add numbers. So if you want to append numbers to it, it should start with uppercase. So basically it's camel casing, but starting with lowercase. Whereas class name, it's a camel casing which starts with uppercase. Variable name is again camel casing, which should start with lowercase. And constant is always like it has to be everything in uppercase. So basically, if I define a constant final string, I would write something like this. Okay, so, and if you want to add more words to it, it should be like this, underscore. So it should be separated out by underscore. All right, so these are the conventions that's followed in industry by Java community. So mostly, even if you go to the source code, if you want to see something, dig into the source code of Java, you would see same naming convention being followed. Types of variables, we spoke about the types of variables. Again, to brief you through, we have local variables. Local variables are nothing but the variables that are defined in a method. So if we define something within a method, that's local variable. So arg100, or suppose I define int local var is equal to 100. So this is a local variable, right? If you remember, this is within the scope of a method. Once the control goes out of a method, your variable is no longer accessible. And also it gives space for the JVM, for garbage collector, to kick in and clean up this particular memory space. Instance variables are nothing but it's defined at the instance level. So here, for that matter, this constant is also instance variable. All right, so I can define integer. Variable starts with lowercase and it follows camel casing. So this integer is nothing but an instance variable. It's at the class level, right? When your class is loaded, when you refer to this particular class, you would have your instance variable initialized by Java. So instance variables are declared in a class, but outside a method, constructor, or any block. Okay. Class variables are nothing but static variables, and it is one copy per class. So as against instance variable, which is one per object, whereas static variable or class level variable are it's just one per class. So if you define static, this is just one per class, and this could be accessed directly using calculator dot constant example. You would be able to access it, but for instance variable, you need to have an object created. This is non-static, basically non-static instance variable. So one of the reasons why you need to access instance variable is because different instances might have different values for a particular instance variable, right? I could define calculator 1, right? Or let me put it as calculator, and we have like normal calculator. You could have one more class which is like scientific calculator. It's one more object. Now normal calculator can have its instance value as 10, and scientific calculator can have its instance value as 100. You have different values, but whereas in static, since it's one per class, it's not at the object level. So you have demo D is equal to new demo, which is an instance of a class demo, and you print message, right? D.print message, and it should print this message. So basically there's a class demo which has got a method print message, and we are trying to invoke that message from the main method. Okay, let's talk about the constructor. Constructor is nothing but when you invoke new keyword, new calculator, there's a constructor, implicit constructor for each class, which is without any parameters. So we'll talk about that. But when you do new calculator, basically there's a method which could be used by the programmers to initialize variables. If they want to initialize something, so for each instance, if you want the same value for an instance variable, you could initialize it within constructor. So basically constructors are for initialization, or if you want to do some kind of pre-processing, right? On invocation, if you want to initialize something or do some kind of pre-processing, that could be done through constructor. Constructor is used in creation of an object. It is a block of the code used to initialize an object. So when I say initialize an object, it's nothing but initialize some property or variable within your class. Constructor must have the same name as the class it is in, and it does not have any return type. So unlike method, which has got a return type, constructor won't have a return type at all, because what we are trying to do through constructor is just to initialize objects within, but you can't return something out of it. So basically constructor is a special method which you don't have control over. You're not doing anything within it. You're not trying to actually return something out of it, right? You don't have control over its invocation. It's done by JVM itself. JVM calls a special method when you invoke new, or when you create instance of it by using this new keyword. Constructors are of two types, default constructor and parameterized constructor. So when I say default constructor and parameterized constructor, this is nothing but, so I'm defining a constructor now, calculator. As I said, it has to have the same name as the class. Okay, so this is a constructor. And as I said, this could be used for initialization of variables. Say I initialize this to 200. So for all the objects, you would see this being initialized to 200. That's the initialization. Okay, so I have created two instances of it, two instances of calculator class, that is normal calculator and scientific calculator. Let me do normal calculator dot instance variable. Okay, so here we are printing the value of the instance variable. Let me copy the same thing again, but in this case, the second case, I would be as you could see here, we have a constructor. I defined a constructor here, constructor for a class, which is initializing the instance variable to value 200. So as and when you call this new calculator, a new instance of calculator would be created. the first thing that would be called is this constructor, and which would initialize it. So basically what we are trying to do here is we are right after the construction of this particular object, we are going to print the values of instance variable to see if it assigned 200 to it. So here you could see the value 200 being printed out. So basically, if I wouldn't have constructor, then the value wouldn't have been 200. So let me comment out this one. This is how we comment in Java, by the way. This is a block comment which starts with slash and asterisk and which ends with asterisk and slash. So I commented out that one. I commented out the constructor, and you would see the value being initialized to 0. So you could see value being initialized to 0. All right, so that's what constructor is all about. Now this is a default constructor. You could have parameterized constructor, which is like integer, you provide some value, right? And you assign this value to variable. So instead of hard coding this value of 200 for the instance variable, you could pass on some value during the construction of the object. So basically what we are doing here is I pass 30 here and I pass 40 here. All right, so I'm passing 30 and I'm passing 40 to the constructor. And as you could see here, we are initializing the instance variable to that value. So basically for normal calculator, it should be 30, and for scientific, it should be 40. Yeah, as you could see here, you have 30 and 40 being printed out, and this is the parameterized constructor. That's what this default and parameterized constructor, and that's what it is all about. So default constructor is you don't even have to specify any constructor. So I commented this calculator constructor. Still implicitly there's a constructor put in by JVM, which is the default constructor. So it's not mandatory to have constructor each time unless you want to initialize something. So what's the difference between constructor and a method? Constructor must not have a return type, whereas method may or may not have a return type. Here you could see that unlike the methods add integer which return something, this doesn't say anything. This doesn't return anything because we are not doing anything within it. We are just initializing it, initializing some instance variables, right? Constructor name must be same as the class. So this is a contract. This has to be followed. Constructor has to have same name as the class. Since you are not invoking the constructor by yourself, it's done by the JVM. You don't have control over invocation of constructor, and you have to follow the naming pattern that Java recommends to, or Java forces us to. You have to make sure that constructor is given the same name as the class name, whereas method can have any name. As we saw the add method, you're free to use whatever method name that you want to. Constructor is used to initialize the state of an object. We saw the instance variable being initialized within the constructor. Method is basically, it gives some behavior to a class, right? We saw add method, which is giving some behavior to the calculator method, which is nothing but adding up to numbers. Similarly, you could have multiply, you could have divide and stuff like that, which adds more behavior to it. Constructor is invoked implicitly, so you don't have control over invocation of constructor, which is done by Java itself. When you try to instantiate a class or when you use the new keyword, it's implicitly invoked by Java, by JVM. Whereas method, you have to invoke it manually. So basically, when you do this, constructor is called by itself. Whereas when you want to call add numbers, you have to invoke it explicitly. How does constructor work? The moment object of a class is created, the constructor of the class is called, which initializes the class attributes, right? So we saw about this. So when you use the new keyword, JVM by itself would give a call to the constructor, which could be used for initializing instance variables within your class. So type of constructors, there's default constructor and there's parameterized constructor, which we already spoke about. The constructor which is created by the compiler without any parameters is the default constructor, and the constructor with specific number of parameters is called parameterized constructor. So here we spoke about this already. So we have integer value, right? This is a parameterized constructor since you are passing parameter to the constructor. Whereas if you don't define anything, Java by itself. So in this case, you could see that we didn't have a constructor for this class, right? Array demo, we don't have constructor for this class. So Java by itself puts a default constructor for array demo, which is known as default constructor. So it's not mandatory that you need to have constructor every time since Java takes care of it. That's the differentiation between default constructor and parameterized constructor. We use parameterized constructor for passing values to the constructor and initializing something based on the value that's been passed in rather. So the default constructor is used to provide the default values to the object like 0, null, depending on the type, right? When I didn't have any constructor at all, for a moment, I'm going to comment this. So this is a line comment. When you put 2 slashes, it's a line comment. Okay, it's commenting just this particular line. There's a block comment and there's a line comment. Block comment is slash asterisk and ends with asterisk slash, whereas line comment is 2 slashes, forward slashes. Okay, so basically I'll comment out these constructors as well. All right, now we have this calculator class. Now let me print the value of the instance variable. Value of instance variable initialized by default constructor. All right, so we don't have a constructor at all. So that's what I'm trying to say here. I commented out this constructors, right? So we don't have a constructor at all. And when you create a new calculator, JVM by itself would have a default constructor, which is used by JVM to initialize variables within. So you would see this instance variable as value as 0, because that's what the default constructor does. It assigns some value to it. It has like specific values. For integer, it's 0. If it's a class, it would be null. So you could see the value being printed as 0. If it's a class, it would assign value null. So in this case, you have string, right? And you could see 0, null, depending on the type of instance variable that we are dealing. We saw how we passed parameters and initialized it. Constructor overloading is just like method overloading without return type. Constructor overloading in Java is a method of having more than one constructor with different parameter list. Like we defined add, we had 2 add methods, and now I have renamed this to add numbers, but basically this was add method, right? So you could have multiple methods with the same name but different parameter list, which is known as overloading. Similarly, for constructor, you could have the same paradigm. So basically what we are trying to do here is we have a constructor with one parameter that's integer. I'll define one more constructor here with 2 parameters. So we define one more parameter here, and I say, for example, I put something like this. So we are adding up these 2 parameters and putting it into instance variable. Okay. This is constructor overloading. So here you have single parameter being passed. Here you have multiple parameters being passed. So based on whatever you pass here, suppose I say 10 and 20, or I say, so on construction, you should see 130 as the value of the instance variable. Okay, as you could see here, you have the instance variable initialized to 130, which is nothing but addition of 110 and 20. And you could have something like this, just 110, which is also okay because you have a single this thing defined as well. Constructor taking a single value as well. And in this case, it would be just 110. So constructors are nothing but methods which helps in construction of object. All right, so you get 110 here. So constructor overloading is in Java is a technique of having more than one constructor with different parameter list. So we had a demo about it. As I showed, there were multiple constructors, one with one parameter and the other one with integer parameters. And during runtime, based on whatever you pass, a particular constructor would be called. In this case, you could see that in the first case, which is shop S1, you could see the first constructor being called, which has two integers as being passed. Whereas when you create object S2, which has two integer parameters and one string, you could see that second constructor is being called. Now, what's constructor chaining? So constructor chaining is the process of calling one constructor from another constructor with respect to the current object. The real purpose of constructor chaining is to pass parameters to a bunch of different constructors, but the initialization should be done at a single place. Constructor chaining can be done in two ways within the same class from the base class, and constructor chaining occurs through inheritance. So basically for constructor chaining, there are two keywords that we have. So one is this. This itself is a keyword in Java, this, THIS. This is a keyword, and this super keyword. Let's see how we do it for this particular constructor. I have this constructor which has this value, right? So instead of doing this directly, what I could do is, so here I was initializing this value directly to the instance variable. What I could do through constructor chaining is I could do this, and I could pass the value comma 0. So basically you're chaining here, right? You could see that what I'm trying to do here is I'm trying to invoke this constructor from this constructor. That's what the chain is all about. So when you say this, it tries to find constructor within your class which takes two parameters, two integer parameters, and this is the one it finds out, right? It has two parameters. And basically what we are doing is we are keeping the second parameter as 0, which means it would initialize the instance variable to whatever value you have here, right? This is what constructor chaining is all about. It's more about calling constructor of the same class within the constructor of the same class. So basically from this constructor, you are giving a call to this constructor. That is constructor chaining. Super should be the first, I think. It gives a call to the super constructor. So you have a subclass and superclass, right? What you do here is you give a call to superclass. For constructor chaining, I think this should be good enough, wherein you use this keyword to call constructors within the same class. You basically chain them together, right? We have demonstration on constructor chaining here. When you create student, you could see there's a constructor without any parameter, and we could see this Megan being called. So basically what we are trying to do here is the default name would be Megan, right? So, and again, we have one more constructor, which is overloaded constructor, which takes name. And in that case, it would give a call with the specified name and mark as 70. So basically 70 is a default marks that we are assigning, and Megan is the default name here. If you don't provide name, it would be Megan. All right, so this is what constructor chaining is all about. Static keyword. Static keyword, again, we have spoken about in a couple of instances, but I'll just walk you through this slide again. The static keyword is used for memory management. Static is non-access modifier used in Java, accessible, applicable for blocks, methods, class variables. Static keyword is used to refer the common properties of an object. So as we spoke, it's at the class level. It's not at the object level. We have it common across all the objects, right? When the static keyword is used to declare any parameter, then memory is allocated only once for that parameter. So in this example, we could see that since it is one per class, so you would have this constant example defined just once, right? It would be allocated just once. Whereas in the non-static ones, like this instance variable, you would have memory allocated for each and every instance. So basically for this instance, you would have memory allocated for this instance variable. For again, this normal calculator that we had earlier, you would again have a memory allocated for instance variable. All right, so it's one per object, whereas the static ones are one per class. So yeah, memory is allocated only once for that parameter. All right, so here we can see that we have a static string company which has some company name put in there, and we are just displaying it, right? We can see that we are displaying ID, salary, and company. And you could see that for both the instances, for E1 and E2, you have two employees here with ID 25 and salary 25,000, and we have employee E2 with salary 30 and with ID 30 and salary 3,000, right? So we are defining two instances of employees, and you can see here we are not passing the company name as a parameter to the constructor, right? Still, when you display it, look at the output at the right side, you can see that it has displayed 25,000 and SRT traders. The company name came by itself because it's one per class. So what we are assuming is this class is basically designed just for one company, right? That is SRT traders. So all the instances of the class, or all the employees that you create here, all the instances of employees that you create here will have the same company name that is defined here, since it is one per class, right? Whereas their ID and salary would be variable, which would differ as per the value that you pass to the constructor. Here we can see that company is a static variable. It allocates memory only once. So here it could be seen that you, as I mentioned earlier, you have reference variables being created out in the stack. And in the heap memory, you could see values being stored. So ID is 25, salary is 25,000. For E2, ID is 30 and salary is 3,000. And you can see the static variable. So basically static variable is stored in a different space, which is permanent generation memory. That's where the static variables are stored. So a method could have static as well. When a method is static, you need not create instance of a method to call that method, instance of a class to call that method. Pretty much similar to static variables, right? So basically I can have one more static method here. So say for example, I have private static. All right, so what I was trying to say here is you could have calculator dot, and you could directly call the display method. So you need not have instance of a class created. It's at the class level. This is at the class level rather, right? One per class. Let's talk about this keyword. This keyword is used as a reference variable to the current object. So basically, what it is trying to say here is, so if I want to print something here, let me print the instance variable, right? So within the add method, what I'm trying to do is I'm printing the value of instance variable within add numbers, right? So I'm trying to print the value of the instance variable within add numbers, which would be basically, this is where we are calling add numbers. So basically it should be 110, right? When we have such scenarios wherein we refer to an instance variable within a method, we could see here printing the value of instance variable within add numbers gives you 110, right? Implicitly what happens is it puts this dot here, this dot instance variable. All right. So what we are trying to say is the instance on which the add numbers was called, on the same instance, whatever the value of instance variable is, just print that thing out. So this is implicitly put in here. You need not use this keyword. This keyword is usually used when you have something like this, right? when you have instance variable. Suppose you have something of this sort, right? One of your parameters is same as the instance variable, right? So you want to differentiate which is the instance variable and which is this variable, right? So that's when you use this. When you say this dot instance variable, this is referring to this instance variable, and this instance variable to the right hand side is referring to this one. All right. So that's when you have to explicitly put this, or in other cases, it's done by the JVM itself. You did not take care of it. All right. So this can be passed as an argument in the constructor call. This can be used to invoke current class method. This can be passed as an argument in the method call, and this can be used to invoke current class constructor. This could be passed basically if there is one more. So say for example, you have something of this sort, which is very vague though, but add method taking calculator as its parameter. Okay. So I'm just trying to demo, you could actually take calculator as an argument for any of the methods within. All right. So you have an add method which takes calculator as its parameter. All right. So here, say for example, within this method, don't think about the logic. It's not logical though. I'm just trying to show you it could be done, right? So I have add and I put this. Within your method, you could pass as an argument. You could pass this as an argument. So basically you are invoking this one. So now if I print it, you can see in add numbers, you have this method being called. So yeah, here you can see printing out the add method taking calculator as its parameter. So basically it's calling this on by passing this. So yeah, we spoke about the constructor earlier. We saw how this could be used in the constructor. And one of the use cases, as I said, here you could see that similar to the example that I spoke regarding the instance variable, you could see the parameter, the name of the parameter is roll number, which is same as the name of the instance variable. This one is pretty much similar to that. You could see that the name of the parameter that is passed to the constructor is same as the instance variable name. The roll number to the left hand side is nothing but instance variable within the class info, whereas to the right hand side it's a roll number that is passed as an argument to the constructor. Similarly, for the name, you have this dot name, which is referring to the name, the instance variable in the class info, and to the right hand side it's a parameter that's passed to the constructor. That's a typical use of this. So we are creating a message here, and you can see that we are giving a call within the constructor. This is within the constructor actually. So we saw this in the previous example. Basically, this is what it does, right? This value of 0, that is what this is doing. Within the constructor, you have this, and you are giving a call. So in this case, this Annie would give a call to message string n and would print it out. So how does it work? The main function is executed. So again, this is a sequence in which the things execute behind the scenes. The main function is executed first. When an object of the class is created, a default constructor is called. Okay, in this case, the one without parameter is called, right? Then you have this dot Annie, which is nothing but you're giving a call to the constructor within the same class, but with the parameter Annie. So the JVM would check whether you have a constructor with parameter as string. So it finds it and it would give a call to that constructor, which is nothing but the constructor that you see here in a blue block, right? Then it would, similar to any method, after the method invocation is done, it comes back to the calling method, right? So after this Annie is called, it comes back here, then it prints welcome to Edureka. And once this is done, it would go back to the main method. In general, what happens is whenever a method is invoked, The local variables and everything is pushed onto the stack, similar to C, right? In C also you have a calling stack. So your local variables go into the stack, the calling method is invoked. After the method is being invoked and is completely done, it would come back to the stack and start off from where it had left earlier. So typically how the subroutines and everything work in programming language, that's how it's done in Java as well. So that's why we have calling stack. So that's a sequence of execution that happens. So let's start off with object-oriented programming concepts. This is pretty much generic. This is not something that is just for Java. So this is an object-oriented programming concept, which usually all the object-oriented programming languages use it or adhere to it. So we have inheritance, which we'll be covering up in the topics to come. Polymorphism, which is we have like static polymorphism and we have dynamic polymorphism. Cover it up in details in the coming slides. We'll talk about what is abstraction and also how Java has encapsulation or how Java is aligned towards the encapsulation feature of object-oriented programming. So let's start off with inheritance. Just to give you an analogy, you could think of inheritance anything that is derived. You have some superclass or you have something from which other subclasses are derived. When you have some feature of your parents, we say that you inherit it, right? Because you have got it from your parent. So you have a parent. So this could be analogical to something of that sort. Maybe your looks is inherited from your parents, sort of. That is exactly what inheritance is all about. You have a parent class and you could have subclasses out of it. And these subclasses would inherit the features or inherit state or the behavior, I would say, of your parent class. So to give you an example, as you could think of vehicle, right? Vehicle is generic thing, which could be a superclass. So vehicle could be thought of as a superclass. Now there are subclasses to vehicles. You have bike, which is a type of vehicle. You have car, which is a type of vehicle. You have buses, which is again a variant of vehicle, and truck, of course, is again a vehicle. So basically, this defines is a relationship. Bike, if you read it out, you could clearly say that bike is a vehicle, car is a vehicle, bus is a vehicle, and similarly, truck is a vehicle. So basically, this is something like it defines is a relationship. So let's see about how actually these classes or the subclasses inherit from the parent classes. Just to read out, inheritance is a powerful feature object-oriented programming through which one object acquires some or all properties and behavior of parent object. So as I said, it's an is a relationship. So is a relationship is represented in Java through inheritance. It could also be seen as a parent-child relationship. So subclasses are actually childs of parent classes. In the previous case, you have bike, which is a subclass of superclass vehicle. So vehicle is a superclass, and henceforth we would be talking in these terms or we would be using these terminologies. So just wanted to be sure you get it. So vehicle is nothing but a superclass and bike would be henceforth referred as subclass. Child classes would be referred as subclass. So you have method overriding. What do you achieve by inheritance is more about method overriding to achieve runtime polymorphism. And the second thing is code reusability. As I mentioned, the subclass would inherit properties and behavior from your superclass or your parent class. So there could be some method defined in your superclass which need not be redefined in your subclass. It inherits by itself. That's the property of inheritance. If it has got a common behavior, like say you have two kinds of calculator, different types of calculator, the example that we spoke about yesterday. There could be a parent class calculator which is adding numbers as is. You provide two numbers, it adds up and it gives you. Maybe this add behavior could be added into the calculator class. Now, suppose there's a subclass of calculator wherein you have this scientific calculator or something, which is modifying this behavior of, or which is using the same behavior of add, right? Basically, though a normal calculator or a scientific calculator will have the same add behavior, adding up two numbers. Whatever you send it as a parameter, it would add it up and give you the result. So basically, you would define this add in the calculator. In the scientific calculator, that would be the subclass of your calculator. You need not redefine this add method. It would inherit from the calculator method. So that reduces code redundancy, or it helps you in code reusability. You need not redefine the add method again. We have a lot of slides to come about method overriding and method overloading, so I won't talk it right away. This is inheritance. You have a manager class and you have like employee, which is extending manager. So what we are trying to show here is e.salary. As you could see here, there's a salary property in a manager, and this employee 2 is extending manager. And we could see here that employee 2 inherits salary property. Though it doesn't have a salary property, we are able to access the salary property from employee 2. So let me give you an example. You just have to click on create new project and give some project name. I'll give Edureka module 3. So it opens up a new window. You could go to the source folder and you could right click on it and create a new class. So basically I'll do one thing. I'll create employee class. I'll follow the same example that's been mentioned here. I create com.edureka.manager class. So com.edureka is nothing but the package name and manager is your class name. So now I define a property here, say salary in that case, right? Suppose I say, maybe I'll put it as long salary. So I define a property within your manager, which is salary. Now I define one more class. So you could either define it within the same file or you could create a new class. For simplicity, I'll create a new class. It'll create employee. So it created an employee class within com.edureka package. Now let's do main, which is your entry point for the program. Now, as you could see, I haven't defined salary within employee. The first thing that I'll have to do is, we are talking about inheritance. So employee extends. This is a keyword used for inheritance. So employee extends manager. So now you could see there's a property which is salary, which is defined in the manager, and there's employee, which is the subclass of manager. And let's see if salary is accessible to employee, which is a subclass of manager. So I define employee, emp is equal to new employee. This is how we create instance of the class using new. Now let's see if, just for simplicity, I'll give this emp dot salary. You could see that, right? Just to be sure, I print out. So as we can see here, salary, though it's not defined in employee, it has been inherited from your manager. We can have one more instance created, which is like manager is equal to new manager. This is the instance of manager class now. I do manager dot salary is equal to salary of manager is, we are just printing it out. So what we have done here is, again, I repeat the same thing. So we have a manager. Within manager, we have defined a field salary, and we have employee, which is extending manager. And in the employee class, we don't have the field or we don't have the property salary defined here. But we could see here in this example wherein we created the instance of employee and we are accessing salary property from here, though it's not defined specifically in employee. It's been inherited from your parent class, that's manager. And manager, of course, has salary field, which has been accessed out here, and we could assign some value to it. I run the program, it should compile and create a class file out of it, and it runs the class file using JVM. So yeah, as you could see here, it's printing out values for salary of employee and manager as well. So that's about inheritance. It's inheriting the property salary from parent class. Now, what are different types of inheritance that we have? There's single inheritance wherein you have a parent class and you define a subclass out of it. So similar to what we spoke, we had a manager class and we had employee class, which was inheriting manager. That's about single inheritance. You can have hierarchical inheritance wherein you could have multiple classes inheriting from a same class. So you could have A and B inheriting from a single class. You could have multi-level inheritance wherein you have one class inheriting from another, and again you could have subclass of the subclass. Parent class, you inherit it or you subclass it or extend it, whatever you say. So there's one level. So you have a child class now. You could have one more subclass of this child class. That's what multi-level inheritance is all about. So as we go through the example, it should give you a clear idea about what I'm talking about. So single inheritance, so we have vehicle and we have bike, which is extending vehicle. So this is similar to what we defined here. So what we did here is single inheritance. You had a manager and you subclassed it, and this is just single inheritance, one level. So what is hierarchical inheritance? So you have a vehicle and you have two subclasses created out of vehicle. So there are two childs of a parent class. So this could be pretty much similar to a parent having two kids, right? There could be two kids and they inherit some property from your parent. So it's pretty much similar to that. So you have a vehicle class, which is your superclass, and you have subclasses to it. So let's see how this works. So I create a vehicle class, which is the superclass. I have a vehicle class, and say vehicle class has a property which says integer, say number of wheels. This could be one of the property of a vehicle class. You have, say for example, you have the mileage. So these are common properties that you have in vehicle. Say you have motion. Just to add a behavior to this particular class, I define method move and I just print this thing out here. I define two properties here for vehicle class, which is number of wheels and the mileage, and add a behavior to the class by introducing method, which is move, which is nothing but I'm just printing it out. So ideally you would have some functionality written within, or you would have lines of code written within. Just because we are talking about inheritance, just to show the properties and behavior is being inherited by the subclass, for simplicity's sake, we don't have any logic written within move. It's just printing it out saying that, just to indicate that, there's a move method within the vehicle class is being called. We are just printing it out there. But in reality, as I said, there would be actual logic written within. So now I define car class and I define bike class. So now I say that car is extending, which is nothing but subclass of vehicle. So remember we said is a relationship, car is a vehicle. So what we are saying is we are subclassing or we are inheriting properties of vehicle into car. Suppose I change the property of any method within, or say I can have its own movement when car class. So basically we are overriding it. What we are trying to do is we are trying to, whatever method you had within your car class or the vehicle class, you are overriding it for the car class. You are trying to change something. Similarly, in your bike class, you could override the move. So first thing that we'll have to do is bike should extend your vehicle. So bike is a vehicle, we are extending it. Now we are again overriding this move method to say move in bike class. So now basically we can have, say, one more just for simplicity's sake. We have just a class wherein you would write the main method. So this is generally a practice wherein such classes are called as client classes, wherein you have a main method and you do something with it. I just call it as automobile management class. So you have a main method. So suppose you want to change number of wheels for a car. So what you would do is car is equal to new, or it won't be car. It would be like, suppose I put Mercedes is equal to new car. I create Mercedes. I create BMW is equal to new car. So now what we do is I want to override the property that is number of wheels for Mercedes to 4. Similarly, I could have a bike class, say R1 is equal to new bike or something of this sort. You could have Ducati is equal to new bike. So this is just to give you an idea of how we have classes and objects, right? Now you could imagine what objects is all about. So Mercedes is a object of car, BMW is a object of car, R1 is a object of bike, and Ducati is again an object of bike. So now I could override the properties here, say number of vehicles as 2. So yeah, this is what it is all about. This should give you some idea about how we use Java. You have a class, you have subclasses, then you kind of create objects and you could override the properties within. And you could change, when I say override is nothing but you could modify the values within your subclasses. And similarly, you could change the behavior. Vehicle by itself would have some behavior defined, but Mercedes and BMW, which is a car, could have its own kind of behavior, which is not inherited from parent. You are overriding it. When you say this could be analogical to something like kid doesn't have the same features as their parent. It is something like it's been overridden, right? It's peculiar to that particular kid. And that's what this is all about. So you could override it. Now let me print move, or let me call the move method on BMW. So you could see a move method, and when I run it, it should show move method in car class, since it's a move method called on car. BMW is an instance of car. So this should give you some idea about how are we inheriting properties and behavior from parent class. So here we can see that move in car class. So again, you could define your own method within your subclass, which is not something that is inherited from your parent class. So BMW by itself or car by itself could have something like, say, turbo, which is not in vehicle maybe. This is specific to car. So this is what we spoke about, is hierarchical inheritance. Now let's talk about multi-level inheritance. So basically it's nothing but, say you have a superclass category. So let me use the same example. You have a vehicle class, you have a car, which is extending vehicle. Now I define one more class, which is nothing but superclass, supercar, which is extending car. Basically, I can put this turbo in supercar rather. That would make more sense. This is like kind of multi-level. So I'm putting this turbo here in supercars. You have a vehicle class. You have a car, which is subclass of vehicle. You have a supercar, which is subclass of car. So all the properties that you have in vehicle class could be accessed in car as well as supercar. That's what we want to see here. So you could have something like, say, change wheels, which is void, which is not returning anything here. I just want to show you that we can still access number of wheels here. Though it's not defined in car or supercar, but in vehicle class, you could actually, it is still visible here and you can modify it. That's the beauty of it. Again, to brief, you have a vehicle class, you have a car class, which is extending vehicle class, you have a supercar class, which is extending car class. So basically, there's a multi-level of inheritance, and all the properties and behavior that you have in vehicle class would be visible to car class as well as supercar class. And supercar class can access properties and behavior that is there specific to car class. So what I'm trying to say is, if you define a new method here, so I just mentioned here behavior specific to class to car. So there's some behavior that is specific to car that we have defined within the car class. Now supercar class can access this one as well. So you could see here, you could access behavior specific to car as well. If you look it as a tree, this is a leaf node. This is supercar class can access everything from vehicle and car class, whereas car class can access everything from vehicle class. But it's not the other way around. Car cannot access something that is specific to supercar. There's a turbo method that we have put into the supercar class. Now, if you try to access turbo from here, you won't be able to access it. All right, so it's not the other way around. So you cannot access something that is specific to your subclass in your superclass, whereas you can access anything that is there in your superclass into your subclass. So it's a one directional flow from superclass to subclass. Now let's talk about has a relationship. Has a relationship is nothing but you have properties within your class, which is has a relationship. All right. So say for example, employee, right? We define the employee class, and employee would have an ID specific to an employee, and it can have salary and stuff like that, which is has a relationship, which is nothing but employee as a ID sort of, right? So a department in a class, let's talk about this example. A department in a college has several professors. Without existence of departments, there is good chance for the professors to exist. Hence, professors and department are loosely associated, and this loose association is known as aggregation. So one can exist without other, which is loose association, and such thing is nothing but aggregation. So here you could see employee. Here you could see name class itself, which has got first and last name. So basically you have a name class which has got property as first and last, and which is nothing but the first name and the last name of any entity. It's not associated with anything. Right now it's a different entity. Name is a different entity which would have first and last name. Now there's an employee info class which has got ID and which has got name. So you can see name here. This name property is nothing but the instance of name class that is there at the left hand side. So this is has a relationship. This says that employee info has name. So basically this is what it is. When you talk about has a relationship, it's containment. It's basically you have class as a property in a class. So in this case, name is a property within your employee info. And similarly, this name could be used somewhere else as well. It's not that it has to be used just in employee info. That's a kind of detachment they have, right? It's not tightly coupled, it's loosely coupled or decoupled. So basically you have name, which is altogether a different entity defined as a class, which would have first and the last name, and you would have an employee info, which is containing name, which has name. So this is has a relationship. And also to give you idea about has a relationship, it's not just it has to be object, right? So vehicle has number of wheels. Vehicle has mileage. This could be thought of as a relationship. So let's talk about polymorphism now. When one task is performed by different ways, then it is called as polymorphism. Poly is multiple, morphism is forms. Basically, that's the meaning behind it. So multiple forms, that's what polymorphism means. And when one task is performed by different ways, then it's called as polymorphism. This person, which is a superclass, you have a subclass, student is again person, millionaire is a person. These are superclasses. So you have a person class, you have a superclass student and millionaire. You have a behavior which is nothing but pay bill and which would be specific to both of them. So as we move on, you would get much more idea about the different kinds, but basically you have multiple forms. That's what polymorphism is all about. So what is method overloading? So we spoke about this yesterday. If you remember, we spoke about constructor overloading, wherein you had multiple constructors defined. One was integer, and the other one was like it was taking three parameters, integer, and three integers, right? So basically, this is what method overloading is all about. You have the same name of a method, but you have different number of parameters passed to the method, or you have different type of parameters passed to the object, to the method, and based on that it would understand which is the method that needs to be called. So suppose you have add with two integer parameters defined and you have add with three integer parameters defined. Now when you invoke add method on a particular instance of calculator and you pass two parameters to it, it would appropriately call add method with two parameters. And if you pass three parameters to it, it would call one with three parameters, or it would resolve it during the runtime, which one to be called. Rather, it's not overloading doesn't happen during runtime. It's done during the linking or the resolving operation happens during the compile time itself. That's why it's static polymorphism. Method overloading is nothing but static polymorphism. So return type is not taken into consideration when it comes to method overloading. It's just the parameters that a particular method takes. So Alex wants to write a code which can be used to find out the area of triangle as well as of circle. So generic code which would have area of triangle and circle. So such are the instances wherein you could use method overloading. So what's the thought behind this? I want to find area of both the shapes. Here area is a common method. It's there for both the shapes. It's there for rectangle, it would be there for square, it would be there for circle, and so on and so forth. So basically you would have a shape method which would have area, which is a common method. So instead of writing two methods of different names, I'll write area as a method name for both shapes and I'll pass different arguments according to the respective shape. So instead of defining multiple area methods, you would have just a generic area method defined in your shape class and your subclasses would overload it as per the type of shape. So here we can see that there's area class, there's an area method which is taking integer. Since it's a triangle, it's base and height. So it's taking base and height as parameter. So Java doesn't understand base and height. This is user defined, by the way. It understands there are two integer parameters passed to the area. Whenever there are two integer parameters passed to area method, this one would be called. The other one is, again, we have one more method which is area, which is by the same name and which is taking just one integer parameter, which is radius. So this is supposedly for circle, pi r square. So during runtime, when you call it, So I'm not repeating this exercise again because we did the same thing yesterday. If you remember, we kind of had multiple add methods in the calculator, and we saw that it was getting resolved to the proper one based on the number of actual parameters that you pass. So I'll just read through the slides to make you give more explanation on this, but it's pretty straightforward. So here you have area method, which is taking 4, 6, which is nothing but it would get resolved to during compile time. This particular area method invocation would get resolved to this one since it is taking 2 integer parameters. The second one is taking just one integer parameter, which is 5. So it understands that it has to call this area method, the second area method that's been defined in method demo, and it will call it accordingly. So here you could see that when you run this particular program, you could see that the first one resolved it to triangle, and it said that the area of triangle is nothing but 4 into 6 into 0.5, which is nothing but 12. The second one goes to pi r square, and it gives answer as 78.5. So you could see there are two different invocations done based on the number of actual parameters. Now let's talk about type of parameter. The method overloading can happen on type of parameter as well. So you could have multiple methods with the same name taking same number of arguments but different data types. One could be taking integer as a parameter, the other one could be taking string as a parameter. And during runtime or during compile time itself, it would resolve that, this one should be resolved to this invocation and the other one should be resolved to the other one. So basically it tries to resolve based on the parameter, based on the data type of the parameter that you pass. So here's the example wherein you have two different methods. I'll take this one, say for example, I define public integer, so it's a dummy value to be printed. One of the best practices when you write Java code is to express it, right? So you can have a big variable name. You shouldn't be restricting on variable name, which makes it difficult for other programmers to understand. So it's good to have big variable name versus small one, which is not that expressive. So here I said dummy string value to be printed. I'm printing integer value, which is nothing but dummy integer value. And here I'm printing. So we have two methods with the same name, but it's taking different data types as argument, and we are just printing it out. So I define a main method here, and I define manager. So we have instance of manager, say senior manager grade 2 dot display. I pass integer to it. I pass 100 to it, and I pass. So I have two method invocations here. One is first one we are passing 100. The second one we are passing string to it, and it gets resolved. You could see that the first one would go to this display method which says printing integer value. The next one would go to this display method which prints string value. So you could see here, right? So first one is printing integer value, the second one is printing string value. So based on the type of the parameter that you pass through or pass to the method, particular method would be called. This is static polymorphism. Now what's runtime polymorphism? So since it is resolved during the compile time, it is static polymorphism. There are a few things that gets resolved during the runtime, or the compiler cannot judge it upfront what the instance would be, and that's when it does it during the runtime, and that is nothing but dynamic polymorphism or method overriding. So method overriding is mostly used in a easy relationship. So in one of the methods, or we saw in vehicle and car example, we have a move method here, and here we overrode it. You can see a override annotation here for the move because you are overriding the behavior of vehicle in car class. So that's where it says that there's a easy relationship. Method overriding must be used in case of inheritance, that is easy relationship. Method must have the same name as in the parent class. We saw in the move, in the example, move, we have the same name as in the superclass. So vehicle has a method move and car has a method move as well. Method must have the same parameters as in the parent class. As against method overloading, which has different parameters, method overriding, you have to be sure that it takes the same parameter. If I change this to integer, if I add an integer parameter to it, so it's not taking it as overriding. You could see it's not been taken as overriding because you have integer parameter to it. So basically it has to have same number of, or it has to have the same signature as your parent class. So that's about method overriding. let's have a demo on this. So which we already saw, but I'll again reiterate on that. So basically in this example, you could see there's a man class which has got a pay method, which is adding behavior to the man method. And you could see it's a dummy print there. And you have a millionaire is a man, and you could see it overrides the pay behavior. When you run this program, one thing to note here is you can assign millionaire to man. You can assign, unlike all the examples that we saw, we are creating instance of the same class or assigning the instance of a class to the same class. But in this case, you could see the instance of millionaire is being assigned to reference of man. This is something that happens only in either relationship or inheritance. So what I'm trying to say here is I go to automobile management. I have car. I have a new car, which is Mercedes. I could assign this Mercedes to vehicle. Since Mercedes is a vehicle, it should be assigned. You should be able to assign it, right? This is something that you need to keep in mind. Your subclass object could be assigned to superclass. So here we have Mercedes being assigned to vehicle. But one thing to note here again is the tricky part is vehicle itself has its own move method, which prints move in vehicle class. And Mercedes, which is car, itself has its move method, which is move in car class. So the tricky part here is when you would do something like vehicle.move, just give a thought about it, which one should be called. So you have two variants of move method here. You have one in car and one in vehicle. So the one in vehicle is printing out move in vehicle class, and the one in car is the overridden version of vehicle which says move in car class. Now what we are doing here is we are creating an instance of a car class and we are assigning that instance to vehicle and we are calling the move method. So just give a thought whether the move method on the vehicle class would be called or a move method on the car class would be called. So this is where method overriding comes into picture. So method overriding is nothing but it's a runtime polymorphism, which is done at the runtime. So during the runtime, JVM would see that Mercedes is nothing but the instance of car. Though it's assigned to vehicle, which is superclass, still an instance of class. So during compile time, JVM wouldn't have upfront knowledge that which move are you calling? Is it on vehicle class or is it on something else or some subclass of vehicle? So it doesn't decide it during the compile time. It delays it, or there's a lazy binding that happens, delays it till the time you run it. So when you run it, it understands that this vehicle is actually pointing to car, that's Mercedes. So when you run this, you could see that I'll comment out this piece of code. So this is how we comment out. That's a block comment. So when I move this, you could see that move class on car is being called and not vehicle. That is what is. If you get this concept, you're pretty good in terms of object oriented, by the way. This is an important concept in object oriented paradigm. So you could see here move in car class is being called. Similarly, vehicle could have, I call it as vehicle one, right? I define one more vehicle here, which is like new vehicle, and I invoke the method on vehicle 2. So the second variant would call the move method in a vehicle class. The first one calls on the car class, the second one calls on the vehicle class, since it's an object of vehicle itself. So basically, you have to see on the right side which is the object that's been assigned. Since it's object of vehicle, it's vehicle. But since this one is object of car, that's the reason you have car class being called. So we had some discussion on this keyword yesterday. So super keyword is similar to that. Super keyword is just that it is called on super class. This is called on the same class. Super is called on the immediate subclass, immediate parent class. You could have multi levels, right? But this one is calling the immediate parent. Used to refer immediate parent class instance variable, used to invoke parent class method. And there's one more super keyword, one more form in which you could use is to have class constructor. So basically, whenever you create a class, whenever you call a class, whenever you call constructor of a class, by default, JVM by itself would give a call to the superclass constructor, which we would be looking at in the further slides. So here we have vehicle 11, which is a superclass which defines string wheels. Vehicle moves because of wheels. So that's a string, that's a property of a vehicle. You have a truck which extends vehicle, and then within truck you're overriding the wheels property, saying that truck has 4 wheels. This is kind of you're overriding the property. It's not called overriding though when it comes to properties, but basically you're changing the values within your truck class. Print wheel is nothing but a method that's defined in a truck which would print the number of wheels in your truck class, and it has got super dot wheels which would print the number of wheels in your, or print the value of the wheels, not number of wheels, value of the wheels property within your vehicle class. So we will look at this one. So we have a vehicle class and we have a string wheels, which is a property within a vehicle class which has some value put in, right? We have a truck class again, which has got wheels and it is overriding the value. It is just changing the value as truck has 4 wheels. Within truck class, you have print wheel method, which is printing the wheel or the value that this particular wheels property holds. It would print it. First one would be the value that this particular truck class would hold. And the other one that you see here, the second print statement, which is doing super dot wheels, is actually printing the value of wheels in vehicle class. So let me show you a quick demo on this thing. So we have a vehicle class wherein we are defining the default number of wheels as 4, say for example. And now we have a bike class which is overriding vehicle class. And what we are going to do here is we are going to change the value of number of wheels. I have a method to print number of wheels, which would give, so suppose I change here number of wheels to say 2. So here we print number of wheels first, and I would have one more print statement which would be printing super dot number of wheels. Within a by class, we have a print number of wheels method. First, we are changing the number of wheels to 2, and then we are printing the number of wheels for bike and number of wheels on the super class. All right, and by default, we have set the number of wheels in the vehicle class to be 4. So we have a bike class. Now I remove this too. So now I print the number of wheels. So I create the instance of bike and I invoke print number of wheels. Now you would see that first it would print 2, and on super dot, basically this is what it's going to call. So first it will print 2. So basically here we need to have one more integer number of wheels. When it comes to instance variables, it's not overridden as such. So I have like number of wheels defined here again, and here I change number of wheels to 2. So let me run it again. So when it comes to instance variable, when you define one more field here of the same name, it's not overriding it, it's rather creating a new instance variable. So now you could see that when you print number of wheels, it's printing out 2, which is nothing but the value here, value of this instance variable. Whereas when you do super dot number of wheels, you have a default value of 4 here, which is being printed out. So on super, it gives a call to super class. So here you're creating, it's at the constructor level, and we can see that. So it's more about, as I mentioned, within your constructor, the first thing that is called when you create an instance is the super constructor is called first, and then your subclass constructor. What I mean to say is when you create instance of car, so your first thing that would be called is the constructor of vehicle, and it would do all the initialization that's required in vehicle, and then it would call the cars constructor. So what I mean to say is, for example, I create a constructor here and I print saying that we are within constructor of vehicle of superclass vehicle. Now we have this car class, and say we have constructor for car class as well. Remember we said that there's a default constructor, implicit constructor that's already been put by JVM itself. You don't have to take care about it. So I don't do anything here. So basically you need not write constructor. JVM by default writes constructor unless you want to write something or you want to initialize something. That's when you would write explicitly, you would write constructor. But in this case, since we are not initializing anything as such, I won't put a construct for car. What I'm trying to say is we are creating an instance of car here, and let's see when we create the instance of car, there's a super constructor that's been called. That's what I wanted to show. So that's why we created a constructor here for vehicle. This is not a method, this is constructor, by the way, since it has got the same name as your class and it doesn't have any return value. So I've printed it out saying that we are in the constructor. When we call this now, when we create the instance of car, you could see that this constructor of superclass, that's vehicle, that's been called. So this is done implicitly by compiler. You don't have to care about it. So here you could see whenever you create the instance of car, you would see that we are in constructor of superclass vehicle. And the second print statement that you see is directly for the vehicle instantiation. So even for car, you could see. So this will get rid of confusion. So there's only one instance of car being created and we can see that it is calling vehicle constructor. And it's implicitly put, we don't have to explicitly put it. JVM by itself operates that way. And how it calls is nothing but by super. Final keyword, we again touch based on this one earlier in the session number 1. Final keyword is non-access modifier applicable only to variable, method, or a class. When it's applied to a variable, we say that the variable content cannot be changed. Usually use final when you want to define a constant within your application. So that's final. A method could be defined as final. You define a method as final when you say that your subclass cannot override it. That's when you define it as final. You define a class as final when you say that there cannot be any subclass of that class. So you cannot subclass it. Like if you try to extend on a final class, you would get an error, compile time error saying that you cannot extend it. So just to show you, maybe if I make this as final, your car would show an error saying that you cannot inherit from final class, that's com.edureka.vehicle. So that's about final class. And if you make this method final, you would again get an error in the class saying that you cannot override this. In the car class, we are trying to override the move method. Since it's final, it's showing you an error saying that move cannot override move in com.edureka.vehicle. Overridden method is final. Let's remove this final and you should see the error is gone. And also, if you want to see at the instance level, if you define this as 4, number of wheels as 4, now within this vehicle, if you're trying to modify this number of wheels to 2, it would throw you an error saying that cannot assign a value to final variable. All right, so that's what it is. It's not an access modifier, but it regulates it in a way that you can't change the value. In case of variables, you can't change the value. In terms of class, you can't subclass it, or you cannot create a child class of a final class. And in terms of methods, if you have final method, you cannot override that particular method in your subclass. So final modifier can be applied to class, method, instance variable, class variables, local variable, and method parameters. So final variable is used to create constant variables. When it comes to variable, as I said, usually you use final variable when you want to have constants, right? And it would be final static, by the way. If you have a constant, it's usually final and static final. Final methods is used to prevent method overriding. In terms of method, in the demo that I showed you previously, we saw that we cannot override it. In terms of class, when you have a final class, you won't be able to create subclass of it, which we saw, right? It gives you an error. Some examples of final class in string class. So system class in java.lang.package is final as well. String class that we have been using, string class that's been exposed by, or Java itself has, or Java by itself defines it, that class is final as well. If you try to extend string class, it would show you an error. It would give you an error. So system is kind of putting a contract, or Java by itself is putting a contract, or is saying that cannot extend the string class. You cannot extend its behavior. You can't change anything, any of the behavior within your string class by your own. That's why they have marked it as final. If a method is declared as final, then it cannot be overridden in your child class. If a variable is declared as final, then you cannot change the value of that particular class, or cannot change the reference of that particular class when it comes to objects. So we'll see that later. A constructor cannot be declared as final. So that's a rule. You cannot declare the constructor as final. And blank final variable should be initialized in constructor. So maybe in this case, if you wouldn't have any value here, you declared this as final. If you don't have any value here, it has to be assigned in constructor. Right now it's giving an error saying that it's not initialized. If you mark it as 4, it should be gone. So it's mandatory that if you put an instance variable as final in class, it's mandatory that you assign some value in the constructor. If you don't, then compiler would throw an error. So here you can't override it. So basically you have a final method void run and you have a subclass of vehicle and you're trying to override the run method. It shows you an error. So this is what we saw in case of move was final, and when we tried to override it in car, we got an error, and it's all compile time. If you declare any class as final, you cannot override that class, which we saw. It gives you a compile time error. So when you declared a vehicle as final, and when you try to create car class, which extends vehicle class, it gave you an error because vehicle class was declared as final. Again, this is a compile time. Now, what's dynamic binding, which is also known as runtime polymorphism, is nothing but during runtime, it decides which instance of a method should be called or which method should be called. So this is in case of, again, inheritance and when you override the method in your subclass. So we saw this earlier. Again, to show you, we had this move method here, and in car you have this move method, and in automobile management we did this thing. We have a Mercedes that is assigned to class reference rather, vehicle class reference of reference named by vehicle 1. And in the second thing, we have vehicle itself. So first one is pointing to a object of car, which is Mercedes. And the second one is referring to object of vehicle itself. So this is what dynamic polymorphism is all about. The first one gives a call to the move method in car. The second one gives a call to the move method in vehicle. So yeah, you could see here. So move in car class, and then it calls a move in vehicle class. And it happens at runtime. That's why it's runtime polymorphism. So abstraction is a mechanism of hiding the implementation details from the user and only providing the functionality of a user. So basically you could have abstraction wherein on the first day we spoke about the shape class and the circle class and triangle and square and stuff like that, right? So basically shape is a class which is an abstract class which doesn't know all the functionality upfront, or it doesn't have all the behavior upfront. It doesn't know what would be the behavior of a circle class, or it doesn't know what is the behavior of a square class. When I say behavior, it's nothing but calculation of area. Calculation of area is nothing but it adds behavior to the class, and calculation of area in your square class would be different. Calculation of area in your circle class would be different. So shape by itself doesn't know what's the implementation of area method, I would say. So that is what is abstraction. There are two ways in which you could provide abstraction in Java. One is by abstraction class, which is not 100% abstract, which could have like abstract methods, like area in this case is abstract. But there could be some methods which is same throughout or common throughout all the subclasses of shape. Say for example, printing area. You just have to have a print statement which is printing area for a particular shape. From the implementation per se, it's same throughout all the classes. Area method would be something that is abstract, whereas display area could be something that is non-abstract method. So in such cases wherein you have blend of abstract as well as non-abstract methods, that's where you use abstract class. So it's not 100% abstract. Whereas in interface, interface is something which says that it has to be 100% abstract. So interface is altogether a new construct that we have in Java. When it comes to abstract class, abstract is just a modifier to a class. So you write class and you just prepend it by abstract, which makes that class an abstract class. Whereas interface is something that is a new construct that we are going to see in the coming slides. Abstract class and abstract methods. So abstract method is, as I said, area would be abstract method in this case, wherein you don't have a concrete implementation of area in your shape class. That's the scenario in such cases wherein you don't have a complete concrete implementation of a particular method, you would declare it as abstract method. And if you have an abstract method, If you have at least one abstract method in your class, you have to declare that class as abstract class, or else compiler would throw an error. So whenever you have a abstract class, it means that there is at least one method within that particular class which is declared as abstract. So when you subclass this abstract class, so shape for that matter, when you subclass shape, shape has got a area method which is abstract. Now when you subclass it, when you create circle, which is nothing but class circle which extends shape, now you are creating subclass of it. In that case, you have to ensure that you implement area. If you don't implement area, it is still kept as abstract, and you will have to make circle class as abstract as well if you don't give the actual implementation. So an abstract method is a method that is declared without implementation. Any class that contains one or more abstract methods must be declared with abstract keyword. An abstract class is a class that is declared with abstract keyword. An abstract class may or may not have all abstract methods. So as I said, it's a mixture of abstract and non-abstract methods. An abstract class is mostly used for inheritance. So let me take the same example of shape and shapes. So we define a shape which would have abstract area. This is what I was saying. So when you have at least one abstract method, the compiler would throw an error. So in this case, it is saying that you have an abstract method, but your class is not abstract. So we have to make this one as abstract. And as I said, abstract class is nothing but a modifier. You just have a modifier that you need to prepend to the class. This is abstract method. And you say you have a method which is public void. It's not returning anything. We are just displaying area. Or rather than defining it here, maybe I'll put something like, so we have a shape method, and now I declare circle method. Now this circle method is extending shape. Now it's throwing an error and it says you have to implement the abstract methods. Shape has got abstract method. If you don't implement it, as I mentioned earlier, if you don't implement it, if you choose not to implement the area method, then you will have to make this abstract. If you make this abstract, the error would go off. But in this case, since we know the concrete implementation of area for circle, we'll have to implement it. When I say we'll have to implement it, we say area and we override it. So for simplicity reason, I'll just put some value here for now. Since we are talking about abstraction, I'll just keep it simple. So basically what we are trying to do here is we have implemented area, which would be nothing but your pi r square actually. So here we have a shape class and we are overriding the area method here, and this is how you abstract it. When you run it, so basically you could have something like, suppose I create a shape utility class. So this is pretty much like overriding methods. So you could have a shape class, shape circle is equal to new circle, and you could call circle dot area. So basically what you would get is nothing but a float value, which is your area of, let me put it this way, area of circle. When I want to print it, what I would do is circle dot display area, and I print area of circle. What we have seen here is there was an abstract method area which was implemented in your subclass, that circle, and when you give a call to it, and here you could see that again, similar to vehicles that we spoke about, instance of circle is being assigned to shape, and when you give a call to it, you could see that method on circle is being called and not on shape, because shape by itself doesn't have any implementation of area. So one thing to note here is when you have abstract class, so here you could see this value being printed out, right? Abstract class would have one or more abstract methods for sure, and when you subclass it, you have to ensure that you give implementation of your abstract methods. If you choose not to implement it, then you will have to make the subclass as abstract as well. So execution of abstract method, this is pretty much similar to normal execution that we have. So the main method, you have instance of mobile class created in this case. Then there's a default constructor of mobile class gets executed. So pretty much similar to normal execution. When you create instance of Nokia, which is subclass of mobile, as I said, the first statement that you have in the constructor of subclass is nothing but super, or it calls the super constructor. So here we can see that the default constructor for super is being called when you try to instantiate Nokia. As we are running run method, but in mobile class run is an abstract method. So run method from Nokia class gets executed. Similar to the example that we saw, so shape area class area method on circle got executed and not on shape. What is encapsulation? Encapsulation is a methodology of binding code and data together into a single unit. So basically everything, it's an encapsulation. It's put as one. So you could imagine class being put as one, right? Class has got this for that matter. You see everything being encapsulated as one, right? You group this together. You group this integer and long, which is a property of vehicle, and it has got some behavior as well, which is move. It's all encapsulated as one, or it's all put together as one entity. That is nothing but encapsulation. So basically, you could imagine a capsule, right, which has got multiple ingredients, which has multiple medicines or chemical components, which are put together into one capsule, and you think capsule as one medicine, but it's basically combination of chemical components within. Other thing is for encapsulation, there's access modifier comes into picture. You have this access modifiers of private, and you have public, you have protected, you have default. This access modifiers restrict, or it restricts the visibility of a particular component of a class, say method or variable or anything. So that's an encapsulation feature of object oriented programming. You can't see everything. It's not that everything is open for everyone. So you can have restriction. You have different levels of restriction when it comes to visibility of these components. That is a part of encapsulation as well. So to achieve encapsulation in Java, declare the variables as private. Usually the best practice is not to expose everything, because once you expose something as public, or once you expose it for the application to access, you have to ensure that you maintain it, right? Because anyone can access it. So your class is becoming much more fragile. I won't talk about these topics right now, because fragility is something that is related to code quality or coupling, we say. So I don't want to touch on that, but basically the best practice is to have less visibility, restrict visibility or refrain visibility as much as possible. Try to make it as much less as possible. Make it private. Basically, if you could make all the variables as private, it would be a good thing. So basically, all non-private or public variables are liability for application. So it increases the maintenance of the application, and it's easy to break that way. If you make some changes to a class, it becomes very difficult in the future to maintain it. So usually the general practice is to keep the methods variables as private, not methods variables as private, and we have getters and setter method, which exposes, which are public methods, or mutator methods, which would expose this variable to the outside world through public. So usually we don't have setter methods, we restrict setter methods again. Usually you have a private instance variable, and you have a getter method, which is a public method, which is nothing but returns the value of the instance variable to the outside world. So data hiding, the user will have no idea about the inner implementation of the class. What are the advantages of data hiding? User need not know the core implementation of the class. It increases flexibility. We can make variables and methods read only and write only as per the requirement. So imagine if you didn't have all these access modifiers, there's only one that is public, which is exposed to everyone. So it would create a havoc. So this is basically based on your requirements. You could have different patterns of this access modifiers used within your application. It makes testing easy. So basically, third point is reusability, easy to reuse and easy to change with the new requirement. So with reusability, even the maintainability of the particular application is improved when you have this encapsulation. And easy to reuse in the sense, if imagine the other way around, wherein you have only private methods. So a class could access only the instance variables within a class, nothing from outside world. It cannot be accessed from outside as well. Imagine such a scenario, right? In that case, you would have a lot of code redundancy, right? Everywhere you would write the same code. It might be the same thing you have already implemented in some other class, but you will have to re-implement it since it's not accessible outside the class. So that's how encapsulation increases the reusability of code, and it makes testing easier, of course. So here you could see that employee one. So this is the encapsulation mutator method that I was talking about. So basically you have employee one, which has got string name, which is private. You could see here it's defined as private. When I say private, this name property would be used only within this class. If you try to access it from outside class, you would get an error. But there might be scenarios in which you want to access this name from outside class. You want to understand what its value is. In that case, you would have something like this, right? You would have getter method, get name, which is nothing but its return type is string, which is the data type for name, and it's returning the name. Now, one thing to observe here is this is public. This one was private, name was private, but get name is public, which means it could be accessed from outside as well. Similarly, you could have setters, which is not a good practice, by the way. You shouldn't have setter methods. So again, setter is something like you pass the value that you want to set this particular name variable. So basically you are saying that whatever you send through this method is going to set to the name variable. So yeah, refer to this particular example in main. So you create an instance of employee one who have e dot set name. You are setting it to Alex, and when you access it, you do e dot get name. So basically what we are trying to say here is a demo encaps is a different class. It's not the same class. So you have employee one and you have demo encaps as a different class. Though it's a different class, still you are able to access your name, employee name from this class. This is again a private instance variable. You're able to do this just because you have these getters and setters. Let's understand interfaces. Interfaces are nothing but could imagine interface as a blueprint, or it is something that it's a specification rather, right? An interface could be thought of as a specification. This is how it should be. So basically it could be say a company manufacturing bottles or remote, right? It would say that this is how it should be. Basically there should be so and so buttons, there should be this button should be here, this button should be there, and something of that sort. So basically through interface, what we do is we specify the contract. We say that this is how it should be. Now, for example, you could have specification mentioned in a piece of paper. This is how a remote should be. And there could be different vendors for this remote who would be actually manufacturing remote and which would be aligned to this particular remote specifications. Then you could check that okay, so and so specifications are met, which means that this particular thing could be used as a remote. So basically these are nothing but these are specifications for the system. So through interface you say that this is how it should be, and you would have different vendors or you would have different implementations that align to the specifications, and if they match up to the specification it means that it's a correct one. So hence an interface contains all the specifications and can be used for creating a new remote. So all you see here, there's a joystick, there's AC remote, there's TV remote and everything. It has got different things, but there's something in common, and that's what you specify through interface. An interface contains variables and methods, but the methods declared inside interface are by default abstract methods. As we saw in the earlier slide, interface is 100% abstract. So all the methods that you have within interface is abstract. An interface is used to achieve abstraction. It is used to achieve loose coupling. When I say loose coupling, it's like you are not binding everything into a class. Basically, you say that if it's a remote, it has to have these features, right? So basically, you're kind of decoupling it, or you can say that all the implementations of remote will have so and so specifications, which has been introduced by interface. Also in Java, you cannot have multiple inheritance. You cannot have a class which extends multiple classes. You cannot have car which extends vehicle and which extends, say, for example, locomotive. Locomotive is one of the classes, say, for example. So you cannot have a class which extends two classes. That is multiple inheritance. Though you could have levels and you could have hierarchical inheritance, but you cannot have multiple inheritance. But through interfaces, you can have multiple inheritance. You could implement multiple interfaces, but not multiple classes. Again, since this is inheritance, interface is 100% abstract class, and basically you create subclasses from, or you implement an interface. It's nothing but it follows is a relationship. So what's the difference between interface and a class? An interface can never be instantiated. Just to give you an example, I'll show you what interface is. So instead of this class, I'll make this interface. So this is how we define an interface. We define interface, but as I said, an interface is 100% abstract. Everything has to be abstract. You cannot have methods, something of this sort. You cannot have a concrete implementation of method. Though you could have a default method, which we would be looking at in the slides to come. But at this point, let's imagine that you have a shape class, and whatever methods you declare within your shape class has to be abstract. By default, it is abstract. You did not even mention it. By default, JVM puts it as abstract. Even if you mention it abstract, it's not a problem. It is abstract. So now when unlike extends that we do on class for interface, you implement it. So you implement shape class. So you'll have to make it public. By default, the access modifier for a method interface is public. So here you can see that we have implemented it. You could see that it's 100% abstract. So with this, you could see most of these differences being listed here. An interface should contain abstract methods, which we saw. Class can contain only concrete methods. We are talking about normal class here, not the abstract class. The members of the interface are always public, which we again saw. When I didn't implement this one as public circle, it gave me an error. So by default, it is public. The members of the class can be private, public, or protected. An interface can never have a constructor. Since we are not creating instance, the first point you can see that interfaces cannot be instantiated. Since we cannot instantiate interface, there's no need of constructor. A class can have constructor to initialize the variables, which we read yesterday. Implements keyword is used for inheritance, and whereas in terms of class, we have extends, which we saw now, right? For interfaces, we changed it to implements rather than extends. After extends keyword, any number of interfaces can be given. This is multiple inheritance that we spoke about. Whereas after extends, you can have only one and only one class. You cannot have multiple classes. Cannot contain instance fields. The only field that can appear in an interface must be declared both static and final. Can contain instance fields. So only the constants would be declared in your interfaces, whereas within class, you can have all levels of all the instance variables. Classes have implementation, whereas this is between class and abstract class. So classes have implementation, abstract classes have no implementation, or they can have implementation as well. So it's a mixture of abstract methods and non-abstract methods, as we saw. So abstract class is not 100% abstract, right? Unlike interfaces, you could have concrete implementation as well. Concrete classes are instantiated to create object. Abstract classes cannot be instantiated. Similar to interfaces, abstract classes cannot be instantiated. A concrete class can be final. An abstract class can never be final as it has no defined functions. For abstract class to be complete, it has to be extended. That's what the purpose is. Abstract class and interface is an abstract class can be extended to a class using keyword extends, and whereas interface can be implemented to a class using implements, which we saw. An abstract class can extend only one class at a time. An interface can extend number of interfaces at a time. So yeah, this is one thing wherein your interface can extend other interfaces, right? And you could have multiple interfaces extended. Abstract class can have private, default, protected, and public members. And interface members are by default public. In abstract class, keyword abstract is mandatory to declare a method as an abstract method, which we saw again. In interface, it's not mandatory because by JVM by default puts it. Abstract classes are to achieve 0 to 100% of abstraction, which means that you could have some concrete implementation as well, whereas interfaces are 100% abstract. You cannot have anything, you cannot have any implementation within. But you could have a default methods. Abstract class can have abstract and non-abstract methods. Again, yeah, abstract class can have constructors and interface cannot have constructors, which we saw earlier. Abstract class can have abstract and non-abstract methods since it's not 100% abstract, whereas interface can have only abstract methods. By the way, from Java 8, as I said, there's a default method being introduced, which is nothing but you could have a concrete implementation written within interface. Class interface relationship, you have class which extends other class. You have class which implements interface. You have interface which can extend other interface. If there's an interface already defined and you want to inherit some methods or you want to inherit the methods that you have within the other interface, you could do it using extends. A class extends another class while implements an interface, and interface extends another interface. Class cannot extend multiple classes but can implement multiple interfaces. So here you could see that there's one class which is extending the class on the top, and there's one at the right side. It's trying to extend it. If you try to extend multiple classes, it would give you a compile time error. It won't allow you to inherit from multiple classes. Whereas in this case, you could see it's implementing multiple interfaces. On the top, you could see one interface being implemented by this class, and there's one more interface to the right which is being implemented by this class. Class cannot extend multiple classes, but it could implement multiple interfaces, which gives an opening for multiple inheritance. When any interface gets compiled, compiler automatically adds access modifier to the members. So this is done by default. It's an internal addition. So here you could see interface demo, which has got one variable, that is int count is equal to 10, and it has got a method which is output. Now when this demo.java, which is an interface which gets compiled, you could see that by default it has put it as public static final. So count 10 would be given access modifier public static final. So for variables, JVM by itself puts public static final. And for methods, it would put it as public abstract. So that's the reason when we had the area method, when we tried to override it, it gave an error saying that it has to be public. So John went to a bank. He wants to credit some money to his account. So let's see this one. So basically here you could see two implementation of it. You have money interface and you have operation as its method. So now you could see two implementations of it. One is debit and the other one is credit. Within debit, we are just saying that we are writing a dummy statement there saying that we are debiting money from this account. Whereas credit is nothing but, again, we are printing saying that we are crediting money to this account. So now when you create instance of money or you create instance of credit and assign it to money and money.operation, you would have operation method on credit being called. In this example, we can see that there's a shape interface which has abstract area, and there's a circle which returns this value, right? And say I declare one more class which is square, which implements shape, and it's again throwing me an error saying that you will have to declare it, you will have to implement the method. So I override this and say I return some dummy value like 100. You have a square, and inside circle, say I so circle area, we are just hard coding it right now. We don't have to implement it. So it gives you 200. It's returning 200 as float, and this one is returning 100. So what we can do here is we have this shape utility. So here we have this thing called on circle. So I will just print it out here saying, and now I have one more, say for example, I create one more shape, which is square, nothing but new square. Now what we are doing is we are going to print out square dot area. So instead of assigning to a variable, you could do it this way as well. Area of a square. What we did is we have an interface shape and we have an area method which is abstract. We have two concrete implementations of it, circle and square, and we are instantiating circle and square here, and we are calling area method on it. By the way, you could see here that this is dynamic polymorphism. Circle and square has been assigned to the shape reference. It's not directly to the circle. You would see 100 and 200 being printed out. So circle was 200 and square was 100, and you could see 200 and 100. So it's basically dynamic polymorphisms followed in interface as well. You could extend an interface with another interface. So suppose you have one more interface, which is for now just to, so I create an interface, test interface, which has like test method. So you have a test interface, which is void test, and you could have shape, which is extending test interface. Now your circle and your square would give an error because there's one more method that you need to implement. If you don't implement it, you will have to either make this abstract. If you make it abstract, it should go off. But in this case, suppose we want to implement it, then you will have to ensure that you implement test method as well. Once you implement it, the error should be gone. Similarly, in square, you will have to implement it. So that's what is extending one interface with another, right? So basically here you could see there's walkable, there's runnable, and when you do it, when you implement runnable, you will have to ensure that you implement walk and run, both the methods. It's a class extending one class and implementing more than one interface. There's two interfaces, walk and run. So you could see animal which implements walk and run. So then it will have to implement both the methods, walk and run. Whereas there's a human class which extends animal. So this is basically there's a class which is implementing multiple interfaces and which has to ensure that it implements both the methods. So in this case, walk and run, it has to ensure that it implements walk and run. And there's one class which is extending from this particular class. And you could see here that you could assign human, which is extending, which is a subclass of animal. We could see that human could be assigned to walk and run as well, since it is implemented from there. So you could have h1.walk and h2.run sort of. You're giving a call to these methods. So basically, this is again, if you understand the idea of runtime polymorphism or dynamic polymorphism, which is nothing but assigning the instance of subclass to superclass, you should get idea behind all this thing. We are pretty much talking the same thing. All this is talking about dynamic polymorphism. If you get that thing right, you are good enough. So we are talking about default method, right? Since Java 8, you could have default implementation within your interface. You could say that you cannot have a concrete method, but you could have, if you put a concrete method, something like this, it would give you an error. Okay, it gives you an error saying that it's not allowed. But you could have it as default. Once you define as default, it's good enough. So all these methods or all these classes, circle, square, and all these classes would inherit this. They can't override it, they can't do anything with it, but they would inherit this. They can give a call though, but they can't override it. So basically, I'll just show it here. So basically you have default method, which is say, and which is printing out hello, welcome to Edureka, right? And you can see here default class interface demo, which is implementing welcome. And you could see here hello being concrete implementation of hello, which is nothing but it's printing out the message that's passed to the hello method. So though default class interface demo doesn't declare say method, it inherits from welcome. When you do out.say, you could see the default method being invoked. Here we could see that, hello, welcome to Edureka is being printed out, which is nothing but the output of default method. So basically default methods are nothing but method which cannot be overridden, but is available for all the classes that implements a particular interface or implements that interface. So rules for using private methods in interfaces. Following are the rules for using private methods in interfaces. Private interface method cannot be abstract. Private method can be used only inside interface. Private static method can be called from other static and non-static interface methods. Private non-static methods cannot be called from private static methods. This might look confusing at this point, but you could think that first of all, private interface method cannot be abstract because we want it to be implemented in some other implementation, right? We cannot keep it private since interface by itself doesn't have the implementation of it. You want to implement that method in some other class, so it cannot be private. Private method can be used only inside interface. So if you define a private method within an interface, it can be used only within the interface. So basically you could have a default method which is private, right? So basically default method itself cannot be private, but within default method, so what I'm trying to say is, so here you could have private void, which is doing nothing, but here your default method would call this private method. So private method can only be used within the interface and it's usually used within default. A private static method can be called from other static. This is pretty much similar to other classes, normal classes. Private non-static methods cannot be called from private static methods. This is a common rule that we have. Private non-static methods cannot be called from private static method. So if you have a static method, within the static method, you cannot call non-static method. Remember we mentioned it earlier, unless we create the instance of it, we can't call it. But in this case, it cannot call it at all. So it's not on a class you're invoking it, basically within an interface. So private methods is specifically, you could call private methods from within your default method in interface. And since private methods are not accessible from outside, that's the only reason you could have private method in your interface. Static methods in an interface. So you could have something like this, wherein you have interface one and you have a static method display. As you remember, static methods are more of a class level method, right? You need not have to create instance of a class to invoke a static method. If an interface has a static method, you could call it directly by interface dot the name of the interface dot the name of the method. So we can have a static method like static. So this method could be called. So you could have something like this method and you could call it directly using the interface name. So we have this. So now within shape utility, you could directly call, like, as you could see here, you could call the static method directly by the name of the interface. You cannot have normal methods within it unless it's a default one. Interface features for different JDK versions. So interface has evolved throughout the versions of JDKs. So just to brief on that, we have JDK 1 to 1.7 having normal interfaces with constant static variables. As we said, the variables that you would have in interface are typically constants, which is public, static, final, and with abstract methods, of course. In Java 8, it evolved and we have a default method. As I said, there would be one default method which would be inherited by all the interfaces extending that interface. And you have static methods as well, which was not there earlier. In Java 9 and later versions, so in industry right now, it's mostly Java 8 that's been used across. Very few have gone to Java 9. All the big data frameworks and everything we have is supporting Java 8 at this point. So with the latest version, that's Java 9 and above, we have constant static variables, abstract methods, default methods, static methods, and they have come up with these two methods which are nothing but private methods and private static methods, which was not there earlier. Now you could have these things as well. It makes very little sense to have all these scope variables, but maybe they might have thought something as a part of evolution. But at this point, I believe since these private methods cannot be called from outside, it's just that you have control over the default method. So basically, yeah, maybe if you have a big logic to be written within your default method, just to modularize it, just to break it into multiple methods, not to have one monolith big function or big method, you could have this private methods. That's what I can think. What is a package? We have been using package since day one. So package is nothing but it's a namespace. It's for avoiding collision. So basically I could write a name class with name shape and maybe someone else within my team would write the same thing, right? So basically at the end, when we archive it together, like we have a jar file, which is Java archive. When we archive these files together, there's going to be name collision, right? You wouldn't know which shape class are you referring to. So basically namespace is nothing but it adds namespace to it and it avoids collision. Classes in the same package can access each other's members. So basically you can have within a package. So we'll talk about the import statements that will give you a clear understanding of what we are talking about. But basically within a package, as you could see here, we have not done anything to refer any of these classes. So it's within a package. We have com.edureka and we have all these classes within this package. So you could see that employee or maybe manager, which is a different class in the same package, we are accessing it directly. We are not doing anything different for it. But when you want to access it from a different package, you have to do something else, which is nothing but importing the package. The normal naming convention is usually domain name. Here you could see we mentioned com.edureka. So it's usually something of that sort. org.example.hyphenated name. It has to be in lowercase, usually written in lowercase. Companies use their reversed alternate domain name to begin their package names. So basically, if you have mypackage.example.com, you would have it in reverse order. This is typically one of the best practices or practices that's been followed across industry to define the package, but it doesn't have any constraints from the Java side as such. You could do anything. So for example, if I make it uppercase, so basically it's saying that it's not showing error because of it's in uppercase, but basically you don't have a directory starting with uppercase. As per Java or from the Java side, you don't have any constraints. For example, I could do something like, so basically it does convert it into lowercase even if you give uppercase. I don't know whether this is a feature in IntelliJ IDE, or it is, of course, it has to do something with the IDE because IDE is converting it into lowercase. As far as the Java naming convention is concerned, this is what we do, but it doesn't have constraint. Java predefined packages. So Java itself has many packages. So you could imagine the entire language being written in Java source code. So basically all this you would find in the source code. When we refer to the string, string is a class which resides in java.lang. There's java.lang, which is nothing but java.language. So string is something that resides in java.lang. Object is a class which is a superclass for all the classes. So you know what superclasses are after we went through the inheritance thing. So you have superclass and you have subclasses. So the superclass for all the classes, no matter what class you use within Java, all the classes are inherited from a class called object. There's a class object in Java from which all the classes have inherited from, or all the class inherit from this particular class. Thread is used for multi-threading. Java.lang.thread is used for multi-threading. Multi-threading is nothing but two lightweight processes in order to leverage the potential of your processors. So if you have multi-core, then you could have multiple operations happening at the same instance of time. That's what thread is all for, to make it faster. You have exception class, you have system class, java.lang.system. This package is used to achieve the language functionality such as conversion of data from string to fundamental data, display the output on the console, and many more. The package is ported by default. So you don't have to specifically explicitly import this particular package. It is by default ported into your application. Java.util, this is like utility classes. You have collections and stuff like that into your java.util. This package is used for developing quality or reliable applications in Java or J2EE. This package contains various classes and interfaces which improves the performance of J2ME application. So basically these are utility classes. It does something in terms of performance or does some conversions or something of that sort. Java.io is a package which contains something like file input stream, file output stream, and stuff like that, which is basically for interacting with your files, with your IO. So basically, if you want to load something into your memory, if you want to read something from your file or write something to a file in your local directory, you would use something like java.io package. If you want to do some kind of socket networking or some kind of network programming, you would use java.net, which has something like socket, datagram packet, datagram socket, etc. We have applet. Applet is nothing but an application that gets loaded into your browser. It's not used as of now. Earlier it used to be used, but now there are a lot of other technologies that have come up. But this is something like an applet is a Java program which runs in the context of WW or World Wide Web or browser. You have java.awt, which is like event driven. Like you could have UI applications. If you click on your checkbox or button, there would be an event triggered and you would have an event handler handling it. If you click on a mouse or something, you would have an event triggered. So basically all these classes are grouped into this package, which is java.awt. So you could see java.awt.event, which has like mouse listener. This is specific to event. So without these classes, it is impossible to handle events generated by GUI components. So as far as the front end is concerned, as far as all this AWT applet is concerned, it's not in use. Basically, Java is much more useful in terms of backend programming, which means you take data and do something with your data and stuff like that. But it's not well suited for UI applications, and it's not used to that extent in market or in industry. You have java.sql, which is nothing but all your database related stuff. So if you want to connect to your Postgre or if you want to connect to Oracle, you have all the stuff written in java.sql. So mostly in java.sql you have interfaces, and this interfaces, as I said, it's nothing but specifications, and these specifications are implemented by database vendors. So it's nothing but interface is just an abstract method. It would have like 4 or 5 abstract methods within. So all this concrete implementation, someone will have to implement to use these interfaces, or someone will have a class which will implement these interfaces, and we as developers can use those classes to interact with databases. So vendors like Oracle will have its own set of implementation to the specifications that are mentioned in java.sql. As I said, most of the thing in java.sql are interfaces. So about the access modifier, we have spoken earlier. We have public, we have protected, private, and default modifier. Public is nothing but it could be accessed from anywhere within your application. So you could have your methods as public, you could have your class as public, you could have your instance variables as public, which means that particular method could be accessed from anywhere within your application. You could have protected modifier. Protected modifier is nothing but your subclasses can access it and your current package. Whatever the package in which a particular method or particular class resides, in which you have protected method, you could access it from that class, or any class from that particular package access the protected methods defined within a class in that package. So I'll give you an example since we have spoken about inheritance now. So I'll give you a demo on protected. Private modifier is basically it's private, it's within a class, you cannot access it from outside. If you try to access it, you would get a compile time error saying that it's not visible. Default modifier is package, is public within package. So within package, any class can access it. So basically it's like protected, right? Protected can be accessed within the package, plus it has like if your subclasses are outside the package, even those subclasses can access it, whereas in default it's just within the package. So protected has wider scope than default modifier. This is kind of public. So public has almost like everything, so widened scope. Then comes protected, then comes default, and then comes private. So access modifiers, public, what are public? So when you have public access modifier within a class, in this case you have two packages, edureka.pack1 and edureka.pack2, and you have some public members within your class 1, which we can see here that all these public members could be accessed by class 2, class 3, which is there in the same package as class 1, that is edureka.pack1. So now there are two classes in edureka.pack2. One is a class which doesn't have any relationship with class 1, but still it can access it, though it's there in a different package, but still it can access the public members of class 1. You can see class 4, which is a child of class 1, since it extends class 1, but it's there in a different package, but still it can access the public members of class 1. So protected is nothing but it could be accessed within the package in which the class is defined, and it could be accessed by members that are outside the package but child of that particular class. So in this case, we can see that there are a few protected members in class 1 which could be accessed by class 2 and class 3, since they are in the same package as class 1. Class 3 and class 2 are defined in edureka.pack1. We have class 5, which is not related to class 1, which means it's not a subclass or it doesn't have any relationship with class 1. In that case, class 5 cannot access any protected members within class 1. So here we have class 4, which extends class 1, which is nothing but class 4 is a subclass of class 1, which is there in a different package, edureka.pack2, but it can access the protected members of class 1 since it is there in a different package. Private member is nothing but it can be accessed just within the class in which it is defined. So in this case, you could see that this is private members. So you have class 1 which has got private members, and you can see that class 2 can't access it, class 3 can't access it, neither class 4 or class 5. No one can access it, it's just that class 1 can access private members. So we have seen this in examples that we took in session 1. Default package. So default package is nothing but only within the package in which it is defined. So in this case, you have class 1, which has got default members with default scope. And you can see that class 2 and class 3 can access it, but not class 4 and class 5 since they are out of this package. Since class 2 and class 3 are defined in the same package as class 1, that is edureka.pack1, that's the reason you could access it from there. This is same for attribute or method. There's a table here which is summarizing whatever we discussed so far. You have modifier public. So yeah, it's within the class, yes. It's within the package, yes. If it's within the subclass, yes. And within the world, yes. So everywhere it could be accessed, right? That's why you have public. Protected is within the class, yes. Within package, yes. Within subclass, yes. But not within world. So it's just within package and subclass. But if you have different package, or if you have different package but it's not a subclass, then you can't access it. No modifier which is a default scope within the class, yes, within the package, yes, but we saw that it cannot be accessed within the subclass if the subclass is in a different package. When we say world is nothing but any package and they are not related. In this case, the previous example that we saw, class 5 is something that could be thought of as class that are unrelated but reside in a different package. Private is just within the class. You can see that it's not with package, within the package, it's not within the subclass, it's not within the world. So I think we have spoken about private, public, and default scope earlier. Let's start off with protected. So in the meanwhile, when it starts, let's talk about this. So here we can see package demo, which shows public. It has got a public method that is message. There are three ways to access the package from outside. So let me talk about how we actually code it. So there are three ways to access the package from outside the package. One is with import. In this case, like you had Edureka 1 and Edureka 2, right? The example that we saw earlier, edureka.pack1 and edureka.pack2. These are the two packages you have. If you want to access something, if you want to access class 3 from class 5, you would have to import edureka.pack1.class3 since it is outside the package of pack1. If it's within the package, so far the examples that we were taking was all within the same package. So we didn't have to import it. Now I'll just show you an example wherein you would have something that is outside the package, and I'll show you how to access it. So we have to import it. So whenever you have it in different package, then you have to import that particular package within. One thing is importing the entire package. The other one is importing a particular class. So in this case, you have a package demo, and we can see that within package demo, there's a pack demo, which is nothing but a class defined within it. So let's see how to access package from another package. You have a pack demo here. That's a class that is defined within the package demo. As you could see here, there's one method which is msg, and which is taking two parameters as input, integer I and integer j. So what are the ways in which you could access this particular class that is pack demo from outside the package? So the first thing that you could do is you could import the entire package itself. So demo.star or demo.asterisk, as you could see here, which says that all the classes within this particular package can be accessed from this particular class. So you have a package demo class defined here, which says import demo.star, and which would import everything, all the classes within demo. So in this case, pack demo, you could see that pack demo class could be accessed from within package demo class that's there in different package. So basically this package demo class that you see here is defined in some other package. Other thing is, if you want to import just a class and not the entire package, you could do that thing as well. So here what we are doing is import demo.packdemo. So you're importing a specific class and not the entire package. That could be done as well. And the third one is, instead of importing, you can do one thing. You can have fully qualified path name or fully qualified name like demo.packdemo. That's your class name. You can access it within your class. So basically you would use the fully qualified name. You might use it, you did not do it, but you might use it in case where you're just using it once within your class. But you would go with this options, demo.packdemo or demo.star, in which you class has multiple, is referring to the class in different package multiple times. So in that case, you just do it once and could be used within your class. You need not do it again and again. So I create a new class which is com.edureka new dot. So I created a new package. So there's one that is com.edureka and the other one that is com.edureka new. These are different packages you have. If you want to use something within this package com.edureka, suppose I want to use vehicles, right? So this is what I was talking about. When you try to access it, you can't do it. You can't access vehicle from here because it's there in a different package. Now you are not able to access it because you haven't imported it. So what I do here is import com.edureka.vehicle. Once I do this, I am able to access it now. Now what I was saying is, if you are accessing multiple classes from multiple classes within the package, like car also you are accessing. So instead of writing it like this, so what you would do is com.edureka.car. Now the compilation error has gone. So basically, instead of doing this, like instead of writing it multiple times, the other option that we have is like com.edureka.star. So now if I get rid of these two imports, still it would work. I don't need these two imports because we have ported all the classes within the package. So it's able to access both the classes, vehicles and Edureka, from com.edureka. The other one was you could get rid of this. Now it's showing up error. What you could do is com.edureka.vehicle. You could access it directly with the fully qualified name. So you can see the error has gone. So these are the three ways in which you could access different packages or access classes from different packages. Now let's understand what is a regular expression. So regular expression, pretty much similar to other languages that you have. Regular expression is nothing but an expression through which you could extract some sequence of characters from your string, or you could check whether a specific regular expression or whether a string is aligned to a particular regular expression. So you could define a regular expression saying that, say for example, email ID, right? One of the use cases of regular expressions could be like you have email IDs and you might have seen it on websites wherein you do some kind of registration or something. And if you don't give a proper syntactic one, then what it would do is it would give you an error at the rate gmail.com. If you don't give that, it would throw you an error showing that it's not proper. So it's not checking against the Gmail server to see whether your email ID is proper or not. So it is just checking syntactically. You might have seen it. So if you give a wrong syntactic email ID and if you go to the next tab, if you tap to the next column or to the next space, what it would show is you haven't entered it correctly. So basically what it's doing is it's checking it against a regular expression. It has got a regular expression saying that this is how an email ID could be. It should end with so and so characters. It should be at the rate. It should have at the rate. It should have Gmail, or it should have some characters in between, then it followed by .com or something of that sort. So basically to have this syntactic this thing done, just to ensure that you have given it properly, you have a regular expression. So yeah, one of the use cases could be to have this pattern checker, usually to see if you're giving value which aligns to what is expected. So maybe other thing could be if you're typing something or if you have been asked to put some amount and if you type characters there, it would give you an error saying that it's not allowed. Those type of checks could be done through regular expression. Or if you want some value to start with a particular character and end with a particular character, you can check it against a regular expression. Regular expression is a pattern used for searching and manipulating strings. It could be used for manipulating strings as well. So one of the use cases is searching and the other one is for manipulating. The regular expression either matches the text or fails to match. So basically it would validate and say whether it's a match or it's failing. So we call regular expression as regex, which is nothing but abbreviation for regular expression. So Java supports regular expression, and these are the classes that we have within Java, which is in java.util package. So remember we spoke about java.util package, which has got utility classes. So these are among them. So here you can see pattern class, you have matcher class, and you have pattern syntax exception. So basically if you have some exception, if it's not proper, then you would get some exception as well. So we would be taking an example to clarify what this is all about. So here are some matching patterns used in regular expression. So just about to read through it. So you have like ABC, which means it has to exactly match ABC. If the string that you are matching it against has the content ABC, it would match. When you put it into square bracket, which says any letter A, B, or C should match, any character, and again if there's a negation, if within the square bracket if you have this negation mark which says that any character except these three characters should be matched. So if you put D, it will match. In the second case, if you put A or B or C, it will match. And here it would be from D to Z. If you put anything, it will match. Not just alphabets, it could be anything, any character. A to Z, So when you say A to Z, it says that we are giving a sequence of it, right? So we are saying from A, it's a range basically. So it understands range as well. So when you say A hyphen Z, which means that it is from A to Z. Here we are saying that any one letter or digit should be in sequence. So basically you could have uppercase and lowercase as well. Basically it is saying it should be in sequence. It should end with basically digit at the end. Dot is some kind of a wildcard character saying that any one character except line terminator must be in sequence. This one indicates beginning of line. So we say that line should begin with so and so. You could put some character here and we can say that if a line begins with so and so character sequence or whatever regular expression that we have put in, then the entire line matches it. The other one is end of the line to check if any character present at the end of the line. Other thing is word boundary. We have an example about this, so which would give you a clear idea about it, but it's more about it cannot be part of a word. Here, when we put slash b to the front and the end, or to the start and the end of a particular character sequence, which means that it has to be a separate word, but it cannot be part of some other word. Slash b to verify that any character is not present at the word boundary. Slash g to check that the character is present at the end of the previous match. Meta characters. So we have slash d. Instead of writing 0 to 9, you could use meta characters slash d to define digit. When you want to define non-digit, which is like you can see here, negation of 0 to 9 set, which is non-digit, which could be like alphabet, space, or anything, which could be grouped as slash d. Slash s is a white space character. So space, tabs, and stuff like that could be enter for that matter is a white space character. Slash s is a non-white space character, which means it's an actual character rather than white space. Slash w is a word character, and slash uppercase w is a non-word character. We have quantifiers, which is a quantifier defines how often an element can occur. So star, which means that 0 or more times, plus, which means that it has to occur 1 or more times. Question mark is it could be no or just one time. You could mention the number of times you want a particular sequence to occur, which could be put into your curly braces, occurs X number of times. X, you could put a range within your curly braces, X comma Y, which means that it should occur somewhere between X and Y. So it's a range. You have asterisk, question mark. It tries to find the smallest match. This makes the regular expression stop at the first match. So as and when it finds the first match, it would stop. So we'll have a quick demo on regular expression. So here, before we start off, we define a pattern here, basically. Then you could see it is basically saying from A to Z and followed by character one or more character. Then we have a check here, which is nothing but a string against which we are going to check. First, we compile the pattern. This is a regular expression pattern that you are going to check against. So the first thing that we have to do is we have to compile this pattern to see if it's properly done or not. So first thing is to compile it against pattern, and if it's correct up to the mark, you would get the instance. If it's wrong, then there would be some kind of exception thrown. Then there's a matcher. So once you have the pattern, you do pattern.matcher and you provide the string against which you want to check. In this case, you have happy learning, welcome to Edureka is a string that's been passed. And when you do c.find, if this is fine, it would return the result true. And if you remember the while construct, it would get in only if this is true. So it's a loop. So it would basically iterate through, and you could see here that it's displaying all the characters. I'll quickly run this. Let's name the class as pattern checker. Now I write a main method. Now, if you remember, we had a pattern there, which was like A to Z followed by characters. Then we have string against which you want to check, or you could say simple string to check. So we just put this one. So once you have this string to check, now what we want to do is we want to compile this particular pattern. So what we do, pattern.compile. So one thing to see here is that's the beauty of using the IntelliJ or Eclipse. So you could see here this package has already been imported. when you use it, unless you have multiple classes with name patterns, it would ask you to specifically explicitly mention which one you opt for. But in this case, there was just one pattern class, so it imported it automatically. And we give the pattern here. So basically, if this pattern is correct, if it's rightly formed syntactically, you would get a pattern here, or it's not pattern, I believe. We have a compiled pattern now. Now what we do is we take this compiled pattern, and I think we have a matcher here. We get the matcher now. So matcher would check against string. So you have a string to check, which would give you matcher. So here it's asking me which matcher do I want. I'll select this one, and you see this one getting inputted here. So this is what we have done. We have compiled the pattern, and we have provided the argument against which we have to check as a part of matcher. We get the instance of matcher. So everything is in terms of class. This is what object-oriented programming is all about. You have a pattern, which is a class. You have a method within pattern, which is compiling your pattern. So this is what object-oriented programming is all about. Everything is realized in terms of classes and objects. This is nothing but the object of pattern class compiled. So now what I do is matcher.find. I just print this one, matcher.check. So basically what we are trying to do here is once the entire string passes through, we are trying to get the substring out of it. So when we get the substring from matcher, you would get the string indexes, begin index, and you would get matcher.end as well. So when we run it, you should get appy, and so the first character would be trimmed off. So you could see first character being trimmed off from each line. So importing regular expression, we saw that java.util.regex gets imported. Then you have pattern, then you have string to be checked against. The pattern and the sentence which is to be matched are given. A to Z means any character from A to Z, and plus means one or more. The sentence check is checked whether it matches the pattern or not, and the strings from the sentence which match the pattern are printed. So basically here we could see that H is in uppercase and we don't have uppercase here. So that's the reason it trimmed off the first character. So basically if I add H here, now H would match as well, and it won't trim H, or it won't remove H. You should be able to see H as well. So yeah, as you could see here, you have H appearing as well. Previous case, H was getting trimmed off. So this one is for the word boundary. As I said, if you want to have something like, you want to be sure it's a separate word and it's not a part of any word, you could put something like this. So basically what we can do here is, so we can mention here something like /v and then in. So what we are trying to do here is, you could see here, what we are saying is we want a separate word as in. We don't want it to be a part of any other word. So here in learning, though you have in, it didn't pass it because it's a word boundary. Whereas in, which is a separate word here, it just passed this one. So if had I removed this one, you could have seen two ins. That's what I mean to say. So now what's exception? Exception handling is nothing but typically, so here you could see two ins. When it's /b, it would be just the ones that are complete word instead of matching the word boundary. Let's talk about what are exceptions. An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program instruction. So to give you an example, yesterday we spoke about arrays, right? If array size is 5 and if you try to access something more than 4, like if array size is 5, which means that the indexes range from 0 to 4, if you try to access something more than 4, like if you try to access sixth element within the array, it would give you an error saying array index out of bound. Or if a particular object is assigned null value and if you're trying to access that method within that particular object, you would get null pointer exception. Since it's not instantiated yet. When you instantiate it, that's when the object gets created. But if your reference is pointing to null and if you're trying to access something within that reference or a class, you would get null pointer exception. Similarly, you have like divide by 0 and stuff like that. It's basically something that is not expected or something that would disrupt the normal flow of program execution. When an exception occurs, the JVM creates an exception object to identify the type of the exception that has occurred. So basically, within itself, it would create it, or the code would create it. So I can create my own custom exception tomorrow. If I'm writing an application, usually in applications, that's how we do. We write our own custom exceptions. I can define my own exception as well. If within my application something is not working or something is not running as I would expect it to, I would throw an exception so that within my application, it properly logs or it properly prints out in my console saying that this is the exception that's been triggered due to so and so condition. So an exception is often referred to as runtime error. So here we can see divide by zero exception as an example. Now there are different types of exceptions. First one being checked exception, the other one being unchecked exception, and the third one being error. So checked exception is something that happens at the compile time. What happens is when you have a checked exception, when you are invoking some method which is throwing a checked exception, and okay, I don't want to get into the catch block as yet because we haven't covered it. So this is also called as compile time exception. It means if a method is throwing a checked exception, then it should handle the exception using the try catch block, or it should declare the exception using throws keyword. Otherwise, the program will give a compilation error. Whenever there's a checked exception that's been thrown out in the sense not at the runtime, there could be methods which is throwing an exception. So whenever there's a checked exception, you have to ensure when you give a call to that particular method, say there's a method X which is throwing some checked exception, from your application you are trying to access this method X. When you try to access this method X, you have to ensure that you are taking care of the checked exception that is thrown from X. If you don't take care of it, it would give you a compilation error. When I say when you don't take care of it, how do you take care of an exception? That would be the first question that would have come to your mind. So when I say you have to take care is nothing but you have to catch it. You have to handle that exception. So try and catch is a mechanism through which you handle the exception. So what you would do is method call or the call to X, you would put it into a try block. And in the catch block, you would say that if this particular exception occurs, execute this block of code. That's a handler for exception X or checked exception that is thrown from method X. So basically you write a handler for in the catch block saying that this is what I want to do when this exception occurs. Once you have that, when your program runs, even if the exception occurs, it won't stop at that point. It would go and check whatever is written and whatever piece of code that you have written, and it can continue from there on. It's basically a decision made by the developer whether to carry from there on or whether you want to break it there. Whenever there's a checked exception, you have to ensure that you handle it. Either handle it or you say that I'm not going to handle this. I'm just going to throw this off from my method or throw this off from the method where I'm executing this method X, which we spoke about, which is throwing checked exception. I can choose not to handle it and just to throw it off to the calling program, wherever the execution initiated from. So if you don't do that, you would get a compilation error. Unchecked exception, unlike checked exception, it's not mandatory that you catch. It's not mandatory that you handle it. It's a runtime exception. Basically, it could occur anytime and it's not mandatory that you go and actually handle it. So even if you don't handle it, JVM would be okay with it and it won't give you compile time error. So basically, these are nothing but runtime exception. So divide by zero that we spoke about is nothing but a runtime exception. It's not mandatory that you go and actually handle it during the compile time. You can either handle it or you can leave it as is, and during the runtime you would get an exception. So compiler doesn't check for the unchecked exception. It's done at the runtime. Now error, these are exceptional conditions that are external to the application and that the application usually cannot anticipate or recover from it. For example, if stack overflow occurs, an error will arise. They are also ignored during the time of compilation. So even the error condition cannot be anticipated during the compilation time. It's done during runtime, right? So one of the classic example is the stack overflow. wherein, say for example, you call the same methods like 1,000 times. Not 1,000 times is too less for the stack to get overflowed, but suppose you call it like million times. You call the same method, right? In that case, remember when I said when you give a call to the method, it goes to the call stack, right? We have a call stack. So it would push something, it would push a state of class, or it would push the properties that's been passed as an argument, the class, or to the method into the stack. Iteratively, if you call it like million times, what would happen is you would get stack overflow, because basically everything would get into the stack and it would basically leave your memory overflowed, or even memory for the heap memory for that matter. If you create a lot of classes, if you create a lot of instances of classes, your heap memory would get overflowed and you would get out of memory error. Those are classic examples of error. So what's the hierarchy of exception in Java? When it comes to classes, you have a throwable interface, and then you have error and you have exception. So exception is further, it has got runtime exception. The other ones are the checked exceptions. So IO exception, SQL exception, these are the checked exception. This has to be handled if there's a method which is throwing one of these checked exceptions. You have to ensure that when you give a call to such methods, you handle it or you throw it from your method. To the right side, it's runtime exception. So it need not be handled. As I said, divide by zero and stuff like that would be runtime exception. Even array index out of bounds and class cast exception, arithmetic exception. Then you have null pointer exception that we spoke about. All these exceptions are unchecked exception, and you need not actually handle it during compilation time. So why to use exceptions? When we execute a given program, we'll get an exception. Exception handling is performed in order to get the output. So basically, why do we handle exception is nothing but to get the program going rather than breaking it at that point. Use of exception handling: process exceptions from program components, handle exceptions in a uniform manner in large projects. So basically, why do we do it? So it's done basically to get the process going rather than stopping it at that point. And you could handle it the way you want to. That's the reason you have this exception handlers. Give you a simple example. Suppose 29 by 0. What I'm trying to print here, result after dividing 29 by 0. So basically when you run this, it's not showing up any compile time error. It's compiling fine. Now when I run it, since it's a runtime exception, it's compiling fine. But when I run it, let's see if it throws an exception. So as you could see here, it throws arithmetic exception, which is divide by 0. And this is happening at the runtime. That's why it's a runtime exception or unchecked exception. When a runtime exception occurs, program gets crashed and control comes out of the program. As we saw here, when we ran it, it didn't run this part of it. You could see that it broke out just right from here. So whenever there's an exception, if you haven't handled it, program control would come out from there. Exception handling is done to execute the program without getting an exception. So handling is done basically to handle the exception. Whenever the exception occurs, do some action. It provides flexibility to the developer to handle it the way they want to and get it going. Mainly try, catch, and finally are keywords for exception handling. So we have a try catch. As I said, there's a try block wherein all the suspicious one or wherever the exception, you think that there could be exception occurring, could put it into a try block. And in the catch block, you would say that if a particular exception occurs, this is what I want to do. All right, that's the catch block. And the finally block is nothing but no matter the exception is thrown or not, the finally block is going to execute at the end. So basically, finally block is usually used to release resources, right? When you deal with databases and stuff, you create connections against database, or you create some socket connections and stuff like that when you do some socket programming. Finally would be a place wherein once the execution of the method is done or execution of something is done, you say that we can release these resources off rather than still establishing the connection, right? Which takes up some of your resources, CPU resources, or which takes up memory. So basically it's to release off the memory. Exception handling. So let's talk about try. Try block is nothing but code that could generate. So suspicious code, as I said, that could generate an error is written into the try block. So the catch block would be more about catching a specific exception and doing something with it. So you could opt out to just break at that point or do something with it. Say, for example, you want to profile an application or you want to have some instrumentation set for the application to see how much time, what are the exceptions that occurring during runtime, right? If you want to see that, maybe a typical way in which it is done is you write all these exceptions into a database, and wherein later could apply some analytics to see what kind of errors have occurred in the application. You could see that later on. So that one of the use cases wherein you handle it whenever there's a particular exception, you put it into a database, you make an entry in the database saying that this is the exception that was caught in so and so time, and you could later on have some analytics to see how it could be improved, how the application could be improved. So finally block is nothing but whether successful or unsuccessful, the block is going to get executed. As I said, this is nothing but mostly it's used to release resources such as connections and stuff like that. Let's see a demo of how we can handle exceptions. To give you an example of try catch, say this is a suspicious code which we are running. Maybe you could put this into a try catch block and say when there's any kind of arithmetic exception that occurs, we are just printing it out. Printing any kind of arithmetic. So what we are doing here is nothing but we are catching exception and we are printing it. So everything is in terms of classes again. See, exception itself is a class. So you could click on it, control click, and you could see it as a class. This is a source code for arithmetic exception. So you could see extends runtime exception, which means arithmetic expression is a runtime exception. So it's a subclass of runtime exception. You could see super and everything being used here, whatever we discussed about. So arithmetic exception is nothing but it's a constructor, right? And you could see super being called here. So that's how you could get into exception and you could read through it to understand how the source code is being written. That would give you a good idea about how flexible Java is. It's very much when it comes to flexibility and when it comes to object oriented paradigm, it's very much cleanly followed code. So you could go and actually see at the way the programs are being written. If you remember when we did 29 by 0, the program broke. It came right from there and it didn't execute the following code. Now we have handled it. We are saying that whenever there is a arithmetic expression in this piece of code that's here, we are saying that whenever there is an arithmetic exception, we are going to just print it and we are going to continue it. Don't stop at that point. So you could see here, the program didn't break, right? It gave you an opportunity for you to actually handle it and it didn't break, it continued. So you could see this statement's been executed as well. That's why you have this results. So we had printed here. So as a part of handling, exception handling, what we did is we just printed out saying that what kind of exception had occurred. So exception.get message that gave like divide by 0. This divide by 0 that you see here is nothing but is printed out by this message. So it gave you an opportunity to handle it and get the program running as is. So try catch finally block. Basically what I can do here is let me define integer denominator is equal to 0. So as I said, finally block is going to execute no matter what is going to get executed. So I just print a message here saying, I'll say here, I'll put denominator. When the denominator is 0, we would get an exception and it would come to the exception block here or the catch block here and it would print it and then it would come to the finally block. So let me run this and see. So as you could see here, it came to the exception handler. It got arithmetic expression that is divide by 0 and then we printed out saying that printing the typical message or the actual exception that we got and it came to the finally block here. Let me put a scenario which is not going to throw exception. In this case, my denominator is 1, which means 29 by 1, which shouldn't throw any exception. So what I want to show is still it would execute the finally block. So you could see here 29 being printed out, which this got executed successfully this time because the denominator is not 0, it's 1. It got successfully executed. Still the finally block has been executed. Why to use multiple catch blocks? So you could have multiple exceptions and you could write multiple catch blocks. There are different exceptions that we spoke about. There could be like null pointer exception as well, which you want to handle, right? So it depends upon your program logic or what you're trying to do here. So there could be null pointer exception, then you have finally, so you have multiple catch blocks here. So you usually don't handle null pointer exception, but this is just to give you an example. So basically you have this arithmetic exception here being handled, then you have null pointer exception being handled here, then you have finally. So if you want to have different exceptions to be handled within your application, you could have multiple catch blocks. Since all the exceptions are derived from exception, catch exception E should be placed at the end. So basically, if you put the exception, there's exception, right? If you remember the hierarchy that we spoke about, all the exceptions are derived out of exception class. So you could have something of this sort. So if it is not an arithmetic expression, not a null pointer exception, then there's of course going to be some kind of exception which is going to be handled in this exception block. So basically we are catching all the exceptions here. First is specific to arithmetic exception. The second one is null pointer exception. If it's not a null pointer exception or arithmetic exception, then this particular catch block is bound to get executed. And it has to be last. You cannot place it first, because if you place it first, these two blocks, exception handler blocks, will never get executed, because even these two exceptions are a subtype of exception class itself. So it is mandatory that you place it at the end, or else it would give you compile time exception. So you could have something like array index out of bounds and stuff. So just to give you, this is integer array. I put 1, 2, 3. I define an array. Now I say integer array of, there are 3 elements, right? And if I try to access or just choose, so when there are 3 elements, the index ranges from 0 to 2. So now I put 3 here. So this is generic exception handler. For all the exceptions, we would have this handler. When you run it, this is going to give you array index out of bound, because you're trying to access element at index 3, which doesn't exist, right? So you would see a generic exception handler. So it came here. What I was trying to say is, so you could have array index out of bound here, right? So instead of null pointer exception, now I have array index out of bound. Now it would be handled by this block, and it wouldn't come to the generic exception handler. So here you saw it came to the generic exception handler. Now what you would get is array index out of bound exception handler, because it's been handled by this particular catch block and not the last catch block. So this one is, as you go down, it becomes generic. So here you could see it's been handled by array index out of bound exception. So as you go down, it becomes generic, more generic. Why to use multiple catch block? So this is pretty much similar. We have array, we have arithmetic exception that occurred. Array has 4 elements, 0 to 3, and you're trying to access the 10th element. That's when you would get array index out of bounds exceptions, as we saw. There could be a nested try, wherein you could have try and inside try. So basically, when you have try inside try, if there's an exception that occurs in the nested one or the innermost one, it would try to see if there's a catch handler for that particular exception innermost one. If it doesn't find, then it goes to the outer one. So in many cases, it may happen that a part of the block may cause an error and the entire block may cause another error. In such cases, we have got nested try block. So what I was trying to say is, you have this one, you could have one more like exception E, or shouldn't be that. So you have a nested one. Within this try, you have one more one, this thing which says array index, which is handling null pointer exception. It's handling just the null pointer exception. It's not handling array index out of bound. So what I was trying to say is, if such scenario occurs, it would check the innermost one. If it finds the exception handler, it would execute it. If it doesn't find, then it would come to the outer one. So basically, though this try doesn't have handler for array index out of bound, still it would be taken care of. So you can see here, it came to the outer one. So if you would have some piece of code right after this, it won't get executed. So this piece of this code will not execute if inner try. So basically, if there's a exception which occurs in the inner block, and if it's not handled, it would come to the outer block, but this piece of code, whatever you have in between this catch and this catch, wouldn't get executed. Why to use throw keyword? The Java throw keyword is used to explicitly to throw an exception while executing the program. So if you want to throw something, as I said, you could create your own custom exception, and if you want to throw something, you could throw it out. You could throw an exception from your program. It can be used to throw checked or unchecked exception. Any kind of exception could be thrown using using throw. And the Java throw keyword is used inside a method. So you could see here, basically, if b is equal to 0, you throw new exception, divide by 0 causes an exception. So before it goes to actually dividing it by a by b, you are kind of handling it prior to that. You are checking whether denominator is 0. If the denominator is 0, you are throwing exception by yourself. You are creating a new exception. This is kind of your own exception, right? You're creating your own exception and saying that it's divided by 0. So for any condition, so basically if denominator is equal to 0, you could throw it from here, saying or denominator. So basically if I keep this denominator as 0, and this should be prior to this, just cut this and this should be done prior to this. Okay, when to use throws? Throws is something, as I said, when you have a checked exception, you can either handle it using try catch, or you have to throw it out of the method saying that I'm not going to handle this. Let the caller handle it. You could do that using throws keyword. The method is not taking the responsibility to handle a checked exception, and it is, asking the caller of the method to actually handle it. This is in terms of just checked exception, when you have a checked exception. So basically, since you're throwing it from there, but since you have handler here, it's coming to this. So you have this denominator, you threw an exception from here, but this exception is been handled here. So it came here saying that generic exception handler. All right. So if I remove this, that's the reason you have generic exception handler here. So I remove this handler. I'm not going to handle exceptions. Whenever you throw an exception, it has to be handled, since exception is a checked exception. So basically you could have runtime exception which need not be handled. So basically the handler that you see here, we just have two handlers, which is for arithmetic exception and array index out of bound exception, but we don't have handler for runtime exception. So that's the reason it gave you an error saying denominator is 0. So this is the exception that we threw here using throws. So it's giving you an error right here because this is a checked exception. The exception itself is a checked exception. Now you could either handle it like the way we had handled it here. You could write catch exception and you could handle the way you want to. So you have two options now. When you get into this scenario, into this situation, you have two ways to handle it. Either write exception and handle it. This would be a handler. If you see, the compilation error has gone. Or this is one thing that you could do. Or the other thing that you could do is you could ask this method. This method can say, I'm not going to handle it. I'm going to throw it for my caller to handle it. So the main method is saying, I'm not going to handle it. I'm just throwing it off from my side, from my code, for the caller to handle it. So see, the exception has, again, the error has gone. So basically, whenever there's a checked exception, you have two options, and this is happening at the compile time, by the way. So you have to ensure that you either handle it or you throw it. Throw in the sense throws. It's through throws. Main is saying that I'm not going to handle this. Let the caller handle it. As you could see, the throws keyword was added in the method signature. We saw how we throw exception. We throw exception from here. You check for some condition, you throw exception from here. Why we use throws? Throw is basically to throw an exception, and a method saying that I'm not going to handle the exception. So what's the difference between throw and throws? The throw keyword is used to explicitly throw an exception. The throws keyword is used to declare an exception. The throw keyword is followed by an instance. The throws keyword is followed by throwable class. All right, so here you could see this is throws keyword is actually by instance. You create an instance of exception, whereas throws is the class itself. Throw keyword is used within a method, and throws keyword is used with the method signature. So you could see throw is used within a method, within the method body, and you could see throws at the signature level. So you have throws and throw. So throw is nothing but whenever you want to check whether there's an exception and you want to throw it out, you want to actually trigger the exception. That's when you would write throw and you would throw this exception. So basically here we are checking for a condition if denominator is equal to 0, which is potentially which would cause error further down the line. So we are checking it upfront, saying that if the denominator is 0, then we are not passing it further, right? In such scenarios, we could throw the exception right away. That's how you trigger the exception from the program. Throws is nothing but it's at the signature level of the method that you could see. And what you mention out by throws is that main is saying here that I'm not going to handle the exception. I'm just going to throw it off. So these are unchecked exceptions, by the way. So whatever is not being handled here, if there's some exception handled here, it would get to the exception handler or the catch block. But if there's something that is not been handled here, would be thrown out of this main method. Main method won't handle it. That's the reason why we have throws. Throw keyword is used within the method and throws keyword is used with the method signature. Throw keyword can throw only one exception, whereas throws keyword can be used to declare multiple exceptions. Basically, you could have something like there's one exception, say IO exception. So you could have multiple exceptions here. So the main is saying I'm not going to handle IO exception. I'm not going to handle exception or something of that. So you could have multiple exceptions after throws. User defined exceptions, you can create your own exception and it is called as user defined exception or custom exceptions. A user defined exception class can be created by creating a class, child class of exception. So basically create an exception. I create a class which is say custom exception. Now this custom exception is extending exception. So you could have your own classes defined and it would have like this. So whatever exception you get, you could pass that exception directly here. So this is basically what I'm trying to do here is overloading of constructor. So you could see if you're passing string, it would come to this. If you're passing exception, it would come to this constructor. So you could create your own exception here. So basically to give you an example of this, instead of exception, what I throw is I can have a new custom exception. So initially I was throwing exception. Now what I'm saying is new custom exception. This is the exception that I have created. It's my own exception. When I run this, now you can see that it should throw custom exception. So you can see here exception in thread main. Thread main is nothing but your main method where your program is executing, and it shows the exception type, which is custom exception, which is created by me. And I have passed the string saying that denominator is 0 and at what point or at which line this particular exception occurred. You can see it in the stack trace. This is a stack trace. Basically, whatever you get here when an exception occurs is nothing but stack trace.
The projects that I will be discussing today are ATM machine, which is based on core Java concepts, text editor that is based on swings and applets, and the sign-up form which will make use of servlets and JSP concepts. Without wasting any further time, let's get started. First, ATM machine. All of you know what is ATM and how it works, but implementing the same using core Java concepts is something interesting. So let's see how to do that. Here, we will be developing the code for user account details, bank account, and then further we will perform few operations like deposit the amount, withdraw, check the balance, etc. Basically, it's based on core Java concepts and is developed using Eclipse. So all that you require is your Java install, that is your JDK and JRE, and you just need to have Eclipse installed on your machine. Let me tell you one important thing, that is I have set the privileges for account number and password. That is, you can see on the screen that I have given 2 account numbers and passwords. While running the code, if you give the account number and password as mentioned on the screen, only then you can do the further operations. Else it will just display a message saying wrong account number or PIN. Now let's see how it works and how the code is being developed. So basically when you run the code, this is how your console appears. And it asks me to enter the account number. That will be the one which I mentioned on the screen, and the password is going to be this thing, enter. So when you enter this, it will ask you to select the account you want to access, that is whether your checking account, your saving account, etc. So first I will say type 1, that is checking account. So in the checking account, the operations that you can do is you can withdraw the balance, you can withdraw funds, you can deposit the funds. So let's see how much balance is there in my account. It's 0, is it? Now I want to deposit the funds in the checking account. So how will I do that? Again, checking account, option 3, which is deposit funds. So it's asking me amount you want to deposit from checking account. So I say I want to deposit some 10,000. Enter. So you can see here the new checking account balance is 10,000. Correct? Again, I will choose checking account, and now I want to withdraw the amount from the checking account. So I'll say option 2, and I'll say I want some 5,000 from that account. So you can see here I've withdrawn 5,000 and the new checking account balance will be 5,000. So this implies I've withdrawn 5,000 from the account. Again, I will choose option 1. I will view the balance. So it says 5,000 is remaining. Correct? Now we'll go to savings account and again view the balance and do the same operations. Balance is 0. Again, same thing. I want to withdraw some funds like say 4,000. It says 4,000. And now I want to withdraw some funds, say some 5,000. Let's see what it says when the amount that we want to withdraw is more than the amount which is in the bank account. It says balance cannot be negative. Correct? So when you try to access more amount than which is there in the bank account, like the savings account, it says balance cannot be negative. Similarly, you cannot just enter the negative values into this. Now say I want to just withdraw some 2,000 and it says the new saving account balance will be 2,000. So basically this is how you can do operations like same way you do it on your ATM machines. And now I want to just say I want to exit. So suppose if I enter invalid account number, say I'll enter something like this and I'll give the PIN something. It says wrong customer number or PIN number. That is, I have set the privileges only for those two account credentials so that I can access using only those two numbers. You can even include more account numbers and PINs. I'll show you how to do that. So basically this is all about the working of ATM machine. Let's take a look at the code now. So here in Edureka 1 package, I have created 3 Java files. One is for account, one is ATM, and one is option menu. So now let's see why we have 3 files for ATM and how it works. First we'll see option menu. So you can see here option menu extends account class. That is this Java class. I'm just reading a money format that will be in decimal. And then I'm creating a hash map of integer, and then I'm creating a variable of type hash map and giving a reference for that. So basically the first thing that I want to do is I want to validate the login information, that is customer number and PIN number. As I have already told you that I have set the privileges for 2 numbers. That is these 2 account numbers and PINs. If you want more, you can just copy this data.put, paste it, and you can change like whatever you want. You can add more number of privileges like this. So the first step when you execute, it will just say welcome to ATM project and enter your customer number. Correct? So first what you will do, you will enter either of these customer numbers and then it will ask for PIN number. I am reading the customer number and PIN number using menu input.nextInt. So in case if you enter some characters, it has to catch an exception. Correct? So what it will do, it will say invalid characters and it will ask you to enter only numbers because I have set the privileges only for numbers. So in this for loop, I'm trying to check whether the entered customer number and PIN number is correct or not. If it is not correct, it will print saying wrong customer number or PIN number that you already saw in the output. So after that, if the entered credentials are correct, then this method will execute. That is the get account type. In this get account type, I have mentioned these choices. That is select the account you want to access, checking account, saving account, choice, etc. And then using the switch case, I am using get checking, get saving methods. If you press exit, it will say thank you for using the ATM, bye. And in the default choice, if you press the choice that is not correct, it will say invalid choice. So here is the get checking. And I have defined the method over here, that is get checking. So what all we had in the get checking method? View balance, withdraw funds, deposit funds, exit. Correct? Now I am reading everything. That is account balance using money format, withdraw input, deposit input, and everything will be in get account type method. Correct? And obviously case 4 will be your exit, so it will just print saying thank you for using the ATM, bye. Now similarly for savings account, that is view balance, withdraw funds, deposit funds, etc. Again, we are using switch case to print the saving account balance, saving withdraw input, saving deposit input, everything. So this is all about your option menu class. Now we will see what is there in account class. So here it is just required to set the customer number and set the PIN number. That is, first you set the customer number and return customer number, and then you set the PIN number and return the PIN number. So basically, account class is to retrieve all the details that is being set in option menu. That is your checking balance, saving balance, your withdraw input, deposit funds, everything that is being mentioned in option menu class. So you can see here that I have checking balance method and I'm returning the same. And again, I have saving balance. So here you can calculate the checking account withdrawal, that is checking balance equals to checking balance minus account. And then it will return the same. That is, we saw that when we want to withdraw 2000 from 4000, it will say the new saving balance will be 2000. Similarly, the same thing will be here. That is saving balance minus amount, like that. So similarly, you can calculate the account deposit, the saving account deposit, that is the balance plus the amount that you enter. Suppose say the saving balance is 0 and if you enter 2000, so it will add and it will return the balance. Similarly, the same thing with this as well. That is account withdraw input and customer saving account withdraw input as well. And then it will just check the deposit amount. Same thing for savings as well. And I have initialized all these variables as private because I want them to be local to the class. So this is how it works. And now coming to the last file, that is atm.java. So here this class extends the option menu and option menu extends account. So what ATM should do? It should obviously extend option menu. And I'm just creating an object of option menu and just trying to get the login from option menu. So when I execute again, it works same. It will ask same thing again. If I enter something, it says wrong customer PIN or account number. As I have told, if I enter something else apart from the numerics, it says invalid characters, only numbers. That is the exception that I have thrown. So this is all about the ATM project. I hope you understood it. Now let's move further and see the text editor. So here I'm making use of Java swings. That is, I will be using JText area, menu bar, J menu bar, etc. And all the menu items will have action listener to detect any action. And as I have told, it makes use of Java applet and swing concepts. And similarly, all that you just need is a Java install and the Eclipse ID. We can say like we can perform all the operations like we perform in your WordPad or your Notepad, and it is very efficient. So now let's see how it works. So first let's execute and see how it works, and then I will explain you the code. So you got a text editor here. You can see you have file and it consists of all the operations like new, open, save, exit. And you have edit option like cut, copy and paste. You have font like bold, plain, italic, and you have size like up to 28. And you have font type, that is Roman, Helvetica, Arial, Courier, Century, etc. And also you can set the background and foreground color, and you can undo and redo the operations. Now let's see each of them how it works. So I want to say like welcome to Edureka YouTube channel and enjoy learning. Now suppose I want to change the font of this. I'll capture everything like Control A and then I'll give font like bold. So you can see here it became bold. Say suppose I want it to be italic. You can see even that became italic as well. I want to increase the font size like 28. It got done. I want to change the font type to Century. Even that happened. Say I want Helvetica. I want Times Roman, even that happened. Say I want a color to give for that like background color in something like say I want red. Okay. You can see the background color is red. So I want to remove the background color now. And I will change the font color to be. Say I want to enter some more text like I did as Java projects, and I want to undo that. I can just press Ctrl Z and it goes on removing all that thing. And Ctrl 5 for whatever I have deleted. You can see it's going on. Also, you can create a new file that I just did. Also, if you want to open something that is already present, you can open from the libraries. Also, if I want to save this, I can save it. like however I want in the downloads or in desktop, wherever you want, you can save the file by giving save it. It will be saved. I can enter something, and again if I want to save it, it will be saved, like applet 1. Similarly, you can even check that whether it is being saved or not. So in desktop, you can see it is being saved as applet and applet 1. So basically, this is all about your text editor as how it works. Like you can perform all the operations like edit, font, file, color, undo, redo, everything, etc. Sounds interesting? Let's see what is the code behind this now. So here you can see a undoable text area that extends the text area and implements state editable. Why it implements state editable is because we have defined the editable class in which we can edit all the options like I showed you on the text editor. So you can see here I have given the key state as undoable text area key, and then I have declared the current edit and undo manager. In the first undoable text area, I have defined it in various ways. The first thing, it is 0 parameterized, and then in the next I have defined some parameters like string, and I have given it in super as well. And then I have used rows and columns, and then I have used string along with rows and columns, and then string, rows, columns, and scroll bars as well. So in various ways, I have declared this undoable text area constructor. So if in case something happens, you are stuck and you cannot undo some operations that you have performed, then automatically the exception will be catched here. And next, same for redo as well. If you cannot perform any redo operations, then it again catches an exception. You might be wondering why it need to catch an exception, correct? It's just because to maintain the normal flow of execution so that your further operations will not be interrupted. And next, to store the state and restore the state that I have given, I'm using the key state as a variable. And for the snapshot method, I'm giving like condition if the text is being changed, then use undo and add edit to edit the current state. And now I'm declaring the init undoable and giving some new reference variables for undo manager and current edit, and I'm adding the key listener for new adapter. And then I'm using the focus listener to focus the event that was being captured. And similarly for text listener as well. If the value is changed, it has to say that the text is being changed. And now you can see there's a text editor class which undoable text area has extended. In this, I'm declaring few parameters like frame, file dialog, font, etc. And now here comes the text editor parameters like say courier, its style, its size, everything. And here I have used the option menu bar, that is Times Roman, Helvetica, Arial, Century, etc. And I have given one parameters for each of them. And then using the add method, I'm adding all of them, like appending it to the menu. And we have to use the action listener to detect any action that is being performed. So similarly for bold, plain, italic menu that all we saw. And again using action listener, we are calling that event. And then I'm declaring all the sizes over here that you saw, like till 28. And appending it using the add method. And to detect them, I'm using add action listener. Even for new, open, save, exit. Again using action listener for all them. And for cut, copy, paste, edit options as well. For background and foreground color, and for color, for undo, redo, for everything, it all remains the same. And then I'm implementing the action listener class to invoke that method, correct? Like for undo and redo, and similarly for file name, untitled, for select menu, everything. So whatever the options we have seen here, they all have to implement the action listener class. So you can see I'm detecting save. Else what happens, the action will not be detected. You can see again for exit as well, for read file, everything. And even cut, copy, paste. For everything we have to use action listener classes. Even the size class implements action listener, like for size 10, size 12, for 14, 16, 18, similarly till 28. That's all. And then I'm extending an applet class and implementing the action listener even for this. In bold, I want courier, font, everything. And even in plain, I want the same thing. So as you can see, if I type anything here, so it is by default courier, correct? So that's what is here. That is in get action command, in bold, plain and italic, whatever it is, the first thing is courier, correct? And then comes the type, that is Times Roman, Helvetica, Courier, Arial, Black, Century, everything. And then again, I'm choosing the color, that is the background or foreground colors. And then I'm implementing the main method and setting the size of the text editor to 800 and 600. So that's how it works. Like, you can perform any operations on text editor and do rest everything. Now let's move further and see the sign-up form, which is developed using servlets, JSP, and web development tools like HTML, CSS, etc. So I'm just going to create a basic sign-up form, and all that you need is servlets, Java server pages, Apache Tomcat server, and cascading style sheets, and Eclipse for Enterprise Edition. And it's very easy to develop, as I'll be showing you how. So first, let's run the output and check, and then I will explain you the backend code. Make sure that you run on server. My Tomcat server is starting now. So this is the sign-up form that we have created. You can enter the name. I'll give some email like 13 or older is my option. So here in the sign-up form, you can see your name, email, password, your age. I'll give some biography like I am a footballer, singer, swimmer, etc. Like just my hobbies. I can give my education, everything you can give. Like it's not mandatory that it should be the same thing. And the job role have so many options in web, mobile, business, and others. So I'm very interested in iOS developer, so I'll give that. And interests are in development, design, business, everything. And when I sign up, it says, "Hi Chris, welcome to Edureka," because the sign up that I have done got saved. So where will be the output? Like, or where you can see the details that you have entered in the backend. In this console tab, you can see the details that you have entered. That is your name, your email ID, your password, your over 13, your biography, your job role, your interest, etc. So that's all was there in the form. So you can see here in this form, these are the basic information that is being given. So now let's take a look at the backend code. In the sign up, I have created 5 files like HTML for creating a form, CSS file to add some beauty or make up to the form that we have created. We have servlet class files like request post form and person1.java class. And then to retrieve the data from the servlets, we have the JSP file. And also we have the web.xml file to add the mappings to the servlet. And we have JSP file to retrieve the data from the servlets. So for this front end, that is your sign up form, we have used HTML. You can see here that I have linked with CSS as well. That is for giving some makeup to the file. That is, you can say beauty to the form that you have created. I'm giving form action as request post form and method will be post. So here you can see in the label, you have created like name, email, password, age, your under 13 or above 13, whatever it is. And then for your profile or your biography, you have created one more label tag and giving the text ID is equal to bio and name is equal to user bio. And for the job roles, there are so many. So you have created a first label for job role. And the first opt group label will be web. In web, you have so many options. And again, you're closing that and opening one more opt group label. That will be your mobile, your business, your other. So same things. And then for your interest, like this one, you can see you have checkboxes over here, correct? For that checkboxes, we have given the class type, value, everything. Like for development, for design, for business, everything. And last, it will be the submit button. That will be your sign up. So this is how your index.html file will be. And now coming to main.css file. For each and everything, I have given the paddings like the font family, the color, the maximum width, the margin, background, everything. Even for the first thing that will be the H1, I have aligned it to center. You can see here I have aligned it to center and that is in H1. Even for that, I have given the specified color and the font family as well. And coming down for form as well. And for all these things, I'm using a select type for background, border, font size, height, margin, outline, padding, width, color, everything. Even for the box shadow as well, you can see there's a shadow for this box. It's not just a simple one. And even for the checkboxes, for buttons that is present as well, for field set, for legend tags, for label, for number tags, everything. So this will be your main.css. Now let's take a look at the servlet classes. So first, what I'm doing here is I'm extending a HTTP servlet class, correct? And I'm using a doPost method and declaring parameters for request and response. And I'm requesting all the parameters, that is your username, email, password, age, biography, job. And for your user interest, again the same thing. And then I'm creating an object of person and trying to retrieve all the details, and then I'm trying to request and set the attribute of my person. And then using the dispatcher, I'm trying to request the get request dispatcher from JSP. And obviously in the dispatcher.forward, you will be having a response and request, both of them. So as I have created an object, let's see what is there in the person. In this, it's nothing but it will retrieve all the details. That is, I have made everything as private because I want it to be a private to the person class, and this class is called as a bean class. I'll tell you why. I have made a constructor of person1, and then using the parameterized constructor, I'm trying to reference and retrieve all the details. You can see like for get name method, I'm returning the name, and set name, I'm retrieving. Again for get email and set email methods, for get password, for get age, set age, for bio, job roles, interest, everything. This is nothing but defining a constructor and retrieving the details. And request post form is essential to send a request and response. And then person1.java is essential to retrieve the details. And then, as I have told, it is requesting a dispatcher to login1. So in the login1.jsp class, I have imported the bean class, that is edureka.person1. Why? Because Edureka is my package and person1 is my class. And then I am giving the scope as request. And similarly, as I have imported the bean class, and similarly to redirect it to the next page, I have used a small icon, and you can say that it says welcome to Edureka. So this is all about the JSP. And then now coming to the last file, that is web.xml, you have to add mappings to the file. You can give servlet name like anything, but make sure you give the servlet class name very properly. That is, it should be like Edureka, that is your package, and your request post form, which is your class name. This should be very correct. And then for URL pattern, that is request post form URL, this should be same as the one which you give in form action tab, that is your request post form URL, or else it will result in an error. So this is all about the sign up form. I hope you understood how it works.
So let's just start with something known as the basic questions which are asked to the candidates in the entry process. So the very first is the difference between three terms, that's like JDK, JRE and JVM. So as a Java developer, you must have a fair knowledge what exactly are these three terms, right? So guys, let us understand now. So Java virtual machine is basically an abstract machine. It's a software which is already provided by the platform. So it provides the runtime environment. Whenever you are writing the Java source code, it gets compiled into the bytecode. So JVM is that there which is going to execute your bytecode now. Other than that, you got JRE, which is the runtime environment. Now it's basically where JVM is gonna use the JRE. So JRE is set of libraries required by the JVM in order to execute your code. JDK is one development kit required by the Java developer. So it consists of various APIs for you through which you can write your code. So just for an instance, right? So JDK will contain your various packages coming into, for example, java.io, java.utils. All these APIs, the set of library, the information that comes from your Java development kit. Other than that, it has various tools also available. For example, Java and Java C, right? So Java C is a tool which is used for compilation, whereas Java is for the execution of your bytecode. So these tools are also part of JDK. So let's switch on to the next question. What is synchronization? This is one of the hot favorite questions. Whenever you talk of threads, so we do have this term known as synchronization. So synchronization is something where multiple threads, if they're gonna access the same object, right? So there is only one resource which multiple threads they want to access. You need to come up with something known as synchronization. So guys, what is synchronizations? Here we'll take up one example. Let's say we want to book a movie ticket and it's gonna be one seat which has to be booked by multiple people, right? So let's say one corner seat in the last row has to be booked by multiple people. So multiple people over the web will treat them as multiple threads. They are looking onto a single object on a single resource, that's like the last row, last seat, right? So whosoever will first of all try to block that seat will be given an access, and no other person can thereafter block that seat. So synchronization is very much in line to this concept. When you got multiple threads which are going to work over a single object, you need to use a keyword known as synchronized, with the help of which you will be able to acquire the locks on your objects. So synchronization is a process which gonna keep all the concurrent threads in the execution to be in a synchronous mode, one after the other. The lock acquisition is gonna come up into action. Synchronization will avoid the memory consistency errors due to any inconsistent view of the shared memory. Let us understand the difference between processes and threads now. So synchronized word came up and we started off something known as thread. So let us understand what exactly is process and what is a thread now. So guys, in order to come up with process and thread, let's just have one visual coming in. Let us say you got this layer as an operating system, right? So we'll say that this is one operating system. It can be any OS now, right? It can be Windows, Mac, Linux, any of the flavor. So when you're gonna run the program, what OS will do? OS will create a process, right? So this process will be created by the operating system whenever you are supposed to execute your application. So other than that, what it does is it will also give you some storage space where RAM will come into action, right? So further, the RAM can have various data structures coming into it. For example, you can have the data being stored in the form of stack or the heap, right? So that's like the storage concept. Let us say I got one program which I need to execute. So whenever I'm going to execute my program, so the running instance of your program over the operating system is nothing but it's a process. Within the process, we have one guy known as main thread. So main thread is what? This is the guy which will execute some instructions, or you can say some sequential tasks which you mention in your main method, right? So whatever the statements you are writing in your main method, they are nothing, they are these tasks which are executed one after the other via main thread within the process. So guys, a process is running instance of your program over the operating system, and a thread like a main thread is running within the process. So we must understand threads are available within the processes and processes are running on top of operating system. There might be a scenario that a particular task like I'm just going to highlight this task over here. So this might take a longer time, right? So let us say this particular task will take a minute or so because it's going to fetch the data from the server now. So in this context, right, so these three tasks, they will be blocked, right? So when I'm talking about these three tasks, the yellow states, so they're gonna get blocked now. So what we can do, we can bring down one more thread and we'll say that this is one user thread or child thread. So we got various other terminologies for this guy, right? And we'll offload the heavier task over here of the main thread to the user thread. In this way, what we are able to do is we are able to outsource the heavier task to some other thread, and we will be coming up with the concept of concurrent programming. That is what we want to achieve now, right? So let us understand what has happened over here, guys. So let's see this part now. So process and thread, they are two different concepts, but we must understand now any executing instance of a program on top of your operating system is nothing but it's a process. So on operating system, we got multi-processing, whereas thread is something which is a subset of the process now. So within a process, you got multiple threads. So multiple processes on OS level, multiple threading on process level. When you talk about the communication, so one process, when it wants to interact with the other process, we call the processes as inter-process communication, where threads within a process, they can directly interact with each other. When we talk of the control statement, so processes can only exercise control over the child processes, whereas threads can exercise considerable control over the threads of the same process. Any change in the parent process will not affect the child process, whereas if there is something where the main thread is getting affected, the other user threads or the child threads, they might get affected. If you talk of the memory structure, so processes, they run in the separate memory space. Each and every process will have its own memory space, whereas threads, they gonna share the same memory space which is being allocated to the process by the operating system. So guys, once again, process is controlled by OS, whereas threads are controlled by the programmer in a program, right? Or you can say by the process itself. If you talk of the dependency level, processes are independent, where threads, they're gonna get dependent, because if you can notice this image right over here, so we created this user thread and there is a dependency that this task has been outsourced to this user thread by the main thread. So dependency of the main thread over the user thread relies, and vice versa, right? So it can be based on our logics even. So let us move to the next concept now. So the next fundamental is, what exactly is a wrapper class? Now this is also one of the hot favorite question which is always asked. What is the wrapper class? What is meant by the term boxing or the auto boxing? So let us see this part, guys. So wrapper classes, they are the way where we can convert the Java primitives into the reference types, that's like the objects. So each and every primitive type has a wrapper class defined, and it's in by default they are available in java.lang package. You need not to import any package. So for boolean we got boolean, right? For char we got character, and for int we got integer, for double, so on and so forth, guys. So wrapper classes are the means by which you are able to convert your primitives into the references. So let us understand what exactly is this conversion of primitives into references. Let us say I got this I as 10. So we call this guy as a single value container, because I can contain only one value. It's not an object now, it's a primitive type. You want to convert this primitive guy into an object, you say integer iref assign new of integer, and you mention this guy I as a part of constructor. So what we have done, we have boxed. So it's like constructing the object now, constructing the object. So that's what we have done, guys, over here, right? So this particular statement over here is known as boxing. On the other way around, when you say in jassign iref dot int value, so this concept is known as unboxing, right? Extracting the value from object. So you must understand this concept over here, boxing versus unboxing, which is achieved with the help of wrapper classes. Other than that, you can also say integer kref assign I. So this is known as auto boxing, right? So this instruction is translated internally by the compiler as in integer kref assign new of integer, where we got this guy known as I, right? So this is auto translation. You need not to write the whole statement. So you just mention the partial statement or the implicit statement, we call it as auto boxing. And if you write down, let's say L assign kref, right? So this is known as auto unboxing. So important question again, what is boxing versus unboxing, and thereafter what is auto boxing versus auto unboxing. So the major reason why we do boxing or unboxing is to convert primitives into the objects. Now if you're talking about object oriented programming structure, right, so we are always thinking of objects now. So if you are able to convert primitives into the objects, it means that you are strictly and truly following object oriented programming structure. So we got one way of doing it, and now you can also pass by reference the primitives. So that's one more way of coming up, like why you do a boxing part. So we can pass the variables by references now, right? Because here you are getting the references to the objects. All right, so let's come back now to the next question, number 5. That's like, what are the keywords final, finally, and finalize, and what is exactly the purpose of it? So they are now the 3 different keywords, right? So even the final term is something which means the last thing, but they have different meanings in different contexts now. Now final is a kind of a constant. So if you mark a variable as final, you can't change its value. So here if you can see a very small snippet, right? So a is 1000 and you try to change its value, the compiler will not allow you to do so. So final is a keyword where you are able to mark your variables as constant. You can also mark your classes to be final. In that context, you cannot inherit from that class. You can also mark the methods to be final. In this regard, your methods, they will not be overridden. So final can be used with 3 of the concepts: final as a variable, final as a class, and final as a method. Finally is the other context where we use it with the exception handling techniques now. So what exactly is the place where we will be coming up with finally? So many a times when you are writing the exception handling code with a try and a catch clause, there might be a scenario whenever the exception will come, the statements mentioned within the try block, they will not be executed below the statement where the exception will come, right? So let's say there are 10 instructions in the try, and on the 5th instruction in the try you get an exception. So below 6, 7, 8, 9 and 10 instructions, they will not be executed. You need finally block to mention such instructions which must be executed, either exception comes or it does not. So finally is that piece of block which will be executed whether the exception is coming or it is not coming. For example, if you want to close the database connections, now exception is there or not, but we would like to close the connection at any cost, right? So you mention all such statements in your finally block. So the next part is finalize. So guys, finalize is a kind of a destructor. So whenever the object will be removed from the memory by the garbage collector, so this finalize method will be executed. So you can explicitly try out this example where you can say system.gc, right? And you need to just mention your references to be pointing to the null, and thereafter your finalize will be executed. So you can just have a small example on this, right? So what I can do, I can just demonstrate this. So let's say we got this class known as finalize demo, right? And I'm just gonna make this method finalize over here. So I'll say CISO object finalized, right? So here we go. Now what I'll do, I'll create the object of finalized demo. So I'll say finalized demo, fd reference assign new of finalize demo. So here we created an instance, and thereafter I'll say fd ref to go as null. It means it is not pointing to anything now. So later I'll say system.gc. So gc is called to the garbage collector, and it's gonna destroy the objects which are no longer required. So now you can see over here, so let me run it as a Java application. It says object finalized. Why is it coming? Because it's acting as a destructor call. So anything which you want to do before your object is removed from the memory, right, you can write it into the finalize method. All right, so let's go to the next concept. It's a difference between string buffer and string builder, right? So before we jump on the string buffer and string builder, we must understand they are both similar concepts when they are compared with the string class. So string is immutable version, whereas string buffer and string builder, they are the mutable versions, right? So let me define this part, what is meant by mutability versus immutability. Consider you got this string str1, which is a new string having hello, and you got this one more guy known as string builder. You say builder sign new string builder, and you mention hello. Similarly, you say string buffer. Let's take this guy as a buffer. You say buffer assign new of string buffer, again hello. So I have taken up these three strings, let us say str, builder and buffer. And now what is next? I will be appending the data in these strings now. So you say str dot concat. So in string you need to say the function as concat. So I'll say hi, and similarly let us concat it into the buffer and the builder. So I'll say builder dot append. So in the builder, the function which we use is append, and same goes with the buffer. So buffer and builder, they are quite similar now. Later, when I'll do a CISO on str, and similarly the builder and the buffer part, let us say builder and then finally the buffer. So the buffer here, we run the code. You see one major difference over here is that you get hello. So nothing happens when you concat the data into the str, right? But in case of builder and buffer, the data is concatenated. This is why, because strings are immutable, whereas buffers and builders, they are mutable. This is also one of the very beautiful query, first of all. So guys, buffer and builder, they are the mutable sequences, whereas string, it is immutable. You cannot change it, even though you are going to perform an operation. So what is happening over here, whenever you concatenate the data, you will be getting a new string, right? So you need to store the data into a new string. So concatenation results the data coming out as a new string. The old string is not changed. So significant difference between buffer and builder now we'll be discussing. String buffer operations are thread safe. So it means that by default, when you are going to use buffer, it will be synchronized. You need not to worry on top of multiple or concurrent threading now. Whereas builder, it's not thread safe. String buffer is to be used when multiple threads, they are going to work on the same string, whereas builder is supposed to be in a single threaded environment. Other than that, builder is quite better as compared to buffer over the performance part, because there is no synchronization overhead. So you can just try to write out this snippet over here, which will be able to help you to come up with the timing difference, and you will be able to see that builder will outshine the buffer in terms of performance. All right, so let us understand the difference between heap and stack. So stack and heap, they are two memories which are very much famous when you talk about the Java runtime, right? So Java runtime, the RAM, we got these two major data structures, stack and heap. So first of all, let us see how the stack and heap will come into action, right? So let us take one example, guys. So I'll just remove these snippets. All right, so let us understand the stack and heap into action. When we are talking about the RAM allocation, so this RAM will be divided into two parts. The first part is the stack, and the other part will be the heap. So this circle is representing the heap memory. So both of them are a part of RAM now, right? So both the data structure, they are part of RAM. We got stack and heap. So let us understand this point of stack and heap, how the data will be stored and where it will be stored. I'll just take up one basic example from the Eclipse now. Whenever you will be creating an object, so for example, finalize demo, I said fd-ref assign new finalize demo. This is known as object construction statement, right? So this is object construction statement. So here what we are doing, we are trying to create an object with the help of new operator. And to be very much more precise, I'll take one class like point, right? And we'll define some x and y as attributes within this class point, right? And I can have one function like show point, which can just display me the data of point. So I can say point is plus the value of x, let us say a hyphen plus y, right? So that's like a point now. So how I'll be creating the object of point now? Same way you created the finalized demo, you say point p1 reference assign new of point. So how this statement will be represented in the memory? So guys, for this statement to be represented in the memory, what will be going into the stack, what will be going into the heap? Let's have a close look onto that part now. P1 ref over here will reside into the stack like this, right? So this guy is P1 ref. It will be created on some memory location. So let us assume it's 4001. It will be a hexadecimal address, but I'm just assuming it to be one address over here as 4001. So this memory location, this container P1 ref is created out over here. What is next? The next part is an object which will be constructed in the heap, which will have two compartments. The first compartment is your attributes, that's like x and y, and the second compartment goes like the methods show point. So this is like the attributes, and the second compartment is for your methods. Now what is happening over here? So this object has no name now, right? So this is having no name on the heap. You don't have any name for this guy, but you can definitely have an address over the memory. Let's say this is 6001. So this object is constructed at 6001. So P1 ref will have the address of your object, and this guy P1 ref is doing nothing, but it is pointing to this guy 6001. So we say P1 ref as a reference variable because it is referring to the object available at 6001. It's not a kind of a pointer now, right? In order to prove this concept, we can just say sys out of P1 ref. When I will do a sys out of P1 ref, let's say P1 ref is plus the value of P1 ref. Now I'm going to run the code. You will understand that P1 ref over here is showing me some address of an object of type point, right? Since we got in the package code.edureka, so it says that code.edureka.point at memory location. So this is the memory location 7852E922, which P1 ref is holding for your object. So now once we are good to go, what is available in stack, what is available in heap for this instruction, right? So guys, anything for which you use the new operator, that will be constructed in the heap. So heap is that memory location where we use the new operator, and new operator is used to create the things dynamically. When I use the word dynamically, it means at runtime. It means anything which is constructed dynamically at runtime in your program, it will reside in the heap, right? So that's what the new operator will help us to do. Now let us have some more differences between stack and heap. So guys, stack memory is used only by one thread of execution, whereas heap memory is used by all parts of the application. If you talk on the access level, objects stored in the heap are globally accessible, whereas stack memory cannot be accessed by the other threads. Memory is like LIFO, whereas the heap memory is basically the tree structure now, right? So the memory management is based on the generation associated to each object. So here what we try to store the data is in the form of key value pair. So each and every object will have a hash code now. So that acts as a key for your object. When you talk of the lifetime, so we got existence until the end of execution of the thread, whereas heap memory will live from the start till the end of the application execution, and your garbage collector can anytime free this memory space. If you talk of the usage now, when an object is created over the stack, so now please guys, in case of Java, every object is dynamically constructed, so there is nothing like objects being constructed in the stack, right? So we are just giving a general overview of heap and stack over here, not typically inline to your Java. These are the general differences now. In Java, your each and every object will be constructed dynamically in the heap space, not in the stack space. So in the stack space, you will be getting the references to the objects now, right? So guys, whenever an object is created, it is always stored in the heap space, and stack memory only contains the local reference variables which are pointing to the objects in the heap. So let us move towards the next basic question, that's like the difference between the array list and a vector. So these are the two data structures. These are the two collection APIs in the java.util package. So both of them are quite same. The very major difference is that array list is not synchronized, whereas vector is synchronized. So guys, when your data structure is not synchronized, so the performance will be a bit more better as compared to the other one. So that's why your array list will behave faster in terms of performance as compared to your vector. If an element is inserted into the array list, it increases the size by 50%, whereas vector, they don't do it so, but they just double the size of its array, right? And array list does not define the increment size, whereas in the vectors you can define how much size the vector should increment when it has reached its limit. Other than that, array list can only use iterator for traversing, whereas in vector, right, except hash table, vector is the only other class which can use enumerations as well. So you can enumerate over the vector. With the help of enumerations, we can also, iterate within the vector. So that's like some of the differences which are highlighted over here. Similarly, the other collections, hash map and hash table. So this is again a relevant question which is asked in the interviews many a times as a basic question. So hash map and hash table, again, the first difference is the synchronization, right? And your hash tables, they are synchronized, whereas hash maps, they are not synchronized. Hash map allows a null key and a null value, whereas hash table will throw a null pointer exception if you will try to add a null key or a null value. Other than that, since a hash map is not synchronized, it's gonna behave faster as compared to the table. And we can make the hash map as synchronized by calling the collection synchronized map API. So it's not like that we cannot mark the hash map as synchronized. We can come up with our own logics as well, right? So guys, hash map traverse can be done through iterator, whereas table can be enumerations as well as iterator. Hash map will inherit abstract map class, whereas hash table is totally working on the dictionary class. Now the next concept is the difference between equals and equal to operator. Now this is one, as a new Java developer, many times we'll do this big mistake by comparing the strings with the equal to operator. So unlike your other languages, here you need to use the equals method to compare the strings now, right? So guys, let us understand this concept first of all. I'll just try to demonstrate it by writing one example. So let us say you got one string str1 as new string. So just recently we had this discussion that this is an object construction instruction. So str1 is a reference variable, whereas the string object will be constructed in the heap. So str1 is having one address, right? So let me write down this thing. str1 is a reference variable. It is having the address of an object. Similarly, I'll create one more str2, right? So str2 is also a reference variable. It is having the address of some other object. The difference over here which we need to understand is that there are two different objects which are containing the same value hello, right? So objects are containing the same value hello, and str1 and str2, they are the two different references and having the different values. So that's why if you're gonna compare it using equal to operator, right, so it's gonna say str1. Let me just finish out the program, and in the else part I'll just say not of equal to. Right now you will observe that str1 is not equal to str2. The reason is very similar because you are comparing references now. So double equal to, we are comparing references, right? So that's one important difference for us to understand. Now when you need to compare the objects, you don't use double equal to. Instead you use this method known as dot equals, right? So you say let us compare the strings using equals method. So here I'll say equals and not equals. So we don't compare strings using the equal to operator. That's very risky. It's one big mistake. You compare the strings with the equals method. Equals method is not comparing the references, it is comparing the values within the objects, right? So that's what we are able to understand, comparison of references versus comparison of values. So you can take up this program, guys, over here. If you can see, right, just go ahead and try to run this execution. We got one more program over here. Let us predict the output for this program. So in the main method, you are calling the method 1 with the input as 11. So you pass this 11 over here. From here you are invoking the method 2 by passing 11 into 11. And in the method 2 you are passing method 3, which is division of 11, and then in the method 3 you are subtracting 11, and finally in the method 4 you are adding of 11. So guys, finally you will be getting the result as 11 itself, right? Because 11 into 11, it's gonna be 121, divide by 11, it's gonna be 11, minus 11, it's gonna be 0, plus 11, it's again gonna be 11. So try out this program, right, and see to it if you can get the same output or not. So these are some of the basic questions, right, highlighted by us, which are very important and crucial from the interview perspective. Next we'll be jumping on to the object-oriented programming structure. Now this is one key area which company or an interviewer is looking and expecting. As a developer, you should be quite good on these concepts, because the advanced concepts or any of the application development model, it relies heavily on object-oriented programming structure. So let us see what we can have in the object-oriented programming structure. So the very first question, as in question number 12, is the difference between abstract classes and interfaces. So let us see some of the differences. Again, guys, this is quite theoretical information, right? But I would like to take one very small demonstration on abstract class versus interface, because it is very important to have a very fair knowledge, and this concept is linked with your runtime polymorphism. So let us understand this concept. So I'm going to create one class shape, and we'll have this method known as a draw, right? So let's have a draw method, and you say so drawing a shape. Now this is something which even we teach in the traditional language like C, C++, I mean native languages. So this is the same concept carried forward. We got a shape class and we got a draw method. So what you're gonna do, you're gonna create the object of shape s assign, or let us say shape s, and then say s assign new of shape, and then you can say s dot draw. So the output is very much simple. You get the method drawing a shape. But I want my shape to be either as circle, rectangle, or polygon, right? So what I will do, I will just come up with a class known as circle. So I'll say this guy's circle shall extend something known as shape, right? And in a similar way, I'll also try to come up with something known as rectangle. And lastly, I'll say a polygon. So shape has 3 children now, and each and every child will be redefining the draw method with the respective shapes, right? So here we are. Now this is very well understood that whenever you're gonna redefine the method, so the concept of overriding will come into action, right? So this is overriding. And now if you say circle C and C assign new of circle, and you say C dot draw, you will always get drawing a circle because overriding has come into action. What I want to do, I don't want to do this concept, right? It's a basic concept now that whenever you will create the object of child, always the definition of child will come into action as a concept of overriding. What I want to do, I want to say reference variable belongs to the parent and the object belongs to the child. Now this is known as polymorphic statement. So how it is a polymorphic statement now? The guy shape S is pointing to circle. So shape is now behaving as circle. Let us assume that. Now this instruction is equated. It's very well equated. The equation is true. Reason is that circle is also a shape. Circle is a child of shape. So technically their type is same now, right? So I'll say S dot draw. So I'm saying S dot draw. What you're gonna observe is you get drawing a circle now, which is very well true, because there are two definitions. One belongs to the shape, other belongs to the circle. And when you say S dot draw, you will be getting drawing a circle. So you will be giving the preferences to the children over here, and the parents definition, they again gonna get overridden. What I'll do now, I'll say S is now a new of rectangle, right? You say S dot draw, and then you say S is new of polygon, and then you say S dot draw. So every time you are able to achieve S dot draw, drawing the different shapes, right? So this is what we call as in runtime polymorphism. The same method draw over the same reference variable S, we are able to draw different shapes dynamically at runtime. So guys, this beautiful concept is known as runtime polymorphism, right? And what we need to understand from here is that the guy draw in the shape method is useless. Having this concept over here that S is a new shape, so having the object of shape and executing this guy S dot draw makes no sense. It's not a pretty good sense, right? Drawing a shape makes no sense. Shape has to be circle, rectangle, or the polygon. So what we need to understand from here is we need not to have the object for this class, and we need not to have the definition for this guy draw. So you can change the architecture of your program, and you can bring down one more class shape, mark this guy as abstract, and mark the method within your class also as abstract. So an abstract class is a class for which you cannot have objects now. You can't create the objects, right? So here you can see it's an error. Other than that, the method can also be marked as abstract, which means you need not to have definition. So guys, when a class is marked as abstract, you cannot create the objects, but runtime environment will create the object, right? So see, so I say shape is constructed. Very important difference which I'm going to highlight today. So when you say the constructor over here, right, so you are able to create the constructor. It means the objects can be constructed for the shape, but you cannot create it. Runtime environment will be able to create that. You cannot create. If you will try to create it, it's gonna give you an error, right? So the same problem statement is solved. Drawing a circle, drawing a rectangle, drawing a polygon, but before the construction of the child object, the parent object is constructed by the runtime environment. So we say this is object to object inheritance, right? So what is happening over here? Inheritance is happening over here from object to object. So the parent object is constructed by the runtime environment, and then the child object is created. So abstract class is a class. You cannot create the objects, but the runtime environment can do so, and it can have abstract methods which have no definition. So no definition for this guy. Who has to define this guy? The child has to mandatorily define the definition for the draw. So if the child is not defining the draw method, it's gonna throw an error. So let's try to see this. So you try to comment out this code, you can see now it is giving you an error. So if there is n number of abstract methods in the abstract class, you need to redefine them in the children. Now we can understand this part, that this shape has helped us to improve the concept of runtime polymorphism. But this is again, which is like a parent is writing some rules which are supposed to be defined by the children. Now there's a relationship known as parent and child relationship. So abstract class shape is, when extended by the circle, it's a parent child relationship. For example, the parent is just making a rule that breakfast has to take place at 8 a.m. in the morning. Now the children, they need to define this rule, and they can come up with their own definitions. Okay, we'll come up with a breakfast at 8 a.m. but I'll have snacks, I'll have bread and butter or anything, right? So that's like a parent and a child relationship. And from basic shape class, we came to an abstract class shape with some, you can say there were some problems over here, that we didn't want the object to be coming up and we didn't want the draw method to take place, right? So we achieved a better way of coming up with runtime polymorphism through abstract classes. Now I'll come up with the best way. So I'll say one interface shape with the method as void draw. So guys, this is the best way to achieve runtime polymorphism now. So what I will do, I will not say extend shape, but I will say implement shape. Now this is the difference which we must observe over here. So rather than doing an extension, I am doing an implementation. And in the interfaces, by default, the methods are public, abstract. So it is by default like public, abstract, void draw. And in the interfaces, if you will observe now, so this constructor is significantly an error. It means that neither you nor the runtime environment can create the objects of shape, right? So it's an error, right? So for the interfaces, neither you can create the objects nor runtime environment can create objects. It means this is not object to object inheritance. There is nothing like parent and child relationship over here. What is the problem over here? This is the kind of traffic police, or the police department is imposing the rules on us to wear a seat belt, and now we need to define that rule, right? So traffic police is imposing a rule to follow the traffic lights, and it is up to us that how we define that rule. So it's not a parent and a child relationship kind of a concept. It's not parent object and the child object concept, right? I hope you got the example and you are able to correlate the fundamental between the interfaces versus the abstract classes. Now, since this method is by default public, so in order to redefine, you need to always have a higher access or the same access, right? So this is how you have achieved one more refined way of runtime polymorphism, right guys? So what we have understood, let's come back and now summarize the whole concepts. So abstract class and interfaces, they are the two different concepts, but we can accomplish runtime polymorphism with both of them, one being the parent, other one being one implementation, right? So guys, an abstract class can provide complete default code or just the details that have to be overridden, whereas interface, it will not provide any code. So it's just the signature. There cannot be any definitions in the interfaces, whereas abstract classes, they can have the definition. So we can only extend a single abstract class, whereas a class can implement several interfaces. So this is not multiple inheritance, it is multiple implementation, right? Moving ahead now, abstract classes can have even regular methods, whereas interfaces they cannot have. Now the instance variables in the abstract class, they can exist, but an interface, it cannot have any instance variables. Its variables are by default static variables, right? In abstract classes, you can use public, private, protected, so on and so forth, whereas in interface, by default, the visibility is public or none, right? So it is by default public somehow. If you mention nothing, it is by default public now. So here we can have constructors, here you cannot have constructor. It means that you don't create the objects, but runtime environment will create. Here neither you can create nor the runtime environment can create. Now, abstract classes are faster as compared to the interfaces. They are slow because it requires extra indirection to find the corresponding method in the actual class, right? So that's what we got, some of the theoretical differences after the practical implementations. So polymorphism, I hope, is now very well clear, right? So guys, polymorphism means more than one forms, where a mobile phone can serve the purpose of camera, remote, MP3 player, and alarm clock, so on and so forth, right? So polymorphism can be characterized into two parts. One is at the runtime, one is the compile time. So guys, runtime polymorphism is where you are coming up with this parent and a child relationship. Again, we saw this map example: shape, circle, polygon, and rectangle, right? So what happens in the runtime polymorphism, you create a parent class and then you create a child class. Child class must override the method of the parent class, and thereafter you do an upcasting by saying the reference variable of the parent can point to the object of child. And whenever you will execute the method, you will be able to see the method execution happens for your child. So what is the difference between overloading and overriding? So guys, overloading is concept linked with the compile time polymorphism, whereas overriding is linked with the runtime. So in the definition part, method overloading means that the same method name should have different inputs or the different arguments, right? Every time they must be different now. So in method overriding, the signature should exactly be same. So here return type will not make any difference, but here everything should be exactly same. If you talk of the behavior, method overloading is basically adding or extending the method's behavior, whereas overriding is changing the existing behavior of the method now, right? So here we are trying to add the functionality, here we are trying to change the functionality. So compile time polymorphism versus runtime polymorphism, different signature versus same signature. And when you are talking of the inheritance, it may or may not need inheritance in method overloading, whereas overriding is only linked with your inheritance. So this is one significant difference, guys, if you can see, right? So this we have already observed the overriding part, but in the overloading part, if you can see over here, the add method with the two inputs of type integer and two inputs of type double. So this is one significant example, right? So guys, this is like overloading and this is like overriding, right? So you can just, I think this is done wrongly. So overriding is this example, overloading is this example. All right. So if there is any method which is private or static, so can you just try to override such a method? So guys, the answer is no, you cannot do so. So private method will not be inherited, so it makes no sense to override it or to redefine it. Whereas static method, it belongs to the class, so you cannot override a static method, right? So it's basically what we call it as in a class to class overriding, which is known as hiding, right? So here the concept is known as hiding. So if there is a static method in the parent class, and if you want to create a method in the child class to override the static method, it should also be static, and that concept will be referred to as hiding now. So what is multiple inheritance and does Java support it? So guys, multiple inheritance is one class extending more than one classes. So this is not supported in Java. So if you can see, there is a diamond problem which comes into action, that if there is a class A, right, and B and C class, they are inheriting the A class, and there is a class D which is getting inherited from B and C. So two copies of A will be coming into the last class. So this kind of problem is not solved in the Java. It needs the virtual concepts to come into action, since there are no virtual keyword or any other pointer support available in Java. So we cannot solve this problem now, right? So Java multiple inheritance is not supported. So one more query now over here, right? What will be the output of this program? So if the parent is having this method foo, which is marked as static, and one method bar, which is a non-static method, and there is a parent-child relationship where we are hiding a method versus overriding a method, and you are executing these method calls, right? So guys, the output will be, so since if you can see over here, so this parent.foo and child.foo, then parent.bar and child.bar, right? So you'll be able to get all these four outcomes. I am foo in super, in child, then child, and then child, right? So just try to execute the code and get the behavior. Similarly, we got one more program. So guys, this is where we got multiple constructors, and you created the object for the A. So by default constructor will come into action, but this over the reference function call will execute the constructor over here, and this over here will execute the constructor over here. So you will get how are you, then hello, and then the hi, right? So this as a constructor execution will happen over here as a function call. So you'll get the output in the reverse order now. Right, so one more program, guys. What's going to be the output for the program? So it's basically one miscellaneous program where you got a block and a static block. So guys, a block is executed when you create the object of a class, whereas static block is executed when the class is loaded into the memory. So the idea is to define you guys the role for the static block and a normal block. So a block over here, if you can see, is executed when the object is constructed, and static block is executed when the class is loaded into the memory. So just try to run this program and come up with this output, guys. Alright guys, so now let's understand servlets, right? So this is where we're gonna pursue with the enterprise edition concepts of Java. So we have left out the core part of Java, and now we are moving into the advanced part of Java. So servlets is also one of the core concepts when we talk of the enterprise edition of Java. So let us understand what exactly is a servlet, right? So that's like, what is a servlet? So servlet is one Java program which is executed over the server. Now that's like one very basic definition to what exactly is a servlet. So what happens now, whenever you're writing an enterprise application, you need to have some code which is executed by the server. So if the client is sending a request via HTTP or the HTTPS, request will come to a server, and the server will execute your Java program, and it's gonna send back the response to the client. Now the client can specifically be browser, or it can be a mobile application, or any other kind of a client, guys, right? So Java servlet is a server-side technology which will extend the capability of web servers by providing support for dynamic response and data persistence. We got Java X.servlet and Java X.servlet.http package, which provides the various APIs for writing the servlet program. Now, any servlet program should implement the servlet interface along with the lifecycle methods where you can manage your code snippets. As most web applications, they are accessed using the HTTP protocol. So we got a class known as HTTP servlet, and we got a corresponding hierarchy for the same. So over the web, we use two of the major methods. One is the get, one is the post. So what is the difference between get and post? So guys, get and post, we got two major methods how we can send a request from a client to the server. Other than that, we also have various other methods like put, delete, trace, so on and so forth. So these are the two important methods. Get is when you need to have limited amount of data which can be sent, right? Because the data is sent as a part of URL now. So post is when you have a large data and you need to send it across the body. So it automatically comes up that the data is not visible as a part of URL, and it is more secure in terms of post request, right? So security is more because the data is not exposed in the URL. Other than that, you cannot bookmark the post, but the gets can be bookmarked. We got idempotent versus non-idempotent. So guys, what is idempotent? When you send a request, you get a response. You again send a request, you again get a response, and you compare the two responses whether they are equal or not, right? So idempotent. So this guy get is more efficient, right? And it is more used than the post, right? Where now it depends, right? So efficiency is like get is more efficient undoubtedly, but it depends upon a requirement where you need to use what. Okay, so let's say you want to do a sign in. So obviously we need to send the username and the password to the server, and you cannot send it across the URL. Even now you can send it, but you need to encrypt the data before you send it, right? So that's like the differences between get and post. Now what is meant by the session management, right? So guys, session is one term which means the time interval between the client and the server. So we have techniques to manage the data within the session. So that's like the session management now. So what are the various methods? So number one, we got the user authentication, then the hidden form fields, cookies, URL rewriting, and we got HTTP session API also to manage the session. So session is a conversational state between the client and server, and it can consist of multiple requests and responses between both of them. Now HTTP is a stateless protocol. You cannot manage and maintain the state, so that's why we need to use some fundamentals through which we can come up with this, right? So guys, every session will have a session ID which will be passed between the client and the server during the request and response, and you can use various different techniques. So to name few, we have mentioned them, right? Now we also have two APIs known as servlet context versus servlet config. So what is the difference over here? So servlet context and config is where we need to extract the data which is stored somewhere as in part of your web.xml deployment descriptor. So we will consider that part now. So servlet config is a single object where servlet context is on a global level now, right? So it's like a local parameter associated with a particular servlet, whereas we got a global parameter. So both of them are the key value pairs, right, mentioned within the web.xml file. Whereas servlet config, so you mention the data within the servlet, whereas servlet context is mentioned out of the servlet tag. In the servlet program, you can use the APIs get servlet config and get servlet context, and thereafter on the basis of the key you can retrieve the data, right? So for example, shopping cart of a user is specific to a particular user, so you can use servlet config, whereas to get the MIME type of a file or any kind of a global level or a variable, you can use the servlet context. Now what is a possible life cycle of a servlet? Now this is really important when you talk of servlets, guys, right? So servlets, they got 5 stages when you talk of the life cycle, right? The first of all, the servlet will be loaded, then it's gonna be instantiated, initialized, then a request will be sent to a servlet, and then finally the servlet will be destroyed. So we got init, service, and destroy as the 3 life cycle callbacks involved when you write the servlet program. So you got 3 of the APIs now: init, service, and destroy. What is request dispatcher? If you want to share the data from one servlet to the other servlet evenly, right? So we got this guy known as request dispatcher, which can forward the request to the other resource. Now this other resource can be possibly a servlet or an HTML file or a JSP file, and we can do so using the 2 different methods. One is the forward method, other one is the include method. So what happens over here is when you send out the request from the servlet 1 to servlet 2, when you use the forward method, response generated from the servlet 2 will be sent back to the client. In case of the include method, response from the servlet 2 as well as the servlet 1 will be appended and then sent back as a final response to the client. Now we got request dispatcher coming up with the forward and include in these two differences. So guys, one of the important concept associated with the servlet session management is cookies, right? So what exactly a cookie is? So cookies are the textual data which gets stored on the client machine, and this data is sent from the server. So data is stored in the local machine of the client, guys. Let us see this part, right? So if you can see over here, I'll show you this thing. So when you open down the settings of your browsers, right, and you try to say cookie, right? So if you can see over here, so you get these options of cookie coming up over here. Content setting, you can see cookies. So allow the local data to be set, which is evenly recommended. So guys, cookies are the textual data which gets stored on your machine, and you from the server can just use the method known as get cookies, right, to read out all the cookies, and you can create a cookie by using the API cookie itself. It's a hash map key value pair. Cookie C1 assign new cookie with the key and the value, right? And if you want to add the cookie to the client's machine, you just call the method add cookie over the response object. So the next part is the Java database connectivity. So guys, this deals with the database connections now, right? So Java database connectivity, we got the first thing as JDBC driver. So whenever you want to create a connection, you must have a driver, right? So guys, driver is the layer which will help us to interact our JDBC APIs with the database. So there are four major types of drivers. We call them type 1, type 2, type 3 and type 4 driver. It goes like JDBC ODBC bridge driver, native API driver, which is a partial Java driver. Then if you want to come up with a client server model, you got network protocol driver. And lastly, you got the pure kind of a driver, the thin driver, the fully Java driver, which we'll be using to interact directly with the database. So Java app, it's gonna use the JDBC API, and the JDBC driver manager will interact with the driver, and drivers will further interact with the drivers for the databases libraries, and hence this whole channel of communication will be established. So what are the various steps to connect to the database in Java? We use JDBC, and there are some sequential steps which you need to perform so that we can perform all the CRUD operations. So what are these now? So there are 5 sequential steps which you need to perform. So guys, any of the database whichever you are using, right, so you need to come up with the documentation over their website, right? What is their driver class name, what is the URL, so on and so forth. Anyways, let us have a look on to the snippet now. So the first one is registering the driver, which comes through the API known as class.forName. So here you manage to write the driver, type 4 driver or any other driver which you are going to use. Then you need to create the connection, which is created with the help of an API known as driver manager. So you say driver manager dot get connection. We need to pass 3 things over here. The first thing is the URL where your database resides. So if it is on the local host, you mention the host name to be the local host, and you manage to write the port number and the database name. Then the username and the password for your database. Thereafter, you need to say create statement over the connection. Once you have created the statement, thereafter you will be able to execute any of your SQL query. But in the finally block, you must close your connections, right? So this is important that you manage to close your connections regardless of whether exception is coming or not coming. So what are the different JDBC API components? So guys, we got various interfaces and classes coming into the Java JDBC package. So we got java.sql package, and many of the libraries, if you can see, the APIs are mentioned over here. So in the interface part, we got connection statement, prepared statement, result set metadata, database metadata, and callable statement. So all these are the interfaces. So connection is used to have a connection statement to execute the SQL statements. Prepared statement is also used to execute the SQL statements, but prepared statement is different from the statement in terms of how you are going to substitute the data into the SQL statement. So here we use something known as wildcard characters as question mark, right? Result set is the retrieved data from the database, and the data about the retrieved data is known as the result set metadata, and the data about the database is known as database metadata. Callable statements are used so that you can execute the stored procedures of your databases. And some of the few classes which are mentioned in the right hand side, it includes driver manager, which is used to get the connection. So blob and clob are the two APIs where you can manage the binary large objects and the character large objects. So binary large object means the audio files, the video files, right? Whereas clob means the textual files. Then the type will define what are the various types. SQL exception is exception in the JDBC. If there is any connectivity issue or any other syntactical issue or any different kind of SQL issues which gonna occur at runtime, so SQL exception is the class to get the error from. Now, what exactly a JDBC connection interface be, right? So guys, the connection interface is the one which will maintain a session with the database. So here we can use the transaction management logic, which means atomicity. So atomicity means that all and everything should happen at once. So let us understand. So connection is one important interface with the help of which we can manage the transaction. For the transactions, let us assume I want to transfer the amount from one account to the other account. So there needs to be two possible SQL statements which are supposed to be fired. One will be the updation in my account, that will be deduction of the payment. In the other account, again an updation query which will be the addition of the payment. So these two queries should be fired at once, and if any one query fails, the other query should be rolled back. So for the transaction management via the connection, you create the statement, and thereafter you can come up with the auto commit API where you can mark it as true, and then you can use the APIs like commit and rollback to manage your transactions. So close is a method where you are able to close the session with the database, right guys? So there is one more possible difference between three of the APIs, that's like execute, execute query, and execute update. So guys, execute query, execute update, and execute, these are the three different APIs. All the three APIs are used to perform the SQL operations over the database, but query method is always focused to do a retrieve operation. If you can see now, select operation, right? So whereas your execute update method, it's gonna perform the DML and the DDL operations, insert, update, delete, create and alter of the table, right? Whereas execute method, it is able to perform any kind of operation now. So this is typically used to retrieve the data. Here the data can be modified, whereas execute method, any kind of SQL statement. Return type of these methods, they are different now. So result set will be returned from the execute query method. Here we will be getting some integer output, and here we'll be getting some Boolean output. This method is used to execute only select queries, so non-select queries, and here both the select and non-select queries. Right guys, so that's like the JDBC part, right? So how we got various APIs available in the Java database connectivity, but we need to come up and understand there are the 5 different steps. So you start from loading the driver, then creating a connection, writing the statements, executing the statements, and finally moving on to the closing of the statements. So the next part is the framework of frameworks, that's like the Spring framework. So if you know this, if you have a hold on your Spring framework, guys, so it's like you are done with almost everything now, right? So one of the most important framework in the enterprise edition of Java. Let us see what is Spring framework. So what exactly is Spring, guys? So Spring is an application framework which focuses on a concept known as inversion of control for the Java platform. So many of the great technologies, they are built looking on to the architectural model of the Spring framework. Even the Android, how the UI part is linked with the layout part, so that concept is again adopted from the Spring pattern, right? So it is one of the pattern which focuses on IOC, that's like inversion of control. So the framework's core features, they can be used by any Java app for building an enterprise edition application. One of the major advantage of writing a Spring framework app is it's lightweight. It is having an integrated framework architecture where we can use it to develop any kind of an enterprise app in Java, right? So it's less on a memory, it's high on performance, and it contains various frameworks available within it through which you can write a multi-purpose enterprise application. So guys, what and all are the modules available in the Spring framework now? So Spring framework has various modules. To start with, we got the very first layer as the core container. If you can see this core layer, so whole of your Spring framework is dependent on this core layer. So this core layer focuses on something known as inversion of control and dependency injection. So we got this as Spring context dependency injection. Then AOP is aspect oriented programming, which focuses on how we can fulfill cross-cutting concerns. Then the database module of the Spring framework includes DAO, JDBC, and ORM, as in the design patterns. So DAO, the data access object. So here we can write the DAO patterns to access the database. We got JDBC support. We also got the Hibernate or the ORM support, which is object relational mapping. The web module of the Spring framework can help us to write the web applications, where Spring MVC is one of the majorly used frameworks in the market now. So model view controller, where model represents the data container, view represents the UI or the presentation, and controller represents the business logic, as in servlets now, right? So Spring MVC is one of the very important concern when it comes to develop the web applications, and we got various web services coming out in this module itself. Let us move on to some annotations which are used in the Spring configuration. So guys, there are various annotations now which are used in the Spring framework now. @required, right? So it's like what is the input which is required. Auto wiring for your dependency injection. What happens pre-destroy, what happens post-construct, right? So before the object is finalized, just after the object is constructed, what is the resource, what is the qualifier. So these are some of the Spring annotations which are used for the configuration purpose. So what is bean in Spring and what can be the different scopes of the bean in the Spring, right? So guys, I'll take up one very a basic example over here to mention this concept, right? So let us take one example. So I got this Spring demo available with me with all the jar files available out here. We got this employee bean.xml file. So just give me a moment, right? So all right. So here you can see now we got this employee bean. So this is one XML configuration for the Spring framework. So we got core.edureka.employee as a class, right? And here what I am able to do is to define the property value tags for my bean, right? In the employee.java, I can say it's basically a bean or a pojo. So what is a bean class? Bean class is a class which will have the attributes along with the setter and the getters, right? So all the setter getter methods are also there. In my client class, what I am going to do, I'm just gonna use this Spring container, and thereafter I will just extract my employee object, right? So just let me do this part. All right. So I got the reference of the employee bean.xml, and in my class I got this emp bean1. So I'll just say emp bean1, and thereafter I'll do a CISO of right? So let's try to run the code, and you can see that the data over here is coming up as in ID, name, and salary, right? I have just overridden this toString method out here. So along with this, I'm also supposed to do a super.toString, right? I'll do a \n and a super.toString. So now it will show me the data within the object as well as the reference variable m is pointing to the address. It is showing me the address as well to the object now. So the bean is extracted from the Spring container, right? So there are various scopes available now. For example, same m bean1 in my client, if I try to get it again, right? So let us try to say get of bean again, right, as in emp1 and m2. Let us say this is m2 and this is emp1, right? So I will closely observe one difference, I mean one similarity, that every time when you request this guy get bean for the m bean1, you are able to receive the reference to the same object. Scopes of the bean can be mentioned over here using attribute known as scope, and here now I am going to mention it as prototype. You can see we got this guy as a prototype. Now when I run my code again, you will find one significant difference, that here the reference is coming out to be different. It means now by default it was giving me the singleton as a design pattern, but when I change the scope to prototype, every time I am requesting the object of m bean1 from the Spring container, it is now constructing a new object and returning it back to me. So guys, this is what we got as in what can be the scope of your bean in the Spring. So inversion of control container can have various scopes now. Singleton means only single object, which is by default. So prototype means you can have every time a new object. Request means one object per entire request. Session means one object per entire session, and global session means one object per entire global session on an application level. So how is a bean added to a Spring application? So guys, you use this tag known as bean. You mention the ID, and then you can have the properties as in key value pair, right? So what is the role of dispatcher servlet and context loader listener? So guys, dispatcher servlet is acting as a front controller in the Spring MVC. So many times I will call it as a receptionist now. So what happens, any request when it's gonna land up to your web application, so this guy dispatcher servlet will dispatch the request to the corresponding resource available on your web application. So it's gonna act as a receptionist in your program now. Whereas context loader listener, it's a listener which will give you the event callbacks when the context will be loaded. It's like startup and shutdown of the web application context in the Spring root. Now, what is the difference between constructor injection and setter injection? So before you come up with the constructor injection and the setter injection, you must understand what is dependency injection. So guys, let us understand this flow once again. I am having one class as employee, right? And there is one more class known as address. So employee can have the name, employee can have some salary, there will be definitely one employee ID, and employee can also have an address, right? So I'll just say an address to be as ADRS. So what we can do, we can create one constructor of an employee in this way, right? And here you can say EID goes like 101, name goes like, let's say, John, salary goes like 30,000, and address goes like some new address, right? Where address can have some address line, then you can have some city, you can have a state, and lastly we can also have some kind of a zip code. Just mentioning some parameters over here. Now what will happen over the client part, you will be writing employee assign new employee. So whenever you are creating the object of employee, this becomes the concept that the constructor of the employee will create the object of the address. We can see a significant dependency now. When you are creating the object of employee, within the constructor of employee, the object of address will be constructed. We say this concept as high dependency, or you can say we got a higher value of coupling. Now we need to reduce it, right? So you need to bring it to the lower level. So you need to take it as a low coupling. So what I will do, I will not use this technique. I will say, let us create one more constructor and pass the address as an input, right? And thereafter you can say address assign AD. Or you can create a setter, you can say set address, and you can say address, and here you pass this guy. So guys, in these two approaches, rather than having a single employee object, you can now create an employee object. You can create address objects separately, right? You need not to be dependent upon the employee object, and later you can pass the address object. Or you can say employee E assign new employee and E dot set the address, and you can pass this guy A. So we want to reduce the dependency, or we want to come down with the coupling parameter. We created this logic out here. So setter injection and constructor injection are the two terminologies linked up in order to justify these two terms now, right? So let us open up our presentation once again and look on to constructor injection versus setter injection. So there is no partial injection, so setter injection can lead to partial injection. Here we need not to override the setter property, but here the constructor property, in case both the things are defined. So you can create new instance if any modification occurs. So you need not to create any instance if there is a property change. So better for too many properties, better for few properties. So guys, depends upon your choice, but constructor and setter injection, they are the two key concepts to bring down your dependency to the lower levels. Now, what is auto wiring in Spring? So many times when we are writing this dependency injection programs, you can perform these injection programs based on the names, right? For example, you can mention this auto wiring tag and you can say by name. So you need not to now write an explicit injection logic. It will be mapped automatically for you. So there are various modes through which you can have an auto wiring coming into action. So no is the default mode. It means you don't specify the auto wire. It means here nothing is enabled, so auto wiring is not enabled. So when you mention by name, it means you take the setter method and you map the data corresponding to the name. By type will use the type of the attribute, and constructor will inject on the basis of the constructor. So how can we handle any exceptions in Spring MVC framework? Right guys, so there can be exceptions now when you are writing the program, right? So Spring MVC framework can help us to achieve robust programming concept through these possible ways. Number one, controller based. So you can define an exception handler method in your controller class itself. You can have a global exception handler where exception handling is a cross-cutting concern through AOP, right? And then you can have a handler exception resolver. So any Spring Bean which you have declared in the dispatcher servlets application context, that can implement handler exception resolver, which can thereafter be used to intercept and process any exception which occurs in the MVC system, and it is not handled by the controller part. So you can use the various different concepts out here. If you can see @exception handler annotation, so that you can specify that this view will be used to display some error. All right, so some important annotations again in the Spring framework, guys. we got @controller, @path variable, qualifier, configuration, scope, request mapping, response body, auto wired, service, and aspect, right? So all these annotations, they are quite important concepts and you must have a fair knowledge on all these, right? So for example, @auto wired, so either you can configure it in XML file or you can use annotations. So XML files, they come up with the inversion of control concept, whereas annotations, you need not to have XML files, you can use them directly. All right, guys. So lastly, in the Spring framework, we can also have Spring framework coming up with the database connectivity either through JDBC or through Hibernate or any other framework now, right? So Spring and Hibernate, they can work together. We have some ORM modules available within the Spring framework, and we got an API known as Hibernate template. So if you want to come up with the Spring and JDBC, you got JDBC template API, right? So guys, Spring ORM module will help us to integrate Hibernate framework into a Spring application, and Spring ORM also provides the support so that you can use Spring declarative transaction management. You can use annotations and you can perform the actions now. So now we will be on our last concept, that's like the Hibernate, which is the backend framework based on object relationship mapping, right? So guys, let us see what and all we got in the Hibernate now. So the 44th question is, what is Hibernate? Hibernate is an ORM, which is object relationship mapping. It's a framework now where you just mention your Java object and you forget about your database tables. So guys, what we're gonna do, we're gonna write down some mapping files as in XML configuration files where you will be mapping that this attribute in my object in my class will be the column name in the respective relational table. So Hibernate provides a reference implementation of the JPA, Java Persistence API, right? And it makes a great choice as an ORM tool where we got the benefits of loose coupling. Now I hope you got the meaning of loose coupling, where dependency has been reduced to the maximal level. So Hibernate configures all the flexible and can be done from the XML configurations as well as through annotations programmatically, right? So it provides us both the ways now. So what can be the benefits with the Hibernate framework? So guys, Hibernate will eliminate all the boilerplate code, whereas in the traditional approach, you need to mention and write various code snippets, and you need to write the relationship mappings, the cache management. So everything is eliminated when you use Hibernate now. So this framework will provide us XML support as in through configuration files and annotational support through JPA, that's like Java Persistence APIs. Now Hibernate provides a very powerful language, that's like HQL, which is very much inline to SQL, but you need not to learn it. It's more simpler than the SQL even. Now SQL itself is very simple language. You got more simpler language than the SQL, that's like HQL. So guys, it's an open source project from the Red Hat community, and it is used worldwide and it's very famous, especially for any large enterprise application. Your Hibernate framework is one of the ideal choices now. Now, any database vendor specific feature, Hibernate is suitable because we can also execute native SQL queries. So Hibernate is not just that we can use its native APIs and you can't do anything out of the box. You got to execute the SQL queries also with the Hibernate. One of the most significant features of the Hibernate is the cache management. So Hibernate provides 3 levels of cache through which your performance of the database operations, they're gonna get improved now. So what is the architecture of Hibernate, guys? So Hibernate of having an architecture in a very simpler fashion, guys. We got a database. On top of database, we got various modules coming in. For example, Java transaction APIs, we got Java database connectivity, and thereafter we got JNDI, that's like Java naming and directory interfaces. On top of it, we got the Hibernate APIs. So configuration API will read the XML configuration file and it will help us to create a session factory. Session factory will be used to create the session, and session is one API which maintains and creates a connection with the database. Using the transaction API, you can use the commit and rollback features, and query API will help you to create one query and retrieve the data. Criteria is one API which will help you to mention the criteria. For example, you got restrictions to manage, for example, greater than, less than, all equal to. So all these are criterias when you are trying to retrieve the data. In the Java application, you just write a Pojo class, you just write a bean, and you give this object to the Hibernate, and Hibernate's APIs, they're gonna manage everything for you. All right, we got the get method and the load method in order to perform the retrieve operation. So let's see the differences. Let's say we don't have a record available in the database, so load method will throw an exception, that's like object not found exception, whereas the get method will return a null, as in the object is not found. So guys, get method will always hit the database, whereas load method will not hit the database, right, in case it's not there. And you're gonna get a real object, not a proxy object, whereas load will return you a proxy object. So get should be used if you are not sure about the existence of instance. Now, so let's say that the record is existing or not, I don't know, so you use get. If you are sure about whatever you are going to extract from the database, it is existing, you can use the load method. So there are now significant differences between Hibernate and JDBC. Guys, this is one of the major query between, as in a part of interviews. So why Hibernate and why not JDBC? What are the differences? What are the advantages that you should be opting for Hibernate? Now, if you're writing a very small app, right, you need not to go on the Hibernate level. Hibernate level is required when you're writing an enterprise app, right, where you need to save the time and you don't want to do a rework, and there are various other differences. So let's have a look onto that now. So guys, first of all, you need to write a lot of code when it comes to JDBC, whereas Hibernate, you have very limited instructions to mention, right? Hibernate supports all the association, inheritance, collection, mappings, where in case of JDBC API, you need to write all those logics. So one-to-one, one-to-many, many-to-many, all these mappings, they are available as a support in the Hibernate. Hibernate will also give you the transaction management implicitly, whereas in JDBC, again, you need to manage that part. Now, JDBC API, they will throw SQL exception, right? So it's a checked exception. So we need to write a lot of try-catch block code when you are using this JDBC, but Hibernate will internally manage this try-catch block for you. We got HQL, which is object-oriented programming, whereas JDBC, you need to write the native SQL queries. Hibernate will automatically give you the cache management for better performance in 3 levels of cache, whereas JDBC, you need to manage it yourself. So by default, Hibernate's performance is higher as compared to the JDBC part. So lastly, Hibernate will provide an option where we can create the database and the tables too, but for the JDBC, these existence should be there before you dump the data. Other than that, one of the very significant feature why Hibernate over JDBC is if you want to switch from one database to the other database, it's going to be very complicated with the JDBC. But in case of Hibernate, we got a configuration file. You just need to change the parameters in the configuration file and you will be able to shift from Oracle to MySQL or any other database to any other database of your choice. So guys, that will be all. So we just wish you all the very best, right? The team Edureka and me, Ishant. So guys, wish you all the very best. Thank you very much, guys.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!